Good morning, everyone. Welcome to the Tasmanian Biochar Forum. Running from 9 till about 4:30 today. We've got some excellent speakers, and also just wanted to acknowledge our sponsors of the event. So we've got ANZBIG Proprietary Limited, Healthy Profitable Agriculture. We've got Sustainable Timber Tasmania, and we've also got TasWater. So round of applause. Thank you for putting on this event today. This is fantastic. This is part of the national rollout of our roadmap done by ANZBIG, and we've already been to Victoria, New South Wales, South Australia, Western Australia, and now Tasmania. And then we're going to have our finish off with our national conference in Queensland towards the end of the year. So first up, I just wanted to hand you over to our Tas lead, Karen Enkelar. So I'll just get your... So Karen is from ANZBIG Proprietary Limited, and you've got a background in feed char, so you're doing animal feeds, activated animal feeds, and you've been running for about 8 years, and they've just had a very successful AgFest, I believe. So handing it over to Karen to make the introduction. Thank you. No.
Hello, can everyone hear me? Can everyone hear me? Oops. I'm very honoured to have you all here, so thank you so much for coming. My first job is to introduce our very special opening speaker, Harold Riley. He's going to help us with some open to country today. Born in Launceston in the 1930s, Harold Riley is a lifelong horse and stockman who's worked in the bush of many Australian states and territories. His book, called Don't Rush 'Em, was published in 2013. Harold says he wrote the book to impart knowledge to younger generations about animal behaviour, to try to see an animal's or a person's point of view and be sympathetic and warm-hearted to all beings. Its forward writer, Sir Graham McCamley, stated that Harold uses the psychology of kindness as opposed to handling animals as if they have no feelings or brains, but they do have both brains and feelings. So I'd like you to welcome Harold, who's going to help us with a little bit of his experience as a child in Tasmania, working with animals, and also to help us with a welcome to country. Thank you, Harold. You can stand where you feel comfortable. Okay. This one here, I think hopefully people can hear you, so let's go.
Do I talk to this thing, do I?
Can everyone hear Harold?
Can everyone hear me? You mightn't want to hear me all the time, but it won't matter about that. Thank you. Thank you, Karen. Well, folks, on behalf of my ancestors and myself, I'd like to welcome you all here today on country. I want to talk a fair bit about country today, but I'd like us to acknowledge and appreciate how country was in 1803, because it was cared for by my ancestors for thousands of years. And it was in balance. Everything was in balance in those days. Country was in balance. People were in balance. All the trees and plants were in balance. All the creatures were in balance. The ones that lived underground, above ground, the ones that flew in the air, and the ones that lived in the stream, all was in balance. Everything was in balance. But this was all done over years and years of experience with people that had the experience and passed all these experiences down. And all they had to do it with was one of these, a piece of bark, a fire stick. And this is a working fire stick, by the way. But this is all they had. And this is how they looked after country, to get it like it was when the British arrived. I'm not really proud of the way the country is at the moment. I'm disappointed. And I'm disappointed to have to get up here and welcome you to the country for what it is. I had a sort of a different early days than most people. My mum and dad, I was 18 months old when we went to live with my two great uncles and my great auntie. My great auntie was intellectually disabled, but Bill and Lou, I didn't know they were my uncles, they were just Bill and Lou to me. And it was like a little tribe, I suppose. But these people, these old fellas, I'd had every bit of my daylight and awake time I was with them. Bill used to carry me around on his back when I was a bit of a kid. And all the time we talked about country. And we talked about horses and bullocks and dogs and property, but we talked about country and looking after country. They were very keen on looking after country, and every chance they got, they would be burning. We'd often go to the mountains and there'd be little bits of burns going on that wouldn't do any damage. So that's how I was brought up. Lou was the elder, so he was the elder. Bill was the next elder. When Lou passed, Bill took over, he was the next elder. And Bill passed when I was about 20, so I had nearly 20 years of when he looked after me. And then, of course, Dad took over, and then now there's me. So where we go from there, I got no idea. Because I got no one to pass it on to, except all you people here today. And I'm hoping that I can do that. Another thing I would like to bring up is how country really was when the British came here. Coal River Valley was very, very important. That was a pretty handy place for the Aborigines here. They used to have concerts and things there. They didn't have auditorium like this. But they had to look after the country. They couldn't take their tucker with them in the fridge or anything, so they had to be there. So they made sure country was good enough and was running the livestock, or the local livestock, so they had food for these conferences. And that was in very good order. Right up through the Midlands, the Fingal, the Central Plateau was all cared for with one of these things that look after the country. And the Coal River Valley around Richmond, that country was ready for the plough. They didn't have to, it was ready for the plough. And something I want to tell you, some of you might know about this, but it was that good that they had a drought in New South Wales. 1815, 680 tonnes a week was exported to from Tasmania to Port Jackson. 1817, the farm income per capita in Tasmania was twice that of New South Wales. 1818, 12,000 sheep and 600 cows from Tasmania was exported to Mauritius. The number of livestock in Tasmania was 11,000 cattle, 100,000 sheep. A quote from a pastoralist: natural pasture could sustain and indeed benefit from traditional Aboriginal land management. 1819, Tasmania exported 54 tonnes of meat to Port Jackson. 1820, Tasmania had 182,000 sheep, twice that of New South Wales. 1830, no cultivation of introduced grasses. Cool burning was more cost effective. 1852, with the introduction of new grasses, also came the introduction of many weeds. And it was all done with one of these machines. That's how they looked after country. No, I think this biochar will help. Biochar is not a new thing. It was happening thousands of years thousands and thousands of years was working because the country was looked after with the fire stick and there was bits of charcoal and the animals took it. Now, I remember when we used to burn some of our back country, you'd take cattle there and they'd head to the charcoal where it was on stumps and things, and you could see where I didn't know they were eating it and chewing it, but that's where they were. And when we burned some of the country, unauthorised burns, by the way, back in the back country, you can notice where the wombats would be going around the stumps and getting onto the charcoal. Wasn't real obvious about the other wildlife. Now, there's thousands and thousands of acres in Tasmania that could be treated and brought back into production with one of these things and make it more effective for the carbon sinks. You all know about carbon sinks, the good and green photosynthesis takes the carbon into the soil and the root system and so on. So this is another advantage of looking after country with the fire stick, and it also reduces the fuel road. Now, as a person, as an Indigenous person, I do think of sacred sites, but to me, all Tasmania is a sacred site. And to me today, Tasmania is still a sacred site. Whoever's caring for it, whoever's got control of that country, it's all a sacred site. I don't want land back either. Why would I want my land given back to me? I've already got it. How can I get it given back to other people that don't have it? They've got control of it, but to me, Tasmania is like it was before from that point of view. All I require, and all I'm trying to do over the last 35 years since I started this campaign, is to get support from us all, our powers that be down in Canberra and down in Overtown. All I need is support from those people to try and care for country. 1818, was the last Aboriginal burn on Mount Wellington. 1843, a fire started at Mount Wellington and ended up at where New Norfolk was, with the loss of 3 or 4 lives, and I should imagine a lot of infrastructure. The Dunalley fires, if you remember, there was 47 years between those 2 fires. So it's a few years since the last one, so I would expect, I won't be here, I don't reckon, another 47 years. In another 40 years, there'll be another Dunalley fire. So to me, there's been no change in the last 200 years. No change at all. Because the country's in one hell of a mess where it's grown up, and I would not live where a lot of people live in Tasmania. You get down Taroona way and up round back of Launceston near the houses right up next to the bush. It's not a safe environment. But it could be fixed. The thousands of acres, I said, could be cared for with a fire stick, but there are thousands of acres going to cost a lot of money to make it safe for the inhabitants. But if something's not done, nature will fix it. Nature's not fussy about infrastructure or lives, and nature will fix it. So don't worry, don't think about that. I was in California some years ago, and I said to my mate, there's a hell of a mess there one day, and that it did happen. The big fire in California, as you know about. But now, just something else that you'd like me to say. I am getting some information and some inquiries, and I'm doing a bit of burning on private property, which makes me feel much better. But there are thousands of acres. I think it's all up to us. Every one of us has got the opportunity to make it so we can make it much better. I think I've about run out of talk. Thank you very much. I know. I'm got hooked up to this stuff.
Thanks, Harold.
Don't start a fire with that, right? Come on.
Big round of applause for Harold. some wonderful synergies with Indigenous communities, is what biochar has. So there's an opportunity for us to manage the land in a better way, using biochar as well. So just to introduce ANZBIG, so ANZ Biochar Industry Group, we are the peak body for biochar in Australia. I think we've established ourselves as that now. And really we are about the commercialisation of all the R&D that has gone on since biochar's discovery or rediscovery, if you like, in the Terra Preta, which is Portuguese for dark earth, anthropic soils in the Amazon. And our vision is to be global leaders in this space. And that is in fact realistic, because we currently have led the way when it comes to research with the likes of our founding members, Professor Stephen Joseph, Dr. Lucas van Swieten, and Dr. Annette Cowie at New South Wales DPI, who are all world renowned in the biochar world. So we have an excellent team. You're going to meet some more of them today. And yeah, we're very proud to be doing the advocacy work that we do. And I just wanted to point to this slide, which, next slide, please, Malcolm. Sorry, I've got the clicker, haven't I? We're getting, what did I do with that clicker? Here we go. This slide really spoke to me in the early days of my biochar journey. So it's all about the carbon cycle. So plants capture carbon, but it's not permanent. It decomposes and burns, and the whole carbon cycle is neutral, turning itself over approximately every 15 years or so. But when we carbonise biomass into biochar, we intercept the cycle and convert it into a durable form of carbon which lasts for centuries to millennia. So what is biochar and why a roadmap? We'll play this little video. Sound, please. Okay, we might come back to that. I just wanted to point out some of the resources that we have. So we've got an introduction to biochar fact sheet. So that's on our resources page. We've got a lot of information on our resources page. So yeah, biochar is one of, if not the cheapest technology CDR options the IPCC have identified to date, and comes with significant co-benefits for many industries across the economy. ANZBIG has a users report and a new farmers guide, draft for comment, document at the moment on our website, which highlights case studies with significant net user benefits, dollar value, to demonstrate business case for biochar users. We are seeking sponsorship partners on the production of the full farmer's manual in the 24-25 financial period. I also wanted to highlight these infographics on biochar for markets, application and markets for soils, and these are care of Catalyst Environmental Management with support from Southeast Water. And you can see that you would never get bored in the biochar space. There's so many applications, and you know, we've coined the phrase there, chars ain't chars. So the biochars do need to be fit for purpose for the application that you're choosing. And then we've got the non-soil applications as well, and they're sometimes referred to as biocarbons, and those, the feedstocks that may have some impurities in it, might be the more suitable for an industrial or a non-soil type application. So as far as the emergence of the biochar industry in Australia, so the inauguration was in the 2000s. R&D was at national and state levels. We have the world's oldest field trial in Wollongbar, New South Wales DPI. We had the Biochar Researchers Network, which went inactive as 2014, and then we formed ANZBIG, Australia-New Zealand Biochar Initiative, in 2017, and then out of that emerged an industry group in 2020, which is what ANZBIG is today. We have 200 plus active members, which include corporates, entrepreneurs, academics, capital and governments at all levels. We have a significant library of conferences and webinar recordings, economic reports and scientific papers by category. And we now focus on resourcing, education and communications, innovation, policy and regulations, supply and market development, and standards and certifications. 20 of our members have multi-million-dollar projects underway worldwide. And we've developed the world's first Biochar Industry 2030 Roadmap. The current industry we've estimated to be worth 50 to 100 million per annum. The current production is 10 to 20,000 tonnes per annum, but extensive expansion is underway. So we've got one of our members in Victoria who is coming online this year, and they are looking at producing about 16,000 tonnes per annum. So just doubled it, yeah. So we've also identified in the roadmap over 50 million tonnes of commercially accessible residual biomass is being burnt or landfilled in every year in Australia. So we've identified in the roadmap that there's an opportunity to scale up the industry to a net value worth of between 1 to 5 billion per annum by 2030, and production levels of between 15 to 30 million tonnes per annum. So that is the cover of the roadmap there, and these are all our sponsors. But if you want a full list of the sponsors, please go to our national rollout page. It doesn't include all of our forum sponsors to date, so we're going to be updating the roadmap shortly and releasing that. So Malcolm, unless you can get that video to play now, we might have to leave that till a bit after. How are we going with that, Malcolm? Should we move on and come back to that one? Come back to it? Yeah. So next up, I would like to introduce Melissa Rebick, who is our chair at ANZBIG, and she also works for a biochar technology provider, Metamorph Engineering, and she is a farmer as well, and also she's been a local councillor and so forth. So please welcome Melissa Rebick. Yeah.
Just bear with me, I'm just turning my microphone on. Okay, I think you've got me. Hello, everybody. It's lovely to see you all here, and thank you for coming. You're in and amongst one of the most exciting industries, I think, in Australia and globally. So I trust by the end of this day, you'll be even more enthused as I am, and I've chosen to align myself with this industry. Hopefully my slides will be coming up once we find them. Hopefully Duncan is having a look for them. It's called ANZBIG Tas, if you can find those online. Hopefully they're coming up. So I will just give it a moment. It's always the way of having these technical difficulties. So just a little bit more about my journey, if you like, while we're waiting, is that, you know, I've worked, my background is farming, and my parents were third generation farmers in livestock and cereal cropping, and I was in the southeast in an area with non-wetting sands. I then studied at university as an environmental scientist, and then went on to look at sustainable ag and did honours in sustainable ag, and then also did some business management. And then I worked at SARDI for about 16 years, working with farmers to help better manage climate risk and variability. And in that time period, you know, there was a journey in terms of even talking about climate change with state government, but also, you know, I was working with state government to, you know, support farmers to manage the variability. In low rainfall areas, they make 80% of profits in the best 3 years in 10, and the worst 3 years in 10, they make a loss. And a huge percentage of cropping land in South Australia is in that low rainfall country. But I was very, you know, quickly looking for, as a scientist, solutions to mitigate climate change. And, you know, there was very few. And I worked in that space for 16 years, and then I transitioned into my own company and started doing biochar projects, and I've been hooked ever since. I've been doing those for 10 years and transitioned into not only the applications of biochar to the soil, but the whole business case, circular economy, looking at different technologies that can be utilised for fit for purpose in different industries. And so ANZBIG kind of adopted me, which I'm really proud now to be their chair and take the industry forward to implement this 2030 roadmap. At the same time, I chose to align myself with, you know, really good technology, Metamorph, and was a consultant for them, but have taken a position with them to help develop their industry. So that's a little bit about me. We can go to, I can do the next slides now myself. So there is a little video here which doesn't need sound. If you can try and play that, it's a little play button at the bottom. If you can just, it doesn't need sound like the last one. Hopefully you can see that. If not, we'll move to the next slide. Here we go. So if you can just play that. World leaders are now stressing that we need to limit global warming to 1.5 degrees by the end of this century, because crossing the 1.5 degree threshold will unleash likely irreversible impacts. The International Panel on Climate Change says we're not going to reach the 1.5 degree limits by 2030, and we're burning our carbon budget at an alarming rate. And I guess this video just demonstrates what happens when you burn biomass. So that's what our industry is all about, is recognising that that biomass that's available, not just in Australia, but globally, no longer needs to be burnt or rotted. What our industry does is convert that to carbon, but depending on the technology, can also convert it to renewable energy. And that's a really big, I guess, key message, is that that biomass that's available globally is a resource. And we need our world leaders and everybody in this room to get their head around that it should not be burnt. We cannot afford to burn it anymore. It needs to be turned to carbon in a stable and durable form and keep it within the atmosphere to be able to remove, we say, up to 10% of global carbon emissions. So that's what IPCC is saying. Rapid, immediate reductions in greenhouse gas emission requires carbon dioxide removal. Our industry removes carbon. In 2023, biochar carbon removal delivered over 90% of carbon removal in the voluntary carbon market, 90%. But sadly, we only received 12% of the funding that's available globally. We know that there's global capital that can be redirected to our industry, and that's what our roadmap is all about, is trying to redirect some of that global capital to do what we need to do. There is no other material that can achieve this much to cool the planet while increasing production, sustainability, biodiversity, and revenue. It is the only material that can achieve carbon drawdown at the scale that we can do it. We aim to be a minimum $1 billion industry by 2030. ANZBIG says we can remove 10% of Australia and New Zealand carbon emissions annually. But did you know that carbon drawdown doubles as soon as the biochar hits the soil? There's multiple published papers to say that the carbon in the biochar has this negative priming effect on other types of carbon in the soil. It also accelerates photosynthesis and at least doubles the amount of carbon as soon as it hits the soil. So theoretically, we could potentially, if you apply that biochar to soil, be 20% of global carbon emissions. And we haven't even accounted for the renewable energy that we can create when we make biochar. Carbon dioxide removal hit 600 million in 2023 with a striking 91% of compound annual growth rate, CAGR production from 2021. And you can see the graph at the bottom showing that amazing increase. So the aim of 54% increase in compound annual growth rate is attainable, and they say it should plateau out at a certain time. And so the entire industry globally, IBI and USBI, aim to draw down a gigaton of biochar, of carbon removal via biochar annually by 2040. So that's huge. And so you can see that growth rate, and we can see that we're on a large growth rate. And Oceania, where Australia is part of that large growth rate. You can see that green at the bottom. And that graph is from the USBI IBI recent report. So our roadmap. Now, I'm not going to go through these 1 to 10 bit by bit, but just to say that the roadmap was produced by looking at 200 odd plus members input into our roadmap. We came up with a range of themes, and we came up with a range of priority actions, which is the numbers 1 to 10, and I'm going to touch on those in a moment. And they're available from our website, but you can also scan the QR code and get a copy of it. Also, the USBI and IBI recently produced this report, a global biochar market report, and their report closely aligns with some of the themes in our roadmap as well. So that is a really good report, and it provides insights gathered through 1,007 survey responses, of which a lot of our members contributed to, but also it went across over 100 countries. And so they have some similar priority actions which are aligned with ours. So I'm going to just refer to some of the graphs in that as well shortly. So let's go to our first theme. So we've got 10 themes, but our priority actions, so we might have 1 or 3 themes in the different working groups. So we've now got 5 different working groups that ANZBIG has set up, and across those working groups, we have 60 of our 200 members that are contributing significantly to those working groups. So that just shows you the enthusiasm for the industry, and they're at this stage voluntary until we can become a better funded industry. So those working groups, we recognise the first one is the resourcing working group that needs to find the funding for these priority actions. And we recognise in Australia and New Zealand, if we turn our 50 million metric tonnes of waste biomass to biochar, just the biochar alone, not even the renewable energy and the benefits of biochar on the soil and elsewhere, it's a minimum economic value of more than $5 billion. So we have a conservative aim of becoming a $1 billion industry rather than a $5 billion. To help the industry achieve this, turning the waste to biochar, we only need less than 0.5% of the funding. So we're after about 300 million to be able to implement this roadmap. And we know there's sufficient global capital to redirect this to more climate action. There's global capital available. We just need it directed to our industry. So the resourcing group has, these working groups have only just begun February, March, has already got off to a great start. We developed a crowdfund campaign, which I'm sure Don will probably touch on at the close of today. And that is already off to a great start, raising funding to implement our roadmap. And we're also rolling out new member benefits and a member drive. So it's really important for our 200 odd members to be visible to Australia and globally, what they do, what the technologies are, what biochar is available, who's got feedstocks, who's a carbon broker, so that these projects can be linked together, so that a big company might come along, want to be able to put a project together. It's very transparent. Now the Resourcing Working Group is also looking toward gleaning government and private investment. There's other things that they're looking to do to support this, like waste levies. There's circular economy policies that our members are having input to, that overlaps in some of our other working groups. There's policies for road, agriculture and other, and later on I'm going to show you a couple of some examples of that, and there's lots of grants that will help fund us, as well as philanthropic funding. And we're also just recently, we're about to turn to a company limited by guarantee, which will also support that. I just want to put the names of our working group members up down the bottom. Matt Griffin is chairing that, because these members are really important to our industry, and I really wanted to acknowledge their efforts and their support. So let's now go to the Education and Communication Working Group, which is Initiative 2. And that aims to improve stakeholder awareness and education of biochar uses and benefits. The working group members are there, and now the survey from the USBI and IBI also identified where we need to improve our communication. A lot of it is around the financial aspects of biochar. And, you know, this is close to my heart as well, because, you know, I do numbers frequently for farmers in terms of how biochar can benefit farms, because it can significantly reduce your fertiliser inputs by a minimum of 20 to 30%. And the results, there's a recent meta-analysis by Yi et al. That shows when biochar and fertiliser are combined, it can increase your yields by around 46%. So those are the messages that we need to get out there, and they're already off to a good start. There's a farmer's guide that has been produced that's on our website, which is in draft form. It is a very valuable resource for anyone wanting to make or use biochar in agriculture. And then also they have produced a draft concept of a dialogue platform, which is almost like making ANZBIG a community of practice, where we have that multiple flow of information in and out. It's a great platform, and we have endorsed that. And so the Education Communications Group are going to work on that pending resourcing it. Okay, so then we're going to the policy and regulations. So integrating and optimising industry and regulatory frameworks. And so we do know that policy is very, very important for this biochar space. And I just wanted to draw on an agricultural case study, and something that we could look at both in state by state, but also nationally. So in California, we know there's big wildfires, as we have in Australia. Pacific Biochar have developed this model that they're hoping to have endorsed soon, which is a policy that uses forest biomass and uses it back into agriculture, that will improve carbon drawdown, drought resilience, nitrogen conservation, as I talked about, fertiliser efficiency on a statewide scale. And according to this model, forest biomass in California can generate 1.5 million tonnes of biochar annually, improving 160,000 acres of land annually at an application rate of 1% soil organic matter, adding 13,000 acres per feet of water holding capacity to California soils annually, and achieving carbon drawdown of in excess of 9 million tonnes annually at a cost of $35 per tonne. So that's an amazing policy. That is something that I aspire to, and I would really like to see our policy and regulations group work towards. But, you know, I understand in this room there may be those that are able to influence policy as well. And the more that we can get messages out for policy like this, it's a great model, because it recycles carbon from partially burnt timber and ends up improving the soil while drawing down carbon and increasing revenue. What what could be better than that? Here's another example is the Swiss government, which has published a roadmap for carbon capture and storage and carbon dioxide removal, and in that it talks about biochar in the carbon removal space. And I couldn't find the actual policy, but what I hear is that there's a certain amount of biochar that needs to be used in roads in Switzerland. So one of the problems with getting biochar projects up in Australia at the moment is that it's not being produced to date in big quantities. So it's really hard. So each individual biochar producer needs to work hard to gain that biochar takeoff agreement. If we just had a policy like that, that would take care of, you know, biochar projects just like that. We do have some really good technology in that space with C12 making using biochar for a cold mix that can be used in roads, and that's working with highways. So, you know, that potentially could become a policy nationally. Okay, so moving right along. This is the members of our policy and regulations group. They've also come up with a policy paper, or they want to develop a policy paper to support decoupling pyrolysis and gasification to produce biochar and other byproducts from linear energy from waste policies, and practices that focus on end-of-life disposal. So that's one of the things that they're working on as well. And as I said, there's other policies that they work on as well, like waste policies, circular economy, and some of the other examples. There's a graph there that talks about some of the manufacturing challenges from the IBI, USBI. And so capital for customer financing is one of the big things, you know, so they can implement or influence policy that will help with that capital raising. EPA approval is a really big challenge as well. So, you know, we're asking them to have a look at that also. Okay, so getting there, the other working group, innovation. So they've got Initiative 4, Initiative 7 as part of that, which is looking at biochar commercial demonstration trials and driving increased value of biochar products and co-products. So adding value to raw biochar is really important, especially for agriculture. USBI and ISBI did a survey, and of the 1,000 odd members came up with this is how biochar is being value added, with nutrients, grinding it, crushing it, blending it with amendments, composting, quality testing, packaging, activation. So there's a whole range of ways that we can add value, and we need that innovation. And I know that there's a number of biochar producers that are looking at that and doing that to get greater sales. And the innovation group has recently looked at the climate smart grants and sustainability grants to look at more larger commercial demonstration trials. And I know a number of our members also applied for the climate smart grants, and they may link back through to ANZBIG to help disseminate those outputs. So thank you to the working group members that are working on that as well. Okay, getting there. So standards and certification, they've got 2 initiatives that they're working on: safeguard responsible use and production of biochar, exporting of biochar, and leveraging carbon emission reduction and carbon dioxide removal opportunities. They've got a big portfolio. Just to say that ANZBIG has established a code of practice which classifies 3 grades of biochar to fit for purpose. We also have a strict sustainability policy, which we expect all of our members to adhere to, and we have a code of conduct as well. And it's really important for our industry going forward, and we're continually upgrading those policies to ensure our members stick to those, but ensuring that we've got the policies to make sure that we are being sustainable. And I know Karen's on that working group, and thank you for your work on that, and Chair Adam O'Toole and Gordon Hurst. And there's a graph there about what some of the issues are: measurement, reporting and verification challenges globally, about biochar quality variability. It's you know, that's one of the problems with our industry, because the feedstock varies, the technology varies, the temperature varies, the speed varies that you make it. And so in having those certification standards are very, very important. And the message to the end users is that fit for purpose chars can be made fit for purpose for the end use. Okay, and then the last working group, which is supply and market development, encourages beneficial use of residual waste biomass and supports government utility industry procurement practices. So that's about supply and market development. So one of the things that we have done and working through this group to support is the new membership benefits and advertising, which I mentioned, and the dialogue platform. But also, you know, I just wanted to put up this graph from IBI as well about the biomass that's available, and Oceania is the green there, the dark green, and so in that shows that the largest amounts of biomass available in Australia or Oceania is forestry residues, followed by agricultural residues. So crop residues, really big, cereal crops, nut waste is another one, municipal waste right up there, so FOGO, green organic waste, roadside vegetation clearing, followed by manure. Biosolids aren't as large in Australia as we thought, but they're still a very, very important part of our industry. And we know we've got Taswater here as well, looking at that. So we want to see sustainable reuse of that biomass, and just to reiterate that our industry, and even to get carbon removal certificates, that has to be a deemed waste, and there is sustainability measures in extracting that waste from cereal crops. For example, if you turn the cereal residue into biochar, you still need to leave 30% of the original residues behind. Okay, so they're working on that supply and market development, so turning those residues into biochar, and developing the markets for the use of biochar. I've just put this graph up because it's got a really good list of the different types of people that are involved in our industry, and these biochar producer, academic researcher, consultants and the like, they're going to make up the pages that we have on our website. So they're going to be the pages on our website, and then people will be able to, when they're members, they'll automatically be able, we'll have an ad and can talk about what they do to contribute to the biochar industry. And that dialogue platform will be able to better connect all of those people into a community of practice to accelerate where we're going. And these dialogue platforms show that they accelerate the uptake of the industry by, you know, a large percent. So we're really looking forward to implementing that dialogue platform. All right, so that's just about it for me. I just really wanted to, got a couple more slides in terms of market supply and market development. So we've got our 5 industry groups and the supply and market development. And this slide just really depicts some of the ranges of biochar uses there are in Australia. So up the top, we've got insulation, there's biochar bricks, there's antibiotics from biochar. My company is working on activated carbon, so biochar and activated carbon at Metamorph. We've got biochar from biosolids, but also biochar and activated carbon can be used to filter water. I've got biochar in pavements or roads. I've got biochar used in sustainable buildings because it's a light material and it can be used on rooftops. I've got biochar in animal bedding, and that's my lovely heifer, number 57, who's just had a calf, eating biochar. So biochar for animals. Okay, so ANZBIG supports carbon dioxide removal acceleration. That is our key message. We'll do that by our 5 working groups that I just ran through: resourcing to help fund it, education and communication, policy and regulations, innovation, standards and certification, supply and market development. And our board, executive board of, who we've got members here today, Karen and Craig, who you'll both hear from, and Don, our CEO, are very high on implementing renewed governance and risk and auditing. And part of that governance is going to a company limited by guarantee, and that will happen as of the 1st of July. and we'll make sure that we're on top of that. We aim to be a $1 billion industry by 2030, and with these working groups, we will get there, but we also need significant resourcing and policy to do that. So, thank you. Hey, Karen.
Quickly introduce Annette.
Oh, we will, yes, of course. Go, have you got the little bio there? So now I'm probably over time, but there is a Q&A later. So if you do have questions, please save them for them. But also I'd love to hear from you in a break. So I am now going to introduce our next speaker, who is an online speaker. It's Professor Annette Cowie. And we are very lucky to have Annette as part of our biochar family. Annette has a background in soil science and plant nutrition with particular interest in sustainable resource management. I know there's a whole thing there, but Annette was a lead author in the International Panel on Climate Change, and she's been very instrumental in getting biochar recognised by the IPCC. She has done lots of greenhouse gas accounting. She really will help this presentation, which I've heard a number of times, but she is live there for questions after. She will help you better understand biochar in the carbon dioxide removal context and its importance. But she has multiple publications, is across multiple national, international organisations. But because we're running short on time, I will hand it over to Annette to say more about herself as needed and provide her presentation. So thank you.
Thank you very much, Melissa. And can I just check, is my slideshow on for you?
Yes, we can see it. And I'll
Fantastic. And I gather you can hear me too, so that's all good. I'm really disappointed I wasn't able to join you there in person. Obviously, it will be wonderful to be there and much more effective than talking to you online, but it's great that we have this technology that allows me to be able to at least give you a part of what I'm interested to say about biochar. There's plenty to say about biochar, as I'm sure you can tell already from the speakers that we've heard from so far. So my role today is to give you a really short overview of biochar's role in climate action. I'm going to talk about the policy drivers that are leading to demand for biochar, but I'm also going to take a diversion to tell you about the science of biochar so that we can make sure we're all on the same page as what biochar is and what biochar can do. My emphasis is on biochar as soil amendment. I come from an agricultural background, so that's where I see biochar as having the great advantage compared to other things we can do for sustainable agriculture. So it's the UNFCCC, the United Nations Framework Convention on Climate Change, that is driving our climate policy internationally. And the current phase of the UNFCCC is the Paris Agreement. The Paris Agreement is a landmark agreement because it's brought all countries on board, and it's taken the important goal of aiming to limit global warming to well below 2 degrees and preferably no more than 1.5 degrees. The important things to note at the moment today about the Paris Agreement is that it's trying to ensure that we reach the position of net zero by the second half of the century. So that's net zero greenhouse gas emissions. Net zero means that we will balance all our emissions from all sources of all different greenhouse gases by carbon dioxide removal. And biochar has a really important role to play on both sides of that balance scale. This is a stylized pathway for how we can get to net zero. It's part of the IPCC, the Intergovernmental Panel on Climate Change's recent 6th assessment report, the Working Group 3 report, in which I was an author. And this is showing that if we are going to achieve that goal of limiting global warming to no more than 1.5 degrees, we will actually have to reach peak emissions next year, 2025, which is why many people are saying it's impossible to limit warming to 1.5 degrees. It's hard to imagine that we can turn around the world and achieve this next year. But this is the trajectory that will be required. So in order to do that, we need to halve emissions by 2030. And so that requires a very drastic reduction in the grey part there, the emissions of fossil CO2. It also requires sharp reduction in our non-CO2 greenhouse gas emissions, for example, reducing methane emissions by 30% by 2030. And it requires us to ramp up the carbon dioxide removal. We need to reach the position of net zero CO2, so that's where where CO2 emissions are balanced by CO2 removals by around 2050. And we need to reach the position of net zero greenhouse gases, so that's when all greenhouse gases are balanced by carbon dioxide removal in the second half of the century, as I mentioned. The IPCC's report made this very bold statement in the summary for policymakers. The deployment of carbon dioxide removal to counterbalance hard-to-abate residual emissions is unavoidable if net zero greenhouse gas emissions are to be achieved. As I said, there's a big role for biochar here. The IPCC reviewed a range of different ways that you can pull carbon dioxide out of the atmosphere, the so-called negative emissions technologies or carbon dioxide removal methods. And some of these are obvious and common things like planting trees and building soil carbon. Some of them are emerging geotechnical solutions like direct air carbon capture and storage, which means pulling ambient air across a solvent with fans and a lot of energy, and then capturing that CO2 and condensing it and pumping it underground, doing geosequestration. But biochar is one of the methods that they have focused on in particular, identifying that biochar is a method that has a biological carbon dioxide removal method. The approach is biological rather than chemical or geochemical. So when plants grow, they take CO2 out of the atmosphere biologically through photosynthesis, and normally that's part of the carbon cycle. But when we turn it into biochar, we essentially stop the return to atmosphere. It's very slow decomposition, and so we have a very durable storage mechanism. We know that biochar is very difficult for microorganisms to decompose because of that chemical structure that's largely composed of benzene rings, the aromatic carbon. And the IPCC report identified that biochar has a theoretical technical potential of up to 6.6 gigatons of CO2 removal per year by around 2050. And that, yes, it has a lower cost compared to many of the other carbon dioxide removal strategies. Now, because you didn't get to see the lovely little video clip that Don tried to show earlier, I will just mention, to make sure that we all understand, that biochar can be made from a very wide range of biomass materials, and it can be made at very wide range of scales. So these pictures illustrate making biochar in a very small cook stove, or in a Contiki pit in the ground, through to an engineered plant. This is the Logan City Council wastewater treatment plant, gasification plant, and they would be processing several tonnes per hour in large plants. So just to run through how biomass converting to biochar delivers climate change mitigation. Firstly, we have the fact that the carbon is stored for centuries to millennia. So very durable carbon storage. Once you take biomass and convert it to biochar, as long as it stays out of the atmosphere, as in you don't use it in your barbecue, it is going to store the carbon for centuries to millennia. We also have discovered that using biochar as a soil amendment, on average, reduces nitrous oxide emissions from soil by up to 30%. So this is a wonderful thing, because nitrous oxide is a very powerful greenhouse gas, nearly 300 times worse than carbon dioxide. So this is a really amazing and wonderful finding that we would like to take advantage of, include in our carbon accounting for when we do our greenhouse gas inventories, and hopefully in carbon trading as well. Also, when we do pyrolysis, we release part of the carbon as a combustible syngas, and that can be used for energy generation, for electricity or for heat. And there are many materials that we can use for biochar that would naturally cause greenhouse gas emissions. So if we make biochar from manures that would have been composted, or if we make it from biomass that would have gone to landfill, then this releases nitrous oxide and methane during those biomass handling and treatment processes. If instead we make biochar from it, then we can avoid those emissions. And the last one on the list here is one that Melissa mentioned. It's the so-called negative priming phenomenon. Don mentioned that we have in New South Wales, DPI, the longest running biochar field trial in the world. And this trial has shown this phenomenon of negative priming, which means that having added biochar to the soil, obviously we increase the carbon concentration in the soil. But over time, the carbon concentration has continued to grow. And what's happening there is that the biochar is interacting with the soil minerals and the existing soil organic matter, and also new organic matter leaking out of the plant roots. And it creates these tiny, what we call micropeds, very small aggregates that trap the biomass inside and prevent microorganisms accessing it to decompose it. It's a combination of chemical, physical, and biological stabilization mechanisms. And what we've discovered, even more surprisingly, was that adding a new dose of biochar 10 years later stimulated the same phenomenon. So once again, an increase in soil carbon levels, obviously from adding a new dose of biochar, but then it was continuing to increase the soil carbon concentration. So what this means is that we can use biochar essentially as a never-ending pump. We can take carbon out of the atmosphere through plants, we can pyrolyze it, we can create biochar, and we can keep adding biochar to the soil, and we can keep increasing the soil carbon concentration. In comparison to adding manure or compost, which is going to quickly reach an equilibrium level where the carbon is turning over as fast as you're putting it on, because there's a limit to the capacity of the soil to stabilize the organic matter when we add it in those forms. We've also found a range of other beneficial uses of biochar in the soil. We've discovered that biochar can improve the water and nutrient holding capacity of the soil. This is very important for increasing the adaptation, so the resilience of the system, if we can increase water holding capacity, especially as we're anticipating more droughts under climate change. And the nutrient retention is important because it can reduce the amount of fertilizer you need if you have less of it leaching and volatilizing. And also that's important for water quality as well, if you're not leaching nitrate into the water. Biochar is usually an alkaline material, so it has a liming value. It increases the soil pH, important in our acidifying soils. If you put on reasonably large doses of biochar, which is what we normally, well, what we have commonly done in the past, it certainly affects the physical properties of the soil, and it can improve aeration, and it stimulates biological activity. We've also discovered that it can immobilize contaminants, heavy metals and organic contaminants, and the sorts of smoke chemicals that you create in the pyrolysis process enhance germination and plant growth. But please note that biochars are all different depending on what you make it from and how you make it. So it's really important that you choose an appropriate biochar for the particular application that you have in mind. A couple of years ago now, Stephen Joseph, who you'll hear from a little later on, and a group of biochar researchers from around the world put together this paper, How Biochar Works and When It Doesn't, a review of mechanisms controlling soil and plant responses to biochar. And this attempted to pull together everything we know about biochar from the literature. Now, biochar is a fairly recent topic of interest to science. The biochar literature was essentially non-existent before about 2000, and it's exploded since then. We have something like 40,000 papers on biochar in the literature, many more than you'll find on compost, for example. So obviously synthesizing that literature was a bit of a challenge, but Joey's phenomenal. He knows the literature, and so we pulled this together to as a paper that should help those who are new to biochar to understand what biochar does when you use it as a soil amendment. So what we noted was that biochar is most effective if you load it with nutrients, that is, if it's made from something like chicken litter that has nutrients plus a woody base, or if you add nutrients before you pyrolyze the organic matter, or you compost the biochar with manure, for example, afterwards, and then you use that in the rhizosphere, the root zone. That's when you'll have the greatest benefits. Intriguingly, research has found that in the presence of biochar in that root zone, it actually reduces the energy required for a plant to take up nutrients. You know, a really interesting phenomenon, which Joey can tell you more about. This meta-analysis that looked at the effects of biochar on plants demonstrated that practically every physiological or growth parameter you can think of, biochar enhances. So we're talking about increases in measures of photosynthetic rate and also in plant production, shoot and root biomass, etc. I mentioned earlier that it has a beneficial effect on heavy metals. So if you have a soil that's contaminated with heavy metals, there are a range of different chemical reactions illustrated here that lead to the biochar actually immobilizing the heavy metals. So it reduces the bioavailability of these contaminants and decreases the amount in plant tissues quite dramatically. So this is just a summary from our executive summary of the paper that pulls together the results of the various meta-analyses that had been done by that time. There's actually more since then, so that have strengthened these results. And so in general, on average, biochar increases crop yields by 10 to 42%. The effects are greatest if you're applying biochar to an infertile soil, particularly in dryland environments, particularly in tropical environments where soils tend to be acidic and have a high desorption capacity. Biochar also increases phosphorus availability. Meta-analysis suggested by 4.6 times on average. And I've mentioned its effectiveness in reducing availability of heavy metals. So, and I mentioned that it's most effective if we apply it in the rhizosphere and mix it with other nutrients. I think you'll hear today from others about how biochar can be integrated into farming systems, excuse me, in beneficial ways, including uses as a feed additive for animals, which Melissa just mentioned. So coming back to the policy drivers, I mentioned that the Paris Agreement has identified the need to get to net zero. Having identified that, countries have come on board with their own net zero targets. There's something like 152 countries now that have either implemented or in the middle of implementing net zero targets, usually for 2050. And in Australia, all the states have a target, and we have a national target as well. Tasmania, of course, is way ahead of everyone else in having a target, having already reached net zero and having a target to basically maintain net zero from 2030 and beyond. The other states are targeting net zero around 2050. At the same time, companies are coming on board. So there are many initiatives internationally and also in Australia through our carbon neutral program, Climate Active, that are providing standards and incentives and tracking capacity and certification for companies to adopt carbon neutrality or net zero targets. We also have mandatory climate-related financial disclosure coming. So this is initiated through the Task Force on Climate-Related Financial Disclosure that then produced the International Sustainability Standards Board standard for climate-related disclosures. And now we have this being implemented in legislation in Australia, which will require the large publicly listed companies to report their emissions from January next year. It was going to be July, but they've delayed that to next year now. And when companies have to report their emissions, that is going to create an incentive for them to reduce their emissions. I just wanted to mention here what we mean by carbon neutrality. So carbon neutrality is the situation when the emissions of a company are balanced by any removals that it can undertake within its own boundaries, so planting trees or using biochar, and then the remainder, the residual, is balanced with purchased offsets. So that's buying carbon credits from projects that either reduce emissions or sequester carbon. This is a carbon neutrality pathway from the recently released International Standard for Carbon Neutrality, and it shows that in order for a company to be certified as carbon neutral, it's going to have to reduce its emissions and at the same time purchase offsets. So in the blue, the offsets are emissions reduction offsets, but over time, and certainly once it reaches the position of net zero, it's going to need to be buying removals offsets. So I mentioned the ways that biochar can contribute to climate change mitigation. And just looking again at this list, we can classify these different components. So storing carbon through converting biomass to biochar is a removal mechanism. Similarly, the negative priming is a removal. Reducing the nitrous oxide emissions from soil is an emissions reduction. But if we talk about the other two factors of avoiding emissions from energy generation or avoiding emissions from biomass handling, those are somebody else's emissions reduction. So the biochar producer or user wouldn't be claiming a credit there. The person who isn't burning fossil fuel or isn't releasing nitrous oxide or methane from their manure handling would be claiming a reduction there. There are a couple of standards and methodologies out there in the voluntary carbon market that are already allowing companies to create and trade biochar credits. The Puro one is the most commonly known one and has been operating for the longest. The California one was just released, I think, in March. In fact, Microsoft has purchased carbon credits generated from biochar project in Australia, from the Rainbow Bee Eater project through the Puro platform. In Australia, we have the capacity to generate carbon credits through a range of different activities, mostly in the farm area, mostly associated with vegetation and soil carbon management. But there are a range of different project types here. Some of them don't have many projects yet. Blue carbon, for example, I don't think there are any. And certainly none in reducing nitrous oxide emissions from irrigated cotton. But you will not see biochar on this list, unfortunately. There is a soil carbon project which allows you to use biochar, but you don't get the benefit from biochar. You actually have to subtract the amount of carbon added in your biochar, so that's not terribly helpful. But we are hopeful because one of the promises from the Albanese government was that they were going to review and overhaul the ACCU scheme. And the Chubb review has recommended this new proponent-led method development process. So this is coming. We're not sure exactly when. They've released some guidelines on getting ready for it. And we certainly do expect it to be within months that it will open up for people to submit EOIs for methods. And certainly we're very much hoping that there will be a biochar method proposal generated quite soon and able to be submitted in the early phase of the proponent-led method development process. In order to be acceptable to the ACCU scheme, any activity, mitigation activity, will need to meet the offsets integrity standards. So just going through the list of what that requires, it has to be an additional activity. It has to be mitigation that wouldn't have happened already. No one much is using biochar already, so we don't have a problem with claiming additionality. We know we can measure it and verify it because there's an IPCC method already for quantification of carbon stored in biochar. It's eligible abatement because Australia could count it in its inventory. It doesn't at the moment, but as I said, there's an IPCC method available. Evidence-based, I've talked about the mountain of scientific evidence out there, the literature that supports biochar as a mitigation strategy. We can manage non-permanence because it's a durable removal and it also offers sustainability co-benefits. So I know I've gone over time and I'm really sorry for that, but I just wanted to tell you about how biochar can contribute to climate action. Certainly, the world is ready for biochar now. There's big demand now for durable carbon dioxide removal, and biochar can fit that bill. So, thank you.
Hello? Oh, you got me. Thank you, Annette. That was fabulous, as always. And yes, we are running short of time, but Annette, we know how to find you if we need to ask any questions. And we've got a discussion at the end, but I hope that, I trust and I know that would have helped put biochar into better context for especially its applications to agriculture. And thank you for all of the work you do on behalf of our industry, Annette. It's very much appreciated. I'd now like to introduce our opening address, which is a bit late in the program, but thank you, Brett Hall, Chair of Farmers for Climate Action, for being here and for the work that you do as well. And your background that's led you to this, being a cattle farmer in Derwent Valley here in Tasmania, and that you're the Director of Farmers for Climate Action and have been in that space since 2017. So I'm sure you've very much led the way in terms of gaining the members that it has now of 8,000 plus farmers. You know, I've been working in that space in South Australia, and I remember doing a presentation to some of the Farmers for Climate Action there and their excitement for biochar. So I'm looking forward to hearing from you. And Brett's the chair of the Cattle Council, has been the director of Cattle Council of Australia, got a large grazing background, being Tasmanian Farmers and Graziers Association. Is also on the Southern Australian Livestock Research Council. So thank you back, Brett. We look forward to hearing from you, and welcome.
Yeah. Thank you, Melissa. Just going to get the magic wand to work properly. Is that working okay? Okay, thanks very much, Melissa. As a chair, I understand just the workload you've probably had in putting this together and all the wonderful work that you guys are doing. It's just blowing me away with the amount of information that you guys have put together on biochar, and I'm learning a lot today. So thanks very much for this. Firstly, I'd like to start by acknowledging this Tasmanian Aboriginal community as the continuing custodians of Lutruwita and the lands which we stand. I pay my respects to the elders past and present, as well as the First Nations people here today. Particularly you, Harold, I really enjoyed your presentation to start off with. I grew up in the Derwent Valley in grazing up in the Highlands. And as a kid, I remember wandering around with a fire stick, which was a bit of Candlewick Park, as we called it, and going around, and we'd patch burn patches of rushes and sedge and all that sort of type of stuff, trying to produce more feed for the sheep and cattle that were grazing on that country. And that was patch burning that was adopted by Tasmanian farmers from your culture. So thanks very much for your talk. So I'd like to thank the ANZ Biochar Industry Group for bringing us all here for some valuable insights and discussions. I believe you're filming this, so it'd be great to have these recordings for future use. For people that don't know much about Farmers for Climate Action, this is a picture back in 2015 where we had a group of frustrated farmers. We're tired of inaction on climate change. It includes myself, so an extra biscuit for anyone that can identify me in that picture at the break. I guess we were concerned about not being represented on climate change by our representative bodies. And what we're finding is a lot of organisations, they had varying views on climate change and climate action, what should be done. So therefore they end up sitting on the fence and there was no action. So we particularly wanted to be able to focus on climate action and getting something done. Travelling up here from Hobart this morning, or yesterday rather, I was thinking about the dry conditions statewide, and also what happened when I was farming out east of Oatlands back in 2007, 8, 9. We had a 3-year drought running then, and people still talk about that drought. But I remember at the time going down through Levendale, Woodsdale, all those sorts of areas. And the farmers there, they would have had a lot of dams on their properties, but they're tiny little dams, less than a megalitre, and that had always filled their needs as far as grazing and whatever crops they were doing on their farms. They didn't need extra big storages, and they got caught out really badly because that was just so unprecedented in their operations. And that was a real driver after seeing those sort of things happening to a community that was experiencing conditions that we'd never had in farming experience since Europeans settled in Tasmania. So that's why it sort of really fired me up to sort of try and get a bit done about climate action. So climate action, farmers for climate action now, we represent more than 8,200 farmers and a supporter base of people. It's over 70,000 now of people that contribute and support us across Australia. So move from that motley crew earlier of 30 farmers coming together in the Blue Mountains in 2015 to where we are today. We've really come a long way. And at 10 years will be next year. So we'll be doing some big works next year, sort of just to celebrate our success. But it's thanks to the farmers joining us and supporting us along the way. We have a Tassie group, wide all over the state, over 400 members in Tasmania, farmer members, and 1,000 community supporters. The membership for FCA is free and our members are really highly engaged. So I invite everyone that believes in climate action to head to our website and join us as a member supporter today. Looking through some slides yesterday, I brought up Tasmanian Climate Smart Conference that was actually held here in this building a few years ago now, 2020, 2021. But that was really popular, and that really engaged our Tassie members and got people engaged on climate action in Tasmania. So that was a really good success for us. We stand at the crossroads of progress. It's crucial to acknowledge the foundational principles we have shaped Australian agriculture. Profitability, productivity, and our people, we've focused on those. However, I'm sure most of you understand that there's a fourth pillar now, which is non-negotiable, our planet. So together these 4 Ps underpin FCA's vision of farming forever. We know that farmers are on the front line of impacts of climate change, and the majority of farmers are committed to being part of the solution. Farmers for Climate Action works to influence Australia to adopt climate-wide climate policies by growing the number of farmers, farming communities, and elected representatives championing ambitious climate action. This grassroots-led action has driven results. We know the importance of farming in Australia, not only to economy, but also producing food and fibre for the nation. So what are we doing? This picture here is of a 2019 visit to Canberra. We had farmers from all over Australia coming together, and we had appointments with politicians from all over Australia, and people from each state went to their elected representatives and approached them about doing things about climate action and recognising it and getting more action across the wider community, because farmers are being affected the most, and we need action right across the economy to draw this impact down. At the grassroots level, our work is about upskilling the farmers. We've directly trained over 1,000 farmers in climate literacy and climate smart agriculture. We run regular webinars and host some of the leading voices around the country on climate change and agriculture. We know that farmers are changing their practices and becoming more sustainable as a result of our work. A big part of this work is in shifting politics. We take farmers to meetings with MPs and Parliament House, getting their voice in the media and making sure they hear every side of the argument. We know we need bipartisan support to get climate action, and we need our parliament. We need in our parliaments, and that's what we're fighting for at Climate Action. The PM today up in Beef Australia, I got a notice there before, is announcing a 500 million future drought fund, build climate, to build climate action, to address issues around climate action. So building farm resilience. So that'll widen out the drought fund and be able to sort of access funds for doing this type of work. And hopefully it includes also something for biochar. Let's keep our fingers crossed. So farm profit, the climate climate change is already impacting Australian ag. This came from ABARES, and it shows that farm profits are already being reduced. So it's not coming, it's here now. I think that's the big point. So farmers in Australia have access to one of the most important natural resources, soil. It's the lifeblood of our industry, and it's not only key to producing the high quality food and fibre we are so proud of, but also to reduce emissions. It impacts everything from crop yield to water retention, so it is brilliant to be here today with people focused and invested in creating positive differences through biochar. Farmers know that soil health is the key to their farm's productivity. It is also increasingly understood that soils are the key to climate resilience. Trials around the world are showing that high quality soils reduce the sensitivity of crops to yield and climate variability, leading to higher crop yields. For Farmers for Climate Action, on-farm action is important not only to lower farm emissions, but also to ensure that farm businesses are sustainable, profitable and resilient. Building resilience and ensuring that farmers are equipped with the tools, resources and technology is a key enabler towards our vision of farming forever. So here we have a biochar field day on Greenside Farm. That was a Landcare field day. You can see growing interest in biochar. So agriculture has long understood that turning waste products into productive opportunities reduces wastes, costs and emissions. The circular economy is now finally being given the recognition it deserves as an industry in itself, and that is a great thing. In this context, biochar is a fantastic opportunity as it can work independently and also in combination with fertiliser to improve soil health to increase yields. Storing carbon in soil is a long-term and it's very important for farmers to decarbonise and lower their emissions. Biochar is a stable way, Biochar is a stable way to store carbon in soil long-term. Biochar allows farmers to use waste biomass that they have in farms like crop stubble or woody weeds through pyrolysis, turning into a usable soil enhancing addition to their sustainable land management. The options to produce biochar on farms seems to be changing, and ANZBIG's Farmer Guide outlines, it's an amazing document, it's a huge amount of resources that you put together, outlines ways that all farmers can be involved in biochar, that's do it yourself or otherwise. We're looking forward to hearing more about the role that biochar can play in improving soil carbon and resilience and the opportunities for farmers to either use or create biochar. The Australian Biochar Industry 2030 Roadmap represents a vital step towards enhancing soil quality and addressing climate change in agriculture. By fostering collaboration between farmers and industry, we can harness emerging technologies in boosting farming productivity while safeguarding our environment. Your support enables us to amplify farmer voices and advocate for meaningful action on climate change, paving the way for substantial emission reductions across our country. Thank you for commitment to this important cause, and also thank you to the organisers of this forum for your support for Farmers for Climate Action and the work we do. Thanks very much.
Hello, yes, you've got me again. Thank you, Brett. That was fantastic. Really good to hear that you're looking at biochar. And I just wanted to come to a exciting case study that I know is coming where some cereal producers are looking at making biochar from their own waste from a big pyrolysis system, putting it back on their soil, reducing their fertiliser inputs, and the machine will pay itself back within a year, which is amazing. So we'd love to talk more with you about how to continue to engage and cross over in our industries. I'd now like to introduce the most important person in the room today, I think, Karen Inkalar, who has worked tirelessly to put this forum together for us, and we are really reliant on our volunteers in ANZBIG. So Karen is on the board of ANZBIG and has made some significant contributions, especially in the space of regularity and standards and certification, and has her and her partner, Steve Sullings, who's in here, has had a lot of experience in that space and really done a lot of the hard yards with ANZBIG, developing markets, and she's got a lot to share. So I'm looking forward to hearing from her about linking community industry sectors for circular economy, biochar production and sequestration. Thank you, Karen.
Thank you. I'm hoping everyone can hear me. Everyone can hear me? Beautiful. I'm hoping my slides might come up, but in the meantime, I'd just like to say a very big welcome to everybody. Yes, it's been a lot of hard graft behind the desk over the last few months, and I do promise that I'm the last person speaking before we have to go for a morning tea break and we can all break out and have a bit of a chat. So sorry, I have to stand here so that we can actually keep the recording. But yes, my ideas for this webinar, for this forum, is to really showcase the potentials for Tasmania. We're an island, and we have physical and real boundaries and limits, and we've got to, you know, front the challenge of creating, working with industries within those limits. So I will talk a little bit more about that, but I'd just like to say ANZBIG has worked hard to develop some substantial strategy documents to help us engage with our policymakers, and I encourage you to please join us, join the group, link together with some exceptional people like I've done. Everyone plays a part, and I'll explain that in my presentation here. So the code of practice and the standards, of course, the regulators and the policymakers want to see that, and we're working on that. The strategic plan has 15 key initiatives, and whatever sector you come from, those initiatives, you can hang your hat on those if you're a specialist in those areas and start to invest and engage to help. But we need everybody's help. We've also recently produced the Farmers Practice Guide, and that's going to be complemented by a manual. The manual will have a lot of tabulated materials about application rates and based on biochar type, and then of course your soil type and the destination. So that manuals, that tabulated material, will form a substantial part of the standards. The standards, of course, will cost several hundred thousands, if not more, to put together, and as an industry we need it. And investment, it's now time to invest in us to help make that happen. You can help us too. So as I said, the aim of this forum, I've brought together speakers deliberately to link the 3 pillars of biochar success. So it is a matter of understanding what our feedstocks are, because biochar, anywhere we are in the world, will be made locally. So we're looking at local bio waste. So we're not growing anything to make biochar. We're using beautiful secondary resources to make biochar. They are valuable. They are a nutrition source, and they're also an energy source. And if we look at it that way, we're using biochar from bio wastes. It's nutrition and energy, and we're giving it back to the community that it comes from. It's otherwise wasted, so let's use it. It's fantastic stuff. So I'm also linking the feedstocks around us with what I'm aiming for is investment in our own wonderful engineers. I absolutely adore engineers. They're creative designers, and so want to support those, and investments needed. So Asia Pacific Biochar Check to suit the feedstocks. Different tech will deal with different feedstocks. And then of course, the most important part is, once we've made the biochar, is to develop those markets. Now, Annette Cowie and others have outlined the different markets, and there's such a vast range. And when we understand that biochar is a non-fossil fuel carbon, and that carbon is one of the most important building blocks of our whole world, when we want to sort of draw back from fossil fuel use, we'll be able to start to hopefully understand what biochar is and how it may best be used. We can easily make it, well, not that easily, because it costs a lot of money and it's a bit of hard work to do that, but it's very hard to actually market it. That's where the money comes in. It costs millions of dollars to actually develop a brand. But those sequestration markets are so important. There's no point us making it and having it sit there. It could be easy for us to actually, create a bag of biochar. The corks are then sold and the biochar doesn't get used. That's not what we want. And I will talk about that in a little bit more in detail coming up. So my partner Stephen and I, we started Expand Healthy Profitable Agriculture 8 years ago. And we're obviously involved in biochar a little bit before that, being enthusiasts for putting carbon back into soils. Steve's been involved in the agricultural industry for 40 years, both in the retail sector and now making biochar as selling it himself. He's got a lot of contacts and he really appreciates everybody's support. So his work has been primarily focused on growing grass, getting animals to eat it, and managing the country, growing more grass than ever before. Obviously, that's a carbon drawdown there. And the animals, of course, are part of nature's carbon cycle. As Steve says, you've got 4,000 head or something like that, eating the grass and then walking around in their fertilizer units. So we say biochar is a charcoal-like substance containing stabilized carbon. That's certainly the catchphrase of the video we unfortunately didn't get to see earlier on. But that's a catchphrase there. But it's stabilized carbon plus something else. It's not just carbon. So what else is in biochar? Anybody know? I know Craig's saying, oh. Okay. Well, as Don said earlier, we've got so many variables with biochar. So if we look at the type of feedstock, the treatment, the technology, the temperature and time, all of these variables will create infinite numbers of biochar, infinite different types of biochar. So how do we know what we're making and how do we know what we're selling? I'm not really confident in actually selling something to a biochar to somebody if I don't know what it is. And I wouldn't expect people to buy something they don't know what it is. So I've been working pretty hard in the background of asking the ANZBIG group to help us get appropriate testing in Australia. When I started, there were no labs in Australia that tested biochar properly. So as an industry group, we're saying, well, what do we want to test? And then helping to support labs more around the country to actually help everybody who wants to actually make a biochar and test it, to have those available, because otherwise we don't know what we're doing. So then once we know what it is, we can get application rates. We'll be guided by the new standard. That would be fantastic to have. So once we know that in our code of practice, for example, we talk about feed grade biochar, soil grade biochar, and then industrial grade biochar. So feed grade, of course, is made suitable for all markets, including feeds. Soil grade is not suitable for feeds, but soils. And then industrial grade is not suitable for soils or feeds. So that will really largely depend on the feedstocks you start with. Of course, the code of practice says the feed grade biochars must be a feedstock that is untreated and uncontaminated. In our case, we want to also make sure that it's consistent. There's not a lot of change in that. And then I'm asking the laboratories to set up test suites that can basically help us to outline, first of all, the characteristics, the metals and minerals, and the combustion toxins and contaminants. So you actually have a data sheet coming back from the lab. It's not like a dog's breakfast. It's actually something you can understand. And if you can understand mine, and then the lab produces another set of tests that is produced in the same pattern, then the marketplace can then look at that test, look at that test, look at that test, see that there's a regular pattern, and then decide which biochar might be best for them. The combustion toxins are not often talked about. They're something that comes up with the technology that's being used. The World Health Organization has set a limit for those combustion toxins. They're the carcinogens. The charcoal's not, the combustion toxins are. So we don't want a lot of those in feeds or soils. And they've done that because we put our food into combustive environments all the time, don't we? We smoke it, we barbecue it, we roast it. We love cooking our food in containers, and it's just a matter of making sure that equipment is kept clean and monitored. The heavy metals, of course, all of the composting, fertilizer, we're all trying to follow the regulations that everybody else has to comply with when putting materials in feeds or soils. So biochar is not exempt from the rules that apply to everyone else. We're not on a planet by ourselves. We want to follow the rules. And of course, we cannot have excess heavy metals in soils or feeds. We're following the APVMA, which is the Australian Pesticides and Veterinary Medicines Association. They have very strict rules, and the more we can show that we're following their rules, the better. Characteristics, well, what is your surface area? What's your electrical conductivity? What's your bulk density? What's your moisture content? What's your particulate size? All of these things you can start to ask your questions because they will have different benefits for your application. So with the educational comms group, I'm in the working group there. I mean, my background is academic education. So even though I'm a very shy person, normally sitting behind a desk reading other people's work, as part of the educational group, we want to sort of start to develop a biochar lexicon for people. Do we want feed grade, soil grade, or industrial grade? What particle sizes do we want? Do we want high or low carbon, high nutrient or low nutrient, high temperature or low temperature? The biochars, as I said, can have all those different variables create different biochars, and each one has a destination market. Even regardless of the feedstock you start with, if it's a bit contaminated, it might not make feed grade or soil grade, but it can certainly be used elsewhere as a non-fossil fuel replacement. Excuse me. So as Annette says, Annette specialises in and loves talking about chicken manure biochar. Because chicken manure biochar, if you start with something that's got a low carbon content and probably higher nutrients, so chicken manure, of course, is going to have, all manures do, have carbon, phosphorus, and nitrogen, plus water. If you start with chicken manure as a biochar feedstock, then that's what you'll end up with the biochar. You'll have a lower carbon, but higher phosphorus and higher nitrogen content. If we start with feedstock like what we use, which is a hardwood timber waste from the forestry sawmills, then high carbon, low nutrient biochar, and that's what we want for our biochar because you use it as a platform to put other things with. So yeah, you can see that the biochar, what you start with is what you'll end up with because it's nitrogen and phosphorus persists through the pyrolysis process and other things as well, including heavy metals. So that's why we want to test it. So in 2017, I just wanted to sort of get in my head, just get out of my system and understanding, put it on paper, what are the different community groups that are linked in the process of creating biochar? Obviously, we know that farmers are one. We know that so I've just said, okay, we start with the information bodies, and I call them the policymakers, the universities, researchers, the auditors of biomass, the industry groups such as Meat and Livestock Australia, and the Grain Corp, all of these guys that are industry representatives. So I call them the information bodies, and I'm also looking to them as being potentially the people that hold the seat of generating carbon credits for biochar and also helping to redeem those credits. So there's basically 10 identifiable sectors in the biochar community realm. And by the way, the little circle there, that represents, that's my representation of our planet Earth, and we're all linked together in helping the planet Earth. I'm talking about land care, but taking that up to another level of not just land care, but earth care. So I talk about earth care practice and what we're all involved in this. So we start with the feedstocks auditors, the feedstock suppliers, the feedstock processors, if you need to chip it or mulch it or whatever in order to pyrolyze it. Then I'm really excited about the technology suppliers, and you'll be learning about some of those upcoming today. The feedstocks also get Professor Stephen Joseph coming up after morning tea to talk about the different feedstocks, how we can pre-treat it or post-treat the biochar, or we can combine different blends, and we can start to really design different biochars for different applications. We've got TasWater here, thank you TasWater, as major sponsors. They're also looking at biochar for contaminant mitigation. That's a big thing coming through, and of course other people using biochar for filtration. This is really exciting stuff because we've got an industrial legacy and we're going to be trying to inhibit industrial contamination moving forward. Biochar has a role. So technology suppliers, biochar makers. Now at the point of the biochar being made, I'd start to talk about you know, how we can differentiate different feedstocks to direct them into different markets. So I talk about unqualified feedstocks, so it might be FOGO, like a box of chocolates. You don't know what you're going to get in a feedstock with the FOGO, do you? So if the feedstock's unqualified, then it's not likely to go into feeds. But if it is unqualified, we may be able to still have a use for it in asphalt, concrete, and so forth. So there's going to be industrial uses that we can use the unqualified feedstocks for. And if we have a qualified feedstocks, then it's going to be able to go better into soils and feeds. At that point of being made, I know I make bags and bags and bags and bags of biochar. I would like our policymakers to grant me carbon credit at that time because I've tested my biochar. I know how much carbon's in it, and I know it's going to last a long time. So I'd gain the credit, and the IPCC has deliberately called biochar a negative emissions technology. And being a person into semantics, I love that word technology. I'm going to hook into that because I can at the moment get a renewable energy certificate for a reverse cycle hot water heater. So I get $1,000 worth of carbon credits on that hot water heater. The retailer keeps the credits and gives me a discount on my purchase, or I can purchase the credit and purchase the technology for $4,000 instead of $3,000. And then it's up to me to sell that credit if I want to. So I'm saying let's ask the information bodies. This is just an idea as a community member. It's not what ANZBIG thinks. It's just me. But let's create a carbon credit at that point of the creation of the biochar with a life cycle assessment. We know that it is a carbon removal tool. Then we use that biochar that's made, and then the biochar uses all these different uses. And if we mix it with something else, then it becomes a fertiliser. The fertiliser companies can then direct that to the growers and land managers, and ultimately create products that they do not have to change their equipment. You pelletize it or put it into your little fertilisers, whatever. Now, it's at the point where either the fertiliser companies or the growers and the producers actually sequester that carbon, is then they can redeem that credit. And I'm saying let's make sure that the person that creates the biochar doesn't necessarily hang it out on the global market, and then it's purchased by some third party who uses it to offset their emissions. Let's sort of, this is my idea, just not to be able to redeem that credit until it's actually used. Okay, so then we've got the growers contributing to earth care management, and then the growers also have a relationship with the processors, the people that actually process their produce. So that's your Saputo, your Greenhams, and of course McCain's, all of those guys. And then of course the end product, the consumer will have been aware of the story, and we've got blockchain technology that can measure the transfer of the carbon through right to the end product. The end product, consumers then give information back to the information bodies. So our biochar has 3 levels of safety. We've got our full data sheet from the lab. We've got a safety data sheet. That's a third-party chemically authored sheet. So that's on how to use it safely. They actually asked me to test my biochar even further, arsenic and selenium in particular. That's in response to the Australian Poison Standard, the SUSMP. And if I do have excess selenium, everyone knows we put more selenium into animal supplements. They have to have that at certain times of their lives, and that's okay, but the SUSMP says you have to declare that as a poisons label on the packaging. So again, if you're creating a biochar product, you need to be following the laws of the packaging. And the third thing that we've got is quality assurance certification. So for every batch we make, we have to track the sustainability, the origins of clean, uncontaminated feedstocks, and we trace that all the way through to where it actually ends up, the client, so that if something goes wrong, like any quality assurance program, you're able to recall it. So I just wanted to present this picture from my idol, Stephen Joseph. He's a visualizer. And this is how we can talk about the different grades, and this is a scenario of anybody's farm. So Joey's put together this picture, and I really love it. And we want to, as a group, create more scenario pathways for biochar. So, for example, if you're civic use and you're planting trees in horticulture, then you can put biochar in a strata underneath the tree that helps to hold its water, to help it grow. But in this case, this is an agricultural scenario. So there is a missing link in here, but just in the middle there, he's representing an animal feed. So there was supposed to be a cow, but the cow's missing. So we have the cow eating the feed grade biochar. We're putting the soil grade biochar into what he calls reactive wells. And this is also, I think, something possible for the forestry industry when they're making, perhaps making biochar in their production, in their harvesting. If they're making it in the field, then you can use like a well or trench situation to make the biochar, but also add other nutrients to it. He's put other composts. So, and then also in the roads, for example, or underneath sheds in concretes and roads, you can use industrial grade biochar. So this one scenario, you can use all three grades. He's talking about the fact that once the biochar gets into soils, it's starting to migrate through the soils. And that's obviously with a lot of macrofauna that's moving it around, which are really wonderful. They're our sequestration armies. Just one thing that really compelled me when I started the biochar journey 2014 or so, this picture came from a Canadian forester. He said, well, if we start a fire from a pile on top rather than underneath, the emissions burn into each other and you don't have this smoke. Pretty simple. That's called a conservation burn. What have I learnt with working with animals in the last 8 years? Very big, strong message is that when I'm dealing with animal health all the time, that ill health derives from imbalance. And what I mean by imbalance is generally it means too much of one thing and too little of another thing. So we see this too much of one thing and too little of another thing in monocultures, and that's also our exponential growth model, isn't it? The exponential growth model takes us beyond, if we have to keep growing, we have to keep using resources and so forth, it takes us beyond our limits. And of course Tasmania island, and we've got another islander here from Taiwan, he's going to talk about his journey with biochar and his institute. Later in the day. So we need to be working within our limits and borders, and I remember in the 80s listening to a gentleman by the name of David Suzuki, and he was a preeminent environmental scientist, and he was talking about negative growth, and I thought, negative growth, even as a kid, you know, I thought that's not going to work. I was going to take that off. But if we think about ourselves as a circle, and if we use a new paradigm, a new dialectic, of designing progress, and I've used those words semantically in purpose, because progress doesn't mean growth, but it does mean moving forward. And we're using our engineers, such as Craig and other people, to design progress. So we're moving forward. Nature's balance includes diversity. We'll only get balance through diversity. So in all of our work, including all of our production in forests and so forth, it's important to consider and support multiple entities. So this is what happens when there's imbalance. The sheep are put onto a harvested, irrigated barley crop, and the digestive systems just couldn't handle it. So a lot of that scouring is dead microbiome. And they, you know, we set the animals back because they haven't got the food that they had before, and now that's all dead microbiome coming out. Ill health. So biochar for immunity. We've got carbon, nitrogen, oxygen, hydrogen I mentioned before. And these four main elements, comprise everything we see around us and everything we don't see in terms of our excess greenhouse gases. But they are building blocks for life. So using the biochar with animals, we're just supporting the natural carbon cycle. It's in food, animals, manure, and then the soils. So you've got our greenhouse gases, all these different things, combinations of these elements. So I'm, as a community member here in Tasmania, I'm asking for a future agronomic paradigm at UTAS. We've got the new tier hub coming, which is the Tasmanian Institute of Agriculture, and Australian Forest Wood Innovation Hub at Newnham here. And I'm going to put up my hand and say, can we include biochar in this new hub? Millions and millions of dollars are going into it, and this is a time now with the community support to say, let's have appropriate lab testing, trialling, training and education so that we can have a new agronomy. They're already having sustainability and regenerative agriculture courses at UTAS, and we want to have that paradigm of giving back to soils. We've been taking too much out and not giving back, especially because we've got a problem up here because we've been taking it out of here. So soils are our super sequestration sponges. If we really get the soils working, we can get that negative priming happening. We can be drawing down. Our soils are our biggest bed. That's the carbon cycle that I've got on my website. It's free for educational processes, publications. We're seeing the dung beetles. Dung beetles are important really important for soils. So they just swarm, and it's basically overnight. Now this is a very favourite guy in our whole Australia, Bernard Dahl. It's really hard to see, but when you're there, you can see that actually the dung beetles, there's a trail of dark matter that's going through the soils to break up anaerobic clay soils. And then the plant roots are actually following that trail of nutrition, and because it's opening up the water. I was at the dairy conference a couple of weeks ago, and this was from AgLogic presenter, just showing how difficult it actually is to get water into soils. The blue dye is showing what happens. It's not an equal and even distribution, but if we've got that macrofauna constantly, getting that carbon down at least 50 centimetres, and there's obviously lots and lots of doing this, as well as worms and everything else, then you're starting to get even more water penetration. So where's the beef? Remember that saying from McDonald's? I think somewhere 20 years ago. So where's the beef? So I just want to give you a brief overview of the different evidence of our work the last 8 years. We're involved in a UTAS tier MLA trial, 22-23. So this is a start, the 6-month weaner calf, so it's a beef growing trial. The weaner calves arrived at the property. So we could see that they were very depressed, low weight, dull coats, a ringworm, that's a ringworm on their face, and then scouring. So the ringworms, it shows that they have poor immunity. So a few months later, you can start to see that they're sort of starting to fill out a little bit, but the biochar feed char was put out ad lib, and that means that they are actually free to eat it as they want to, weren't force-fed it. We did, as consultants, ask them to actually use the feed char as a base for adding other things based on the season, because the green grass is different, obviously in summer to winter or autumn and spring. So what happened is after ad libitum supply, we noticed, sorry, I'll just go back there quickly. Whoops. Oh dear. Thank you. I've never done this before. Okay, so we saw that on average over 12 months, we normally would have taken them to 18 months because they're usually grown to 2 years. And their average consumption was over that 12 months was 50 mils, and it cost 10 cents retail per day. They waxed and waned based on the season. They scoffed a lot at first, and then they went off, and then they came back on in autumn and spring. So the results, we did get a significant weight gain from the treatment group over control of 26 kilograms on average across the mob. If we had taken the trial to 18 months instead of 12 months, we would have got probably even greater. And I would love to know, anybody who knows how to model, what we actually would have got to. It would be great to have got to 10% extra. And that's just the addition of feed char, nothing else. we've got results, we've got production results, and we've got a profit. The producer said they were the best spring drop we've had. There's less illness. You can see those bums. There's no messy scouring. They're just because they're using everything that they're eating. It's being converted, and of course, when the animal's not ill, that means that their energy is put into production. They're not stressed, goes into production. So the question of methane, well, if you're finishing your cattle earlier, it means that they then go to their meatworks earlier. So they're not on the planet producing methane, are they? So if we think about it that way, we've also got cattle finished earlier. They're along with feed and labour savings. You're not feeding them for that extra time. So here's our farm manager. They just put a cubic metre of feedchar into the feeder, and that moved around as the cattle rotated. They found that was easiest. The cattle don't like it wet. The other question I wanted to know from the results of that trial is, you can see from the control to biochar between autumn and spring, they took forage measurements from the pastures. And I was interested to note that the biochar between the two periods, you can see the 21.5 as opposed to 13.9, and that's increased clover. So we're doing work with drought-resilient clovers, or not we are, but the UTAS is. They want to have more drought-resilient plants, and this particularly looking at clovers being the legumes. So I'm asking, is this evidence here, even in our small little trial, that adding biochar through the animals may be helping to increase clover? And we're certainly seeing that with our clients. That's the surface area. Like, if we're talking about surface area, we've got up to 1 gram of feed char has close to 300 square metres of surface area. That's just to put in a bowl. You can see where that inert material, it doesn't change its form with water. And so that's travelling across all the surface areas in the gut and in the soil. That one, I've just shown you that if you shake it up through water, it's just phenomenal coverage. So that's covering everything in the gut and helping to stimulate digestion. If you leave it, then it will just float to the bottom. So a glass jar experiment, the in vitro experiments are more difficult, I think, to actually get an idea of how it works in the gut than in vivo working in the gut. So another exemplar family that we've been working with for the last 7 years, he's been supplementing his dairy farm with biochar. He's been starting with the calves. We find that the earlier that the young ones can get onto the feed chart, the better they'll become. So the Dairy New Zealand has put together a table that says, okay, at that age of 15 months, if you can get your heifer to 360 kilograms, then you know, according to Dairy New Zealand, you're doing pretty well for that animal. A cow, yeah, beg your pardon. So the reason that they're asking that is because we know that pre-joining, the heavier the heifer is, the cow is, then the better she'll be a producing animal. So that, you know, if she's lighter, she won't be as a productive animal in her adulthood. So the aim is to put that condition on the cattle before the first joining. And our farmer had an average of his heifer group at that age of 390 to 400 kilograms. So he's producing really great adult cows, and it turned out to be proven in his production and his profits. And that's just from health. We're just talking about supporting health from the ground up. So I was very, very happy for him for that. But he's also got good genetics. You can't have great genetics and not feed it. So with biochar and feed char, we're compounding the benefits of the feed. They also are within the top 30 of the health weighted index in Australia by dairy breed. So for the Holsteins, Mount Heathorn for Saputo was consistently had the lowest cell count for their milk, which means that there were less infections. And what ended up happening for them after 7 years, this is also on our website on the blogs. So he was able to reduce his DAP, his diammonium phosphate application on his property by 70%. And it's difficult for farmers because every time their production returns go up, then of course their input costs go up. So the fertiliser costs go up and everybody starts to capitalise on the money that's coming in. So appreciate that the farmers really struggle to get ahead, but if they've got a mechanism to actually reduce that input cost, that's a profit to them. So he also said the cows were healthy and there was no need to drench for 3 years. So you test for your fecal egg count, and if there's no fecal eggs there and there's no worms, well, why drench? And the problem is with the drenching, of course, is it kills the worms in the gut, and then it also kills all your macrofauna in the soils. So the less drenching you can do for your animals, the better. You'll be sort of supporting all the dung beetles, worms and so forth that are actually creating water channels, and water channels for increased soil carbon come through. And also the health benefits, of course, no mastitis, no laminitis. I wouldn't like to have very sore boobies and I wouldn't like to have very sore feet. But that can come, and I see it coming because they're constantly pushing the animals in one way of producing called acidosis, which causes a lot of illness. If we don't have acidosis, as I said, we're just supporting her animal health. And that's all I want to ask for her. So every time he turned a clod, worms, dung beetles, he had so many dung beetles, they actually started to invade his house. He had to drive around in his buggy and, you know, with a visor on to sort of keep them off his face. And this is his funny stories. So we're aiming to, again, build pasture diversity, and as I said, the clovers were coming through. These are our photos from his property. And the main point I want to say is, this is what really gives Steve and I such confidence to keep progressing in this very, very hard work, and the intensity has just been phenomenal. I can't thank Steve enough for being inspiring and leading in this. But if we've got farm health, we've got animal and production performance, we've got profit, we've got sustainability, we've got very happy and emotional well-being of our youth coming through. This young lady was responsible for growing the calves and then growing her heifers. And I'm very proud for that family. When they started the biochar journey 7 years ago, they were teetering on financial difficulties, and now they've just sold their farm for 1.5 times what they bought it for. So we may have limits and boundaries, but by designing progress in a circular way rather than expecting to continue on an exponential, unsustainable path, Tasmania can be an exemplar on the world stage. We may have limited boundaries, but we had unlimited opportunities to be a world exemplar, and I'm very proud of you all, and thank you so much again.
Hi, hello. Thank you, Karen. Wonderful, and thank you for all the presenters this morning for a great morning session. We're going to break for morning tea now, and we're going to have about 20 minutes. Yeah, we were just going to see if we can
Actually,
video.
sorry.
Yeah.
Sorry to. Yeah, we're actually running way over time, so we've eaten into our morning tea time, Don. So I think we really need to catch up. We will play. I think we'll play that at some point today, Don. But we are.
Hey Sam, I can't hear anything.
Karen, because she's put so much work into the conference, and that was just amazing, that presentation. We've got Joey waiting online. I think we're going to end up running about 20 minutes over at the end of the day, but we'll, you know, at the end of the day is the discussion, so if you need to go at the end of the day, you can. So I think we'll just keep with the program as is.
When do you want me to talk, Sam?
But if we can aim to be back in here by 11:30, what's the time now? Maybe just after 11:30.
Just mute yourself, Stephen.
20 minutes behind, but we'll try and catch up towards the end of the day, and Don will play that. I mean, maybe we'll put the video on. Those that want to watch it on your way out. Otherwise, it is on our website, and it goes for just a couple of minutes. So if you do want to watch, otherwise, come out and have a cup of tea, and we'll try and come back in within the next 15. Thank you for the fabulous sessions and Karen's presentation this morning as well. And I just really, before we go, I wanted to introduce Craig Bagnall, if you'd stand up. He sits on all of the advisory boards, working groups, and he's also at the chair of ANZBIG. And he's going to introduce himself and facilitate the sessions after morning tea. Thank you. Sorry, Don, to cut in, but I just, we're running out of time. We're way over. Yeah. Oh, he's not playing it. I thought he might.
Thank you for your patience. I'm Craig Bagnall. I'm environmental engineer. I'm on the executive board and technical advisory board with ANZBIG. Just like to welcome everybody and thank everyone for their time this morning. We're very lucky to have a fantastic program with some esteemed people. As you heard this morning, we've had some really good presentations. We're now about to hear from somebody who's world recognised in this space in biochar research. So Professor Stephen Joseph is a visiting professor at over 5 universities. He holds a Bachelor of Applied Science in Metallurgical Engineering and a doctorate in Architecture and Applied Anthropology. He's a Fellow of the Australian Institute of Energy, a Chartered Engineer, and has been a Senior Advisor to both commercial, government and non-government organisations in renewable energy and sustainable agriculture and forestry. He has extensive experience worldwide in all forms of renewable energy, including biodiesel, oil from algae, biomass combustion, pyrolysis and gasification plants, biochar, plastic wood composites, microhydro, wind and solar energy, and additives for high-strength concretes. He's been involved in multi-country market research into areas related to biochar, waste recycling and renewable energy. He's written over 100 books and articles and lectured and trained other engineers and scientists throughout the world. He's a founding vice chairman of the International Biochar Initiative and co-editor with Dr. Johannes Lehmann of the Biochar for Environmental Management book, which is world recognised. He served on the committee of the Australia-New Zealand Committee and was a founding member from 2017 and to 2020. He's currently a visiting professor at University of New South Wales, University of New England, University of Wollongong and the Nanjing Agriculture University in China. He's also a founding member of the IBI, Bioenergy Australia and ANZBIG. So please welcome Professor Stephen Joseph.
Thanks, Craig. I hope you can all hear me well. Sorry, I can't be with you. I'm heading off to Indonesia very soon. So I'd just like to acknowledge where I learned about biochar, and it was from Indigenous people up in Arnhem Land, where I worked for 3 years. It's great to see that we're starting to actually take on board the huge knowledge base they have about caring for country, and making biochar as part of that knowledge base. Okay, so basically you can make biochar from most sources of biomass. As a group, we say it should come from sustainably harvested biomass and from residues that don't have a higher value purpose. The best sources of biochar, of course, come from biomass that actually is a waste. And in many countries, invasive species, animal byproducts, biosolids, and residues from processing industries are quite often burnt on the land or buried, and we think that these resources should be converted to biochar. One of the things that the industry's focused on is that the biomass should have reasonably low levels of toxic elements. And I'm going to talk a little bit more about that. What do we mean by reasonably low levels? It's something that has been a continual level of discussion of what are safe levels of heavy metals and toxic organics in biochar. I just want to really talk about where the industry is going. And what do we know about the properties of biochars in relationship to the benefits of for crops and for soil? Essentially, biochar is produced from topsoil manures, biosolids with low heavy metal content, or from wood that has been preloaded with minerals and then pyrolyzed, give you the greatest increase in yields for most plants in most soils. We also know that biochars made at low temperatures, 400 and less, actually are more effective in both giving crops an increase in yield and also greater resistance to disease. The greatest benefits we've also seen when you apply biochar to low nutrient, P-absorbing acidic soils, and in sandy soils and drylands due to the increase in nutrient retention and water holding capacity. As Annette Cowie mentioned, what we're finding is that you get your best bang for bucks is when you apply these nutrient-rich biochars at low application rates in the rhizosphere. There's been a lot of work done on looking at overall results, what we call a meta-analysis of application of biochars with and without fertilizers. And the general consensus is that biochar added with fertilizer can increase average crop yields by 42% compared to an unfertilized control, and can increase yields by 22% compared to a fertilized control. So there's a big difference, and one of the interesting things is for areas where farmers can't afford a lot of fertilizer, biochar can make a big difference both in yield and return on investment, and we'll talk more about that. Biochar applied with fertilizer can increase average yield by 15% compared to a fertilized control. And in actual fact, the 15% is an average. We've done trials when we've seen up to 50% increase in yields. And in a very small number of cases, we've seen increases of 100%. So we've talked about this in a paper that you can download, how biochars work and when it doesn't. I don't have time to go into all of the numbers. One of the interesting things that comes out of these meta-analyses is that biochar actually works better as it gets older. I quite often say to my younger students that I think actually my mind works better now than it was when I was in my 30s, partly because I've had a lot more experience, and partly because you just had that intuition that comes from working with a particular substance like biochar over the 45 years that I've been working with it. The highest increase in yields from trials with non-fertilized controls occurs in the first and second year, whereas with the fertilized control, it's in the third year. And it's really interesting why that happens. Unfortunately, I don't have time to go into this, but maybe in another webinar, we'll talk about it. I just wanted to really emphasize the fact that when you take a biochar, you send it up to the lab, you get a series of measurements. As soon as you put that biochar in the soil, its properties change. Now, how quickly those properties change depends on the soil. So if it's in a sandy soil, it doesn't change as quickly as if you put it in a clay soil. If you put it in an acidic soil, it changes much more quickly if it's in a neutral soil. And what and Annette mentioned this, what we know is that basically you get these really very small, porous, highly reactive microaggregates that form on the surface. And if you look at the middle picture, you can actually see that you can't see the pores of the biochar anymore because there's these tiny little round structures, which are basically a mixture of minerals and organic matter. And what happens over a period of time is the biochar actually gets taken into the micro aggregate structure in the soil and then the macro aggregate. What we find is that when we take these aggregates and we open them up, you find little bits of biochar in them. And those biochars are actually protected, and they're protected probably for thousands and tens of thousands of years in the micro aggregate structure. Okay, this is looking at some of the effects on yield. You can see that basically animal waste and sludges give you the best increase in yield. You can see that low temperatures, less than 450, give you the best yield. Soil pH, we see really quite significant changes when you have soil pH of greater than 7.5. Now, this is interesting because when you have high pH soils, you really need to have an acidic biochar, whereas if you have low pH soils, you need to have a biochar that's a basic biochar. Again, when we start looking at application rates, we're seeing very mixed results. And the problem is that application rate has an effect, but the effect is not as great as where you put the biochar. So if I put biochar in the soil and mix it all through the soil, it's not nearly as effective as that I put it in the rhizosphere. In other words, around where the roots are growing. And it's that interaction between biochar and roots that really gives the maximum benefit to the plant. I'm just going to move. I can't actually see my slides because there's... Okay. Let's talk about nitrogen. One of the interesting things about biochar, it can increase the nitrogen use efficiency, but not necessarily, can actually decrease the nitrogen use efficiency. And so again, when you look at all of the studies that have been done, you get some increases and you get some decreases. And that's to some extent a function of temperature. And so you can see the low temperatures give you a better average increase in nitrogen use efficiencies. Then the temperatures from 400 to greater than 500, pretty much similar. And you see very little average increase in nitrogen use efficiency. And what we find is large applications of woody biochar can increase the carbon to nitrogen ratio, reducing the availability of nitrogen, and increase the loss through volatilise of ammonia. Adding an additional source of nitrogen can bring the carbon to nitrogen ratio back down to about 30:1. And when you do this and you limit the application rates to below 10 tons of hectare of this nitrogen-rich wood biochar, you can actually see a significant increase in nitrogen use efficiency. And of course, when you use a high nitrogen feedstock, like poultry litter, then your nitrogen use efficiency goes up. Not doing that. Okay. I want to talk about biochar properties and water holding capacity. Again, quite complicated. When you put biochar into soil and it ages, its water holding capacity changes. And there's a whole bunch of really complex reactions that relate to this water holding capacity. A fresh biochar that's made at high temperature, that has a high porosity and a high surface temperature, will give you an initial high increase in water holding capacity. It's great. In my own garden, if I'm approaching a very dry period in summer, I actually add wood biochar and straw biochar made at high temperature. But what happens is that as this biochar, as the biochars interact with soil organic matter and soil mineral matter, the surface of the biochar changes, and these little micro aggregates that I talked about are highly porous, and they're actually really good at holding water. So again, as biochar ages, the water holding capacity actually goes up. And there's another factor. Biochar increases beneficial microorganisms, especially fungi, if you have the right sort of biochar. And that in turn can increase the water holding capacity of the soil. Come on, why? Okay. Right. I want to talk a little bit about biochar reduces heavy metals in plant tissue. One of the big questions that has never been answered is the acceptability of biochar is often based on measurement of its heavy metal content. But what the science says is that biosolids and sewage sludge and manures actually can work very effectively at absorbing heavy metals, binding heavy metals, and stopping heavy metals going through the roots into the plant. And so one of the things that we are trying to get the regulator to understand is that you cannot base the suitability of a biochar on its total heavy metal content. You need to carry out tests that look at the bioavailability of the heavy metals and how that bioavailability changes as a function of time. Just to really emphasize this, that biochar's ability to make heavy metals not available for plants is both a function of age and the feedstock and the temperature of pyrolysis. And that's why when you look at this meta-analysis, you see a wide range of results for different heavy metals. So in some cases, you see a reduction in the availability. In some cases, you actually see an increase in the availability. So you need to do the tests to actually show if your biochar is going to reduce availability or increase availability of heavy metals. And that especially applies for manures and sewage sludge and biosolids. Okay. One of the fascinating recent research results is the fact that the pyrolysis of biosolids can eliminate these forever chemicals that we call PFAS and PFOS, and also it can eliminate microplastics in well-designed pyrolysis equipment, and it can meet most heavy metal regulations. It can also absorb heavy metals. And I've just put this slide up from a paper by a group in Melbourne at RMIT. I think it's available online. It's definitely worth reading. I don't have time to go into all their results. I just want to briefly talk about biochar and changes in microbial population. It's really important to understand that low temperature biochar additions in low pH soils greatly increases the ratios of fungi to bacteria. If you want to increase your fungal population, use a low biochar, a low temperature biochar. Crop residue biochar application in dryland soils increases the ratios of what are known as gram-positive bacteria to gram-negative bacteria. Basically, these, very simply, gram-positive bacteria are really good at helping plants grow. Biochar nutrients and structural properties play the important role in soil microbial communities' structural changes and activities. Basically, what happens is that different bacteria and fungi grow in different parts of the biochar. The more nutrients you have, the more diverse bacteria and fungi grow in the pores of the biochar and on the surface of the biochar. And it's a really complicated system, and I don't really have time to go into this. But what I tell people, if you want to actually increase your fungal growth, fungi like phosphorus, and especially arbuscular mycorrhiza fungi. So load your biochar with phosphorus. One of the reasons why poultry litter biochar really increases fungal growth is because it has a high concentration of phosphorus. Wood biochars don't have a lot of phosphorus. So one of the ways that people increase the ability of wood biochars to increase mycorrhiza fungi is they actually treat the surface with a small amount of phosphoric acid. It puts phosphorus on the surface, which is available for fungi, but it also increases the concentration of biochar functional groups, which actually bind nutrients, what is known as cation exchange capacity and anion exchange capacity. Okay, I just want to mention that the way you introduce biochar into the soils has a major effect on the production of both plants and grasses and trees. And the cheapest and best way of doing it is to feed it to cattle and then make sure that you have really active dung beetle populations that work both in summer, winter, spring and autumn. This is a study that we published from the work that was done in Western Australia. Doug Powell was the farmer. He'd been feeding biochar to his wood biochar to his cattle for 3 years, and we saw a really large increase in both carbon soil, nitrogen, and soil pH. Okay, I want to talk to you about biochar liquid fertilizers and foliar sprays. And I want to talk to you about actually in-ground composting of biomass with biochar in trenches and what you can actually achieve. This is a pasture trial that's ongoing and a farm that Russell Burnett and his partner have down in Berrigan in the south of New South Wales near the Murray. Basically, we made a trench, which we call a reactive barrier, and we filled the trench full of dung and straw and biochar. And on one side, they just applied urea. On the other side, we applied a liquid biochar at 200 kilograms a hectare. And that biochar was loaded with minerals and nutrients. We use an organic nutrient called Charlie Carp, which is a fertilizer made from carp that are invasive species in the Murray. And what we find is that these liquid fertilizers actually migrate from the surface onto the roots of the plants, especially the grass. And you can see that after a half an hour, that basically, sorry, a half a year, the yield on the side that didn't have the liquid biochar was 9 tonnes a hectare. The other side was 17 tonnes. Similarly, trials in with vineyards where they actually bury a mixture of biochar and compost have found fantastic results. I know I'm over time. This is some work that we've done on looking at the effects of biochar on soil carbon. One of the things we find is that if you put biochar into the soil every year, you can have a much greater effect than just a one-off application. This is the schematic that Karen showed with the cow in it. Since she's already talked, I'll leave that. We're doing work at the moment. We've just finished the first phase of an experiment. And what we find is that if you put these trenches in photovoltaic farms, the water that comes off the photovoltaics at night can be stored in the trenches. And those trenches can actually promote both plant growth and pasture growth, and so that you can actually still have a productive agricultural farm along with putting in photovoltaics. And I just want to ask people, we've put a draft of the Farmer's Guide. We're asking people to read it and give us feedback on both the content and clarity, and whether we should actually have more information on specific subjects. So yeah, thank you very much for listening to me.
Thanks, Stephen. Fantastic as always. Stephen is an absolute wealth of knowledge, and we're very, very, very fortunate in ANZBIG to have him as our founding director and our lead for our research, of course. So thanks, Stephen. Stephen normally would be talking about what I'm about to talk to, which is the technology. So obviously you saw his background on the last few slides. So I've been asked to see if I give us a rundown on what our industry does and the different technologies available. So this is my talk, and basically it's a phrase that one of the guys in our company, CETA, says a lot, is with bioenergy and biochar together, you can have your cake and eat it too. Basically, we can have drawdown as well as renewable energy. Okay, so I'm going to run through why, how, what, who, and what's emerging as well. All of these slides are available. I'm going to try and set a record for number of slides here, so I apologise. But there is a lot to cover, so it's all available. So anything, I won't leave slides up for long, but we'll run through them pretty quickly. Righto, so why do it, as I said, can we actually get sustainable energy and remove that excess carbon from the sky at the same time? And nature, as I just want to actually acknowledge Harold's talk this morning. I thought that the Welcome to Country was absolutely fantastic. Biochar is not new. It's been around for thousands of years. And I like to say that what we've got now is modern technologies to practice an ancient art form. I think the more that we have synergies with Indigenous land management is something that we really can build on for this industry. So as always, it comes from nature. And solar and wind is great. What we've got here too is 3 billion years of photosynthesis. And what we do in our industry is to start look at the building blocks that are made by taking water vapour and carbon dioxide from the sky and photosynthesis, turning that into carbohydrates as these building blocks for glucose, cellulose, and then lignin. So as you look at technologies and look at feedstocks, you'll talk about cellulose-based feedstocks, lignin, and semi-cellulose-based systems, where you start to look at the structures. And if you think of it a bit like diesel and petrol, short chain and long chain hydrocarbons, the more complex the structure, you head towards more hardwoods, and your less complex stuff is more like your grasses. And as you can see, it's absolutely loaded with hydrogen and carbon, and this is where you get a lot of the energy value in it, and where we can get biohydrogen as well. So yeah, plants take it out of the sky, and then what we can do is then to hold that down, as we talked about before. Plenty of carbon, hydrogen, oxygen, which is what we need for syngas and for biochar. We've already seen this one before, so I won't go spend any time on it. But the key thing here is that carbon is right at the heart of the food and energy and water nexus, but it's also at the heart of our materials. Just like fossil carbon is, you hear about scope 3 emissions, which is the entire supply chain. There's the ability by displacing fossil carbon for it to be scope 3 sinks. And that's the next phase. So we're going beyond just replacing power and burning coal or whatever. We start looking at displacing fossil carbon through the economy. Very quickly, why biohydrogen? It's the lowest cost of hydrogen that we can get, much less energy and infrastructure than going through green hydrogen through electrolysis. And it's also the only one that's carbon negative. And that's why, these are 2 slides that we use within CEDA, but I wanted to just flag that in terms of the energy transition. So we'll come back to that later. There are multiple converging drivers of change. I was talking to the guys from Tasmania last night. Phil's got a background in insurance. Do you like that slide down the bottom right there, mate? Basically, we're seeing climate change is uninsurable, and as you start to see both financial disclosure reporting coming in, as Annette mentioned earlier this morning, and we see the true, the elimination of greenwashing and true net zero and drive into drawdown, we're going to see a real push towards carbon dioxide removal, and with sustainability and with multiple co-benefits, and that's where biochar really comes into its strength. We have aligned all of the roadmap initiatives with the UN Sustainable Development Goals to try and bring that in as sustainability reporting comes into focus for companies as well. Puro Earth's founder, Marianne Tikkanen, she often said by 2050 the carbon negative economy is going to need to be as big as the oil industry is today, and that gives you an idea of the scale and the challenge ahead of us. Displacing peat, fertilisers, carbon black and activated carbon, recycled anode carbon and coking coal are sort of some of the big markets that people are looking at. And as you can see by the price points, that's the big variance in where your target market goes. So when you're selecting technologies of what you want to make, you need to start with the end in mind, which I'll go to shortly. Just wanted to just build on those discussion too about why you'd want to be acting and looking differently on how we manage our feedstocks. We're seeing significant air pollution issues like we saw in Sydney last year. You couldn't even see the Sydney Harbour Bridge. And we're seeing health impacts, particularly on the elderly and the vulnerable, with impacts to air quality. We're seeing economic impacts with roads like the Nullarbor being shut down by bushfires and floods. And and when you actually see the scale of the combustion of carbon going back up, we're losing our sinks as fast as we actually need to be sinking them. So you're getting a double whammy. So many feedstocks up to 6.6 gigatons. It's the lowest cost, but the big thing is that we can enhance food security. We don't need to compete against it, and that's what a lot of Joe was just talking about. And that's a very big difference between the combustion of energy from biomass, which is a linear waste energy, compared to circular technologies, and that's why ANZBIG's looking to decouple combustion, which is basically last century technology, and let these new emerging ones come through. Bit like the old brick mobile phones being replaced by an iPhone. Another reason too for the transition everyone's looking at this sector is that biological treatment systems are limited on their ability to deal with chemical contaminants, particularly PFAS, pharmaceuticals, microplastics. Everyone's saying microplastics is PFAS's bigger brother coming through, which is scary. But what we're finding is we can deconstruct those safely to their base building blocks. And that's now been done globally by a number of technologies, including here in Australia by the guys at Pyrocal, and also with South East Water have done that successfully. And we're seeing EPAs in at least 3 European countries allowing biosolids-derived biochars that can have these emerging contaminants in it be put back into agriculture safely into the food system. The peak body for the water utilities nationally is working closely with ANZBIG on this front to basically sort of look at this as a way forward for water utilities. Okay, so how? Start with the end in mind. Chars ain't chars, as they said before. It's a phrase that one of our older statesmen and leaders in this field has said for many years. Stuart Larson and Joey have both sort of coined this for some time, and Lucas Van Zuyten as well. And that's basically because we can get different feeds, different processing can give you a different char. You can still make a nasty char out of a good feedstock if you process it wrong, which is why we're very focused on creating standards and making sure that that's right. And you need to match your feedstock and your technology to what your end market is too. So thinking about all this feeds into what I'm about to go to with the technology. So horses for courses is the bottom line. Okay, so which horse do you need? These are the questions you really need to be asking. So I'm going to give a very brief slide on each of the technologies, but these are the questions you need to be looking at in choosing them. The biggest one probably, well, how much are you dealing with? You don't need a sledgehammer to crack a nut. If you've only got a very small amount of biomass and you're a little local land care group dealing with weeds or something like that, you don't need to have a cedar plant like one of ours on site. You can do it with a small scale system. But when you look at industrial scale stuff where you've got, say, about 7,500 to 8,000 hours of runtime in a year, if you've got, say, at 1 tonne an hour, that's about 8,000 tonnes per annum that you can process for each unit. If you've got hundreds of thousands of tonnes of feedstock, it's pretty hard to balance that. So whilst you don't need a sledgehammer to crack a nut, you also sometimes need a bigger tool to deal with the job. So it's about matching that up. Whether it's mobile or stationary, your proximity to your feedstocks is big on the economics. Transport's critical in Australia. Whether it's going to be batch or continuous, manual or automated, is it going to be pyrolysis or gasification or some other kind of thermal like hydrothermal in the future? Is it a moisture? This one's the big one too. Is it a wet feedstock or is it a dry feedstock? That's absolutely critical to mass and energy balance. And what's the outputs that you're looking for? You're after biochar, the bio-oils, gases or heat. If you want heat, that's what we do at the moment, which is combustion, and that's an inefficient way to get power. Thermal efficiencies are the big ones. So as I said, indirect heating versus direct heating is a major sort of shifting point at the moment. And then your materials handling, all those pre-treatments or shredding and pelletization, or also materials handling after you've made your biochar. What's it need to be to deliver to the market that they want? Temperature, as Joey said, if it's high or low, what's the heating rate? Is it flash? Slow pyrolysis is where most of our industry works. And that's, whereas flash pyrolysis is like, done extremely quickly and you'll produce mainly liquids. Project duration, is this a project's going to last days, weeks or years and decades? So, uptime and maintenance become pivotal at scale. So you need to be understanding what that commercial uptime is. So you need to be asking, particularly if you've got tars and resins causing glugging up of the system, how long is it down for when it's down and how often? What are the wastes being produced? How much air, how much water does it need and how much electricity for startup? Some systems actually run on external power, so you've got to actually ask those kind of questions too. And of course, the big one, where are you operating in terms of regulatory frameworks? In some states, like currently in the ACT, that's the hardest place, it's fully banned. All thermal treatments are banned in the ACT at the moment. In New South Wales, we've got a very tight framework. It's hard to get through, but they're starting to see these differences and they're looking at pilot pathways and innovation pathways to pull us through. So fit for purpose and making sure you match your market and end use with what you can start with as well. So combustion versus incineration versus gasification pyrolysis. So with combustion, you're getting heat. So you're producing carbon dioxide and water. If you look at the bottom left there, it's a scale of increasing amounts of oxygen. So pyrolysis is when we starve it of oxygen. Gasification is in the middle, and combustion is when we've got excess oxygen. It's like when you light a campfire. If you want more charcoal, you just starve it of oxygen. You're stopping C from converting to CO2, and you're keeping it down as solid carbon. So very different products of gases, and the difference is with combustion, you're getting carbon dioxide and water. They're not a fuel. In gasification pyrolysis, the synthetic gas that comes off, syngas, is a fuel. It's actually something that can be used as a fuel, and if you get it pure enough, you can then make it into a lot of other things. So the key limiting factors are, well, on the right-hand side is the proportion of typically what you'd see. You see about half of biomass is carbon, which is why half the carbon drop into biochar if you in the upper. And it's about 6% hydrogen, which is about how much we can recover too through a good system. With air, if we're using combustion, you've got 80% air and 20% oxygen, which is the oxygen's the bit that does all the work in combustion. So you've got 80% waste, and that is huge. That's why we have big emission control systems and very large capex. That's why waste incinerator in major cities around the world are $600 million euro in Europe, and the latest ones here about 600 to 700 million, like Kwinana over in WA. Went the wrong way there, sorry. And if you've got a clean syngas that isn't diluted, that's where the economics come in about driving this. And you'll hear a bit from Optimal Group later on. Cedar and Optimal are both working on making these derivatives with syngas. So yeah, we can burn it for energy, but if you can make it at the right way, you can then use it as a gas pathway back into all of these fuels and liquids and all these other things. So ammonia into fertilisers, and all of these other things, replacement for natural gas. This is where this industry really has a future. People are looking at drop-in biofuels as a big spot. So we normally see a solid liquid and gas outcome from most pyrolysis systems and heat. Biochar that you know of, as I said, slow pyrolysis is normally about 1/3, 1/3, 1/3. And as I see there in flash pyrolysis, you're getting 3/4 bio-oils in liquid phase and only 10 to 15% of solid or gases. And very different characteristics, very different chemistries. So gasification, couple of different types. Very commonly updraft or downdraft gasifiers. Top-down conversion is where you see that's what they call that downdraft. It needs a dry fuel input, but it makes a high quality syngas, which is the most important thing. All of these systems end up needing to have significant emission controls like thermal oxidizers, or known as afterburners, you might have heard, or scrubbers to deal with some of the materials, particularly when you've got halogens. So if you've got plastics or you've got natural material that's got chlorine in it, you're going to see a need to deal with halogens. And that's to stop things called dioxins and furans that the regulators don't want to see form because they're carcinogenic. So we have to make sure that we've got good emissions controls on our systems. Oh, wrong way again. Fluidised beds, this is what we're working on with CEDA. It's more scalable and more flexible with multiple different feedstock types, and it has a very high quality syngas. As always, there's trade-offs with all these things. It's about trying to match what you need to do, but fluid beds are where we can scale to industrial scale. I won't leave this up for long, except it's basically a traffic light system comparing, there's two slides, one with economic performance and one for environmental, incineration versus conventional air-blown gasification and conventional pyrolysis. And as you can see, depending on what the key drivers are in your system, you'd be looking at that. But one thing with all the red in incineration and environmental, it is the worst one by a long shot. Pyrolysis is the greenest thing we can be doing, but it doesn't scale well. It's hard to get pyrolysis to go beyond 1 tonne an hour. And that's been the holy grail, to see if we can scale it up into something like incineration that might run at tens to hundreds of tonnes per hour. So how do you compare the fruit basket, apples, pears and bananas? You either grab an expert like Tom or Stephen. Tom's USBI expert in this field, and Stephen's probably the leading expert here in Australia, that are both independent and able to go through technologies. RMIT is working for the water utilities, building a tool for comparing technology, particularly useful though for biosolids. They're also now looking at expanding an Australian research centre based in Melbourne into FOGO and other things as well. Okay, Australian technologies and a few from overseas. We've got a list on the ANZBIG website that does list our different technologies and a little bit of a comparison. Basically broken down from everything from the little stoves through to batch kilns and continuous operations, whether they be fixed or portable. And as you can see, the feed rate, the big thing is that scale about, they all operate at very different effects, so you really need to be looking closely at that. So when people talk about a flame cap kiln or a Kentucky kiln, this is a system here where basically they have a flame on top, but underneath it's starved of oxygen, and it's making biochar underneath. So it's we're not recovering any of the gases. You're basically just making char. It's a good way to manage low cost biochar production and deal with the waste. Same with air curtains. This is a Tiger Cat, came out of the US and Canada. There's one operating up in Queensland at the moment. They've trialled it in South Australia, and I'm not sure elsewhere. Basically low yields, but a great way to deal with on-site waste management, being popular in forestry. USDA is doing work with it over there. I know Tom's quite interested in what it can do with dealing with the issue of trying to get transport out of forests. Is not easy, but you do need to manage them carefully. You can smoke them if you don't do it right. That's not a usual situation in the bottom right there, but you do need to manage them and operate them well. Australian technologies like Earth Systems, which is the longest one, based here in Melbourne, been operating, the largest and the longest operating in Australia. They have their batch system transportable on the back of a truck in a shipping container, and then they have their new continuous plant as well. At this stage, they're not looking to do stuff with energy, but it's a continuous system. Then you've got energy farmers. So Ewan and Tom from WA, Ewan hosted our Western Australian Forum recently, doing both batch and continuous on-site systems, mobile continuous systems as well. These guys are using, they've built their technology sorry, I'll come back to these in a second. They've built their technology based on some open source tech that Steve and Joseph has put together. The New Black, so it's a bit of a shout out here to Christina and the team and their fantastic work here in Tassie. So basically these guys have, to their credit, built a system out of at low cost out of all recycled materials but works very, very well. And they've been developing some high quality char there to deal mainly with targeting sawdust residues from their mills, which is, they're going to give a talk separately, so I won't spend too long on this. We've also got the carbon powered minerals up in New South Wales. So this is a carbon coated mineral material, it's not just a biochar. And that one there is based off one of Stephen's designs as well. It's been modified since. And there's been a lot of trials that they're doing with DPI, also on biosecurity with animals from disease management. Joey and Lucas did some work with them on pigs. Metamorph, so as Mel said, she's spending a lot of time with them. They've got a char cell 3, they've got a char cell 4 under development as well. And they are looking at doing with the energy off it. So this is where you can combust the syngas and you can create some energy off that, and you can start to deal with both heat. A lot of these places you use your syngas to burn for heat as a displacement for a fossil-based heat. Then we've got all things biochar. This is Russell Burnett, another, again, sort of working with some technology with Stephen and also with from people influenced from the US, based in Victoria. That's their system there, and he's a Hall of Famer with ANZBIG as well. Pyrocal, which we're going to speak to, sorry, not speaking, but they are one of the leaders in, they're here, so I think, so where Rob is. Well, anyway, yeah, they're here, so you can go and see them later on. But this is Jeffrey, so it's a composting company in South Australia where they've got one of their facilities there, working with symbiotically with their composting operations. And then the big one for them has been the flagship with the water industry. They were the first to go to a commercial scale system, which has basically reduced biosolids to going 300 kilometres to market by 90%. 80 to 90% is typical as a gasification system. So needs a lot of drying. So water moisture balance is sort of the big challenge with wet waste. So it really is all about good drying technologies and trying to get that there. But they are well and truly at the front of the pack on dealing with biosolids. Rainbow Beta, founding members of ANZBIG, Peter Burgess, former vice chair of ANZBIG. They've partnered with Optimal Group. They're looking, as I said, to do derivatives from the syngas, so not just burning it for energy, which they currently do, to where they pair up with their business model is pairing up with greenhouses and intensive horticulture like that, and then the biochar can go back into surrounding farms. Their pilot facility over near the Victorian South Australian border is taking wood waste from Melbourne, converting it into biochar. The combustion of the syngas is then heating the greenhouse to displace LPG, and that's where they get their big savings and their business model from. And then they are sending the biochar off to the composters up the road. And they're about, as Mel mentioned earlier, they've got a very large project coming on with about 16,000 tonnes per annum at Katunga Fresh in Victoria, hopefully very shortly, if not already up and running. They were the first group to sell carbon credits via Puro to Microsoft out of Australia, so very much leaders in the field. Biogen in South Australia, these guys have got a low temperature activation process to make an activated carbon, so they're not so much focused on biochar technology as they are on what you can do afterwards with it to get a really efficient way to make an activated carbon. And then H2 Biogen, these guys are looking at model technologies, but heading towards biohydrogen as well, so they're under development. From Europe, I shouldn't say Europe, this one's from Taiwan. We've got our colleagues here, I don't know if we can put their hands up, from the ITRI, they're speaking this afternoon. Just a quick shout out to them. I won't steal their thunder, but they have a very high yield biochar system they've developed. They've got nearly 9 or 10 demo sites in Taiwan, running on a retort system of a 2 times 350 kilo retorts, and with a lot of focus on almost nanotechnology, really, with dealing with really high quality products heading towards, as you can see there on that right-hand slide, microbes, and sizing their biochar to get microbes into the right pore sizes for products. Chartech in New Zealand, this is actually a Ukrainian technology, but it's distributed out of New Zealand. It's a batch furnace system for carbonisation, and depending on the moisture contents of their feeds, they can get some, they're looking in the range of between 150 to 500 tonnes per year of material that they can run through it. So it's a smaller system, but mobile, and some fantastic case studies, a really good website to go and have a look at what they're doing. From Europe, so European Biochar Industry Consortium, Pyreg and Syncraft are probably the two most notable names that you'll hear from Europe in technologies. Pyreg was actually here at Ozwater exhibiting last week, I believe, in Melbourne, very much targeting, they're leading the biosolid sector in Europe, and have partnered with some Facility USA as well on the West Coast. Carbofex and Carbonex too are also leaders in this space. Carbofex have signed very large long-term carbon credits at very high value with some of, I can't remember which company it was, but there's a lot of interest from people wanting to look into carbon offsets with carbon removals, and Carbofex has been leading with that. Oh, sorry, and one last one too, Standard Bio, based out of Norway. Again, a unit system in shipping container type sizes, batch system. From the US, this is Sardichar. Modular, this is typical of a lot of systems. You just have 1, 2, 3, 5. You can just add them up, and they just add a bit more cost as they go, but they have the ability to be paired into systems to make high quality chars and also look into energy. Polytechnic, Austrian-based technology, very, very high-tech, typical sort of German-Austrian engineering, specialise in boiler technologies, but also then got into this space in carbon. They have batch system that's retorts, but it's fully automated like a production line. So they just have multiple ones running at once. And I think they sponsored a dinner for ANZBIG a number of years ago, and it was very, very impressive. So Christian from New Zealand is the head point for those guys. China, so these, I'll just put these in just for the context of, there are a couple of units in Australia that are operating. They've had to go through very significant upgrades to meet regulatory concerns for emissions controls. As you can imagine, China is very different on air pollution to Europe, Australia and the US. So I believe it's been extremely expensive. Stephen sort of saying to me in the order of $1 million to upgrade them, but I don't want to, don't quote me on that, but you need to be asking questions about anything that's coming from overseas. You've got to make sure that the regulatory context is going to come through here, whereas the Australian technologies are developed here. They've been popular because they quote up to 5 tonnes an hour, but then again, you've got to ask how often they're needing to be shut down for a day or two to be maintained, and how many people it needs to clean them out to operate them. But there's a couple of Beston units on Kangaroo Island that are doing the work over there. Drying technologies, that's a bio-drying technology from the US called Bioforce Techs. They've partnered with Pyreg to run a local municipal biosolids facility over there that's really efficient. So that's been a good one. In terms of 3 emerging Australian technologies, we've got Pyroco out of Melbourne. It's a partnership between RMIT and South East Water. They've basically developed a system where the syngas goes back in to dry the biosolids. So it's a wet waste focus, and they're using the syngas to dry it. Fluid bed-based technology with an air gasification system for the syngas. And they've been working with FOGO as well, co-pyrolysing it, and they're now leading a new research hub. So the ARC for transforming biosolids that's worked based out of RMIT and South East Water chair it, is going to be transitioning to an Australian research hub for organics management, so green waste and FOGO and things like that. So really good chance for councils to start working with water utilities. Waste Ecology out of New South Wales and Sydney. These guys have got a pilot now under their going to their first commercial plant. Don works closely with Waste Ecology. They've got an organic carbonisation system that can deal with everything from biomass-based waste through to plastics and other carbon-based materials. It's a pressurised system, so that's a very distinct difference, and it's running, and it's done in an inert atmosphere using nitrogen. Runs 3 so it's a lower temperature, and it's catalysed. So very efficient from that point of view, but only makes a biochar externally heated, but it's efficient and can do around, you know, a couple of tonnes an hour, 45 tonne a day type of a system. So, but they're at, just going up to commercial as well. Hydrothermal gets talked about a fair bit in the water utility sector, looking at hydrochars. They're not stable in the long term, so you won't get carbon credits for them. It doesn't deal with chemical things like PFAS and things like that, but it does get a very high char yield. And talking to Damien from University of Queensland that's advising the industry a lot on this, we sat down and had a chat about where this, and he sees real synergies with our sector where they could be wet waste could be, say from aquatic agriculture and things like that, that could be going into a wet waste system like this to get a high yield char, but then you put the char through a pyrolysis system. And no one's yet to go through the economics of it all, but it does sound quite promising. The biggest issues with that too is that very, very high pressure. And when I talk to our guys on it, they say, well, the biggest limiting factor is that it needs unobtainium to be able to build a vessel at scale to run that kind of stuff. And so that's yet to be to come into that. Last thing is us. I won't spend long on cedar, but we've basically trying to mix the best of both worlds with pyrolysis and gasification. So we pyrolyse, and then the syngas from the pyrolysis, we gasify the syngas, not the feedstock. So we still get the high yields and the quality of biochar from the pyrolysis, but we get the benefits of gasification to get a high quality fuel gas, but we don't dilute with atmospheric nitrogen. We don't use air at all, and that means that we get a very concentrated syngas with double the hydrogen content of normal syngas. And we do that with chemical and thermal looping, and it makes it, with a fluid bed, it makes it scalable. So that's our pilot facility up in northern New South Wales. It's all now fully approved and we're about to kick off. We make a high quality syngas that then we're looking to make biohydrogen cheaply, and medical grade CO2. If you've got medical grade CO2, that means we can sink it in the future, where there's a future where we could actually be sinking all of the carbon of the feedstock. So not just half the carbon to biochar, but all of the feedstock as well. So, and then as we said, you saw on the slide earlier, many other derivatives from syngas. So I like to think of it like Lego, mainly because I stand on it every night for my kids. But many different colours of bricks, we basically separate those into the different outputs. And from doing that, we can separate out that and build all those different derivatives downstream. Like methanol in particular is a very high value output. Sustainable aviation fuels, this is a pathway that hopefully will enable us to look at that and decarbonising things like aviation sector. The most critical thing to do that is not having air in the system so you can dilute it. It's the main reason why we don't do combustion at the moment from coal-fired power stations. We don't separate that gas out to do anything with it. It's mainly because we don't have an economically separable gas. But if we replace that at scale, then maybe we can do things like that. And by doing it at scale this way, you can avoid having an air separation unit that's worth about $1 billion. So this is a really big play for industrial scale, which is where we really want to play it. So we can do it at small scale. I won't spend any time on this, I'll finish up now, but I've got a comparison there with the New South Wales hydrogen target, but a single 5 tonne an hour system for us, which is our smaller units, would do the entire New South Wales hydrogen target without having to have desal and all the infrastructure and the brine and everything else that goes with it to be discharged offshore like another sewer. And that's us. I won't spend, that's our field pilot. You can look at that online. But thank you. Okay, so from that note, I'd like to introduce Kane Ravenscroft, who's the Sales Director for Optimal Group. As I was just saying before, I won't steal his thunder, but please put your hands together for him because what these guys are doing are amazing. Optimal and RBE partnered with ANZBIG to go to the Bio360 Forum in France last year, and yeah, very welcome partner. So welcome.
Okay, thank you everyone. I'll just wait for my slides to come up, and apologies, I'll be looking at my notes during the talk. And I'll try not to keep everyone from lunch. I don't want to be that person. So, as part of the introduction, my name's Kane Ravenscroft. I'm the sales director and one of the founding partners of Optimal. But I'm here today really talking about Rainbow Beta, giving you an idea of where we are now, where we're going to, and how we think we can get where we need to go to. And talking about sort of the current success in the horticulture market, or what's properly described as protected cropping, so undercover glasshouse greenhouses. So, like a lot of people in this room, RB's mission is to remove carbon dioxide and store it safely for as long as possible. And they've got the ambitious target of reaching 1 million tonnes of CO2 by 2030 and hopefully getting to 1 million tonnes a year by then or 2034. But obviously to do that, to make that possible, is that we can't really outpace the market for biochar demand. Part of the economics mean that we have to sell the product. It has to do work and be useful. So where are we going to find those customers? Where are we looking to find those customers, and how do we fill those markets? So we've done a little bit of crystal ball gazing and working out where we think the markets are for biochar. In the top left-hand corner, top left-hand corner for you, those high value, low volume markets, but where we're focused is that sort of bottom right-hand quadrant where we're talking about high volume but low cost, and low cost to go into applications like high value agriculture, asphalt and cement, building products, potentially water and land remediation. So that's where we're focused. Just bear with me for a sec. So we want to meet the market where the pricing pulls demand. So this is how we think that it's possible. So the first part is obviously scaling, and for us, scaling is a combination of being close to the feedstock itself. So obviously within a reasonable distance for economical recovery, but also scaling big enough that there's a good return on capital investment. So we're getting a lowest cost of capital per tonne of biochar essentially in this scenario. And also for us, it's accessing low cost residue where it's produced. A lot of our applications are looking at things like wheat straw or forestry slash, or things that have very low to no economic value, but also incentivising those crops to be recovered and paying people for the work. So key to the whole thing is multiple revenue streams. So for us, underpinning the price of biochar where we think it needs to be is, for us, it's renewable gas, as in syngas, clean syngas. The carbon certificates, so CORCs, carbon removal certificates, and potentially developing applications for wood vinegar. And the other one is to maximise efficiency and minimise waste. For efficiency, we're talking about minimising the parasitic losses to process. So how much of the energy in the feedstock is lost to the process, how much additional energy is required to drive the process as well, and also minimise waste. So for the plants that we're looking at, they're not hyperscale plants, but they're large plants by sort of international standards, I suppose. What we would consider waste is probably the pyrolysis oil or tars that if you had a large enough application, you could certainly refine and produce useful outputs for those. But for those smaller these medium sort of sized plants, the pyrolysis oil is probably a waste. So for the rainbow beater process, and we'll talk about this in a moment, we utilise we leave the process, the tars and oils in the process to carbonise further, so we get additional biochar and additional syngas. We don't get that oil fraction. So as mentioned before, there's at least 50 million tonnes of suitable organic resource residues available for biochar. We've done some work on where we think our low-hanging fruit is probably. There's about 28 million tonnes conservatively of available biomass in our low-hanging fruit basket, and there's plenty more in areas that we don't currently look. And the impact of that is 23 million tonnes of carbon removal, but also importantly, if we were looking at, for the syngas component, for the energy component, potentially avoiding almost another 5 million tonnes a year of emissions, and that's just scoping it against, say, natural gas, not dirtier fuels like diesel or LPG. Our target for 1 million tonnes a year is less than 5% of that. So we're ambitious and we hope to get there. So just quickly on Optimal, who's Optimal? We're an engineering business at core. We're a solutions business. We engineer, procure and construct complex energy solutions across Australia, New Zealand, the South Pacific, including Fiji and Papua New Guinea. We work in some of the most remote applications on the planet, remote locations rather. We do power generation, we do heat recovery, gas conditioning, gas upgrading. So we're also investing, we've got a subsidiary company, a sister company called Optimal Renewable Gas that's building a 1 terajoule biogas to biomethane facility in Westbury in Tasmania. We believe in renewable gas and we think this is actually a major vector to assist in biochar uptake and production. So for Rainbow Beard, as I mentioned before, the value stack that subsidises the cost of production, if you like, is clean renewable gas and syngas in this case. Our current projects are all behind the meter, so facilitating next to an energy user where they would take the gas and offset their fossil fuel demands. The carbon removal credits, in this case corks, as mentioned before, Rainbow Beard was the first company outside of Europe, I believe, to be certified on Pure Earth for carbon removal credits and has sold credits to Microsoft and Shopify. And potentially as a value stream in the future, wood vinegar. I'm not going to go into detail in that, but there's plenty of value to be explored in that, and we're working on developing markets for that. So as far as carbon removal credits, it delivers huge amounts of value, but there's a barrier to entry, which is the cost of getting, in the first place, the project certified, and then the ongoing MRV. And that's another reason why we think scale is important. You need a return on those costs, and the benefit of the cork needs to outweigh the cost and the complexity. I'd thoroughly recommend you visiting Pure Earth's website. There's plenty of information on how to get certified and how to go through the process. So just quickly, I'm going to try and skip through this as quick as possible. It's just a video outlining the process of how we get to that balance that we talked about, the split of biochar versus syngas. So the first part of the process is the feedstock basically comes into the reactor and forms what we call a packed bed. And a packed bed is basically a cigarette filter. And that packed bed creates a tortuous path for the hot syngas that exits the reactor, the hot and dirty syngas, and it leaves the heat inside the process. So we're very thermally efficient, we keep the heat, but more importantly, we're cleaning and cooling that syngas. The tars and oils condense out, they condense out onto the feedstock, and they're forced back into the reactor where they break down, they decompose into more biochar and more syngas. So we are technically a gasification unit, so we make a lean syngas, but we clean it up on the way. So it's a continuous process, so biochar continuously unloaded, and then we get that clean, cool syngas, exits the reactor about 80 degrees Celsius. We then cool it down a bit further, depending on the application, to recover the wood vinegar and to dry the gas a bit for the application. So I'll talk a little bit more about that. So this reactor size is designed to be modular. It takes in about 0.5 tonne to 1 tonne an hour of feedstock, depending on the feedstock type. Produces up to sort of 400 kilograms an hour of biochar. It'll produce at the same time just over 4 gigajoules of syngas, and we can optionally make 330 litres an hour of wood vinegar. That can be recycled back as quench water if there's no application for wood vinegar or there's a shortage of water on site. And we'll produce between 0.5 to 1 cork an hour from those machines. So we don't think the scale is necessarily sustainable for one single unit. It is, but the cost of a project is better shared across multiple units. So we're chasing applications that have 6 or more of these reactors. Some of them are going to be a little bit less. A six pack, as we would call it, is about 25,000 tonnes a year of biomass, and that biomass would be typically below 20% moisture. About 120 terajoules of clean syngas a year, 18,000 tonnes of biochar on a wet basis, 25,000 corks, and optional wood vinegar as well. So the current projects we have are in the horticulture space, and it'll probably make sense why this is true. One quick thing is that Rainbow Beard is not chasing biocarbon projects. All projects have to go to ground. They have to be used for either soil amendment or applications where the biochar will be stored. The first project is in Mount Gambier. That was commissioned in 2021-22. That's a single Eco2 unit. The biochar is exchanged with the feedstock supplier. They bring in the feedstock and then they get back in payment the biochar. The greenhouse uses the syngas for greenhouse heating, offsetting propane. So big environmental impact there. And they also get the corks as well to help the financials work. The new project we're talking about there, you can see the shed under construction on the right-hand side. I've got more updated photos there. That's a 6-pack of Eco2, so that's a sort of 25 to 30,000 tonnes a year of biomass. They're using wheat straw. The wheat straw is farmed in local community. They've already got 12 months worth of feedstock on site. Commissioning is June, July this year will be hot commissioning and producing syngas on site. The interesting thing is, so part of our scope is we've designed and built in a syngas conditioning system. What's that? It's a big chiller. We cool the gas down to about 6 degrees. The reason we're doing that is we're piping the syngas about 0.5 kilometre underground. So we want to make sure there's no liquids that can condense out in that pipeline. So we cool it down to 6 degrees and then we put some superheat in to get it to about 15 and then pump it through. We're also constructing a large new 25 megawatt boiler that can take a mix of syngas and natural gas. The CO2 from the boiler stack is then used for what they call fertigation, so enriching plant growth. That's piped to the glasshouse. So an interesting value add for horticulture is, as was mentioned before, we sort of have essentially what's considered a gasification unit technically, which means we use air to combust some of the syngas inside the reactor. So that means we've got a reasonably big fraction of carbon dioxide. We also have nitrogen in there, of course, and about 1/3 combustibles. So if you look on your right-hand side, you'll see that the syngas from this reactor is lean. It's about 1/5 to 1/6 of the energy density of natural gas. Okay, what does that mean? That means we need more syngas to do the same amount of work, same amount of heat. That means that the exhaust coming out of the boiler has more CO2 than it would for natural gas. That's biogenic CO2, so it's CO2 recovered from the atmosphere, but that's of a massive value to the horticulture industry that's currently paying between $400 to $800 a tonne for CO2, for industrial CO2. So a massive value add, and in fact that's one of the biggest value stacks in these projects. So just in summary, I think I got through that pretty quickly. So RBE and Optimal's a massive supporter and believer in biochar and Australian industry. So recognising the value of the work that ANZBIG's doing and the fact that ANZBIG needs additional funding, put the challenge out to industry and people online and people here today that if ANZBIG can attract 3 new sponsors for $25,000 each, RBE will match that for another $25,000. So we'd encourage you to get behind it. It's a huge opportunity and of huge benefit. So that's me. Thank you very much. Time for lunch.
Thanks, Kane. Thank you. Thanks, mate. Yeah, for anyone who wants to know, Kane's based in Melbourne, Optimal down in Melbourne as well, so yeah, as are RBE. Okay, everybody, that brings us finally to lunch. So thank you for your patience through this morning and for we're running about half hour behind where we'd like to be, but we will make it up. There's a couple of bits at the very end of the day where we've allocated a quarter of an hour to do something we could probably do in 5 minutes, so we'll make up some time, yep. Thanks. What we'll do then, we'll break. We've got 30 minutes allocated for lunch. Let's see if we can do it in 25. Yep, okay. Thanks, everyone.
Just paging Andrew Shipp, who is going to introduce him. I'm just starting to talk, so hopefully it will bring everybody back in. So Andrew, if you're here, can you please go and get a lapel microphone on up the back. Andrew is from Construction Business Development Manager in Cyrenix Environmental Tasmania. So Craig's going to find him and introduce him. I just wanted to reflect on this morning and apologise that we haven't had a lot of time for discussion, but we will pave and make sure we have some time at the end of today. So I'm sure there's some questions coming up. It's been a... Oh, yes, networking drinks. What's happening with those, Karen? They're outside afterwards? Okay, so we've got networking drinks afterwards, and then we have booked for dinner as well for tonight at... it's across the road, and if anyone hasn't booked for dinner and wants to come to dinner, please just see Karen at the front or myself or Craig, and that's if you haven't booked, and we'll count those as extra numbers. So I'll hand it over to Craig now. I'm just filling time.
Thanks, Mel. Welcome back, everybody, and welcome back to those online. It's my pleasure to introduce Mr. Andrew Shipp, who's the Construction and Business Development Manager at Syrinx. Andrew lives here in Tasmania, not far away, I understand, and has over 30 years of experience in the construction industry, including 15 years constructing living streams, wetlands, stormwater and sewage treatment, stormwater treatment systems on small to large scales, and has been in charge of procurement, construction and site supervision for the Kingborough Council bypass and the Windermere stormwater treatment wetlands, the Burney landfill, leachate wetland, and which is an amazing project, and creek restoration works, and most recently the Copping landfill leachate wetlands in Tasmania. In addition, Andrew has constructed many wetlands across Australia, from the Donera wetland in South Perth, WA, the Missiondale wastewater wetland in Missiondale, Tas, Curry sewage treatment wetland in King Island, and is well respected by his clients for his ability to deliver projects on time, solve problems quickly and efficiently, with lateral thinking and strong communication skills. Andrew's been key to the design and development of both AusTas Innovation DLP GPT, gross pollutant treatment systems, and the mobile and fighter box wastewater treatment system, which I believe we're going to hear a bit about today. So please put your hands together for Andrew and hear about his talk on biochar and stormwater treatment.
Okay, thank you. Good afternoon. Right, so Syrinx is a strange name for a company, but yeah, it comes from ancient Greek, meaning hollow reed, or a goddess that threw herself in the river became a hollow reed. And that's where it started 20 odd years ago. We've been in Tasmania for 18 years. And yeah, nobody knows that we exist, but we do some remarkable jobs with materials that's been man-made, and we use nature to resolve those issues. So a little quick bio. We're Australian owned. We work across quite a few different areas in the state, and also across Australia and overseas. So privately owned, we're a sustainable water, blue, green infrastructure and nature-based remediation technologies and services we give, working across mining, agriculture, urban industry sectors to deliver end-to-end project delivery capability, research and development, design, construct, operate and maintain. So we're basically a one-stop shop. A subsidiary company in Serbia, in Belgrade, and that's where some of our fighter boxes are being constructed now for Greece and France and Serbia itself. We're pioneers in green tech and nature-based solutions, and we're an internationally certified sustainability practitioners. Consulting services, okay, this is a bit of a spiel. For Syrinx, this is what we can deliver with consulting services for water treatment, ecological restoration, remediation, carbon and natural capital accounting, and products. We provide an end-to-end design for fabrication, installation, operation of our innovative water technology products through our Serbian company in Belgrade. Green and clean technology providers. There's the boss, a remarkable woman. In fact, the company is built up of quite remarkable people from all around the world. We're almost the United Nations as far as that goes, from the four corners of the world. So, yeah, very well situated in the world of environmental science, engineering, and delivery. Okay, so some of our selected projects that we'll be looking at. We've done some conceptual designs for Malaysia and Qatar, large projects, only conceptuals. New Zealand, now this is where we start to break into the biochar. So in New Zealand, in the Bay of Plenty, we're actually implementing a project. Well, one project's now under construction. We've got two more that are upcoming. New Zealand has in fact, this is in Rotorua, around the area of Rotorua. We're talking about, you know, nitrogen in the soils and bits and pieces like that. New Zealand's very high animal husbandry, high density sheep, cattle, dairy, and that's been proving a problem for Rotorua, or the New Zealand in itself, because of the runoff leading into the lake. So there's been a lot of influence of nitrates, sulfates, phosphates, chemicals, animal waste. So it's all heading into Rotorua Lake, and that is having a detrimental effect on its health. So we've been invited by New Zealand, the Rotorua Council and the elders that are situated in that proximity, and they've collaborated with us, and we are now delivering water treatment prior to discharges going into Rotorua. We're capturing one in the middle of the town. There are two others in outlying areas with high volumes. Also, as you're well aware, New Zealand's volcanic, so there's a certain amount of volcanic activity in the catchment areas as well that we need to take care of, sulphurs, etc. To that end, the intensive farming practices that have been in the past would greatly benefit from the biochar substitute for their fertilisation of their soils. Therefore, it would knock down the amount of influence into the Rotorua Lake. So, as I said, we're aptly implementing that now with our wetland systems, and some of those may well, probably will, definitely have a biochar element into them as well. Searings gets involved with a lot of projects for mine site remediation. So we've got a pre and post. So if you can see up there, far left-hand corner is been up before we got to it, midway through, and then the end from the same or similar location. So you can see that we use biological engineering to recover, improve and treat industrial sites. Down below, you can see the Burnie leachate treatment plant. Now, the Burnie leachate treatment plant is a capped legacy landfill that will be going on for generations to come. I'll get probably more into that later on, but as you can see there on the far left-hand side, that's the discharge. This has all been planted by us to look as natural, and all species we use are natural species, native species to the area, endemic to the area. So left-hand side is, bottom left-hand corner is the discharge into Unnamed Creek, which goes down to Kui Creek through into Kui and then out to Bass Strait. When we started this project, there were burrowing crayfish in Kui Creek, 2.5 kilometres downstream. Now there are burrowing crayfish at the discharge point. So we are treating and we're treating 360,000 litres a day of leachate from the capped landfill, legacy landfill, and we're doing that by situating our leachate treatment plant on top of the capped landfill. Not being done often, if at all. Our green tech products. Okay, the DLT on the right-hand side, we're not going to delve into that at all. That's just for gross pollutant capture. Again, that's built here in Launceston and distributed around Australia. The Infito box on the left-hand side, that's the component we're going to be talking a little bit more in depth about today. So our innovative technology for water treatment. So it's modular, it's mobile, space efficient. I must stress also that we've put a lot of work into this to making these, the Infito box, user-friendly, simple, easy, but also has oversight to it. Every module that goes out is connected to the cloud, and it's connected to the cloud all the time, so you get real-time telemetry, you get real-time feedback. If there's a problem that looks like it's going to occur, we can alert the service staff to that. These are designed to go to a remote area. They also can be solar powered, low energy use, and robust in design. So they're efficient, they're effective, they're innovative, they're engaging, and we'll get to that in a moment, and they are sustainable. That was the hard part. The boss, I'll refer to your photo earlier, demanded that everything in the Infito box be recyclable. Bloody hell, that's hard. So difficult. And she will not be moved. And that's the way Syrinx has been. So we're a sustainable, environmental, ecological company. We cannot go outside those boundaries. Did I mention how hard that was? Oh, it's so hard. So moving on. Okay, so supports decarbonisation targets, which is why we're here as well. Produces reusable water and biomass to support small-scale farms, seed orchards, mines and mine rehabilitation. Mobile and suited to remote sites, and I'll get into that further later on. Smart technology, so it's IoT connected, as I said. Inside the box, you've got instrumentation with real-time data, like water quality data, both influent and discharge. It's a fully automated system, so it's got an inbuilt harvesting system with it. We use, in this situation, although that's a bit of an artistic impression of what it looks like, some of them are floating aquatics. We've got other Infito boxes which are cassette with a vertical filtration system. So this is only one, otherwise I'll be here for way over time. So mobile, suited to remote science, smart technology, visual facade options. Okay, so the visual facade options, we've already created those. That's out of regrowth timbers. They can be illuminated. They are also, we've got other applications for green wall. So once the treated material comes out, goes down through the green wall, has even further treatment, and then goes out to the field for reuse. Okay, treats between 20 and 100 kilolitres a day. Reason for that being depending on what inlet material we've got, the influence. So if it's really gnarly material, then we'll reduce the amount of volume that can come down. Now, I also must add that these are a cassette. So they're designed to couple. You can put 1 together, 2 together, 3 together, 5 together in series, or side by side to get the flows, and which is what we're doing at the moment in a project on the mainland. And we've got five going into a project in the next 12 months to take 330,000 litres of wastewater a day. Not as its primary treatment, this is as its secondary treatment prior to discharge to the environment to get the water quality to environmental discharge grade. Treats nutrients, organics, metals, hydrocarbons, pathogens, pesticides and mixed streams. It does a lot. All internal components are removable by a remote controlled crane. Okay, so when this all came about with a conversation I had with Kathy, Kathy said, we want to do a lagoon. I want to use duckweed as the part of the primary reduction of nitrates, phosphates and sulfates. It's high growth. harvesting duckweed's inherently difficult. So I said, okay, so I designed up a harvester for it that operated automatically, that operated when it was needed to, not by time, it was by a visual scanner. So radar looks at the surface area, says, oh, 85% of the area is covered by duckweed. I need to just take out 50% of the duckweed now and let it regrow. Duckweed in certain climates and seasons regenerates almost as you're looking at it. So that gets harvested out, puts into a hopper, that gets drained back into the system. The material that's left is inert, good for fertiliser, goes up either to the top of the cap or into the environment wherever it needs to be as an additive to the soil, enriches it. So that same system was implemented. She said, oh, look, it wouldn't be good to put, have this mobile, like a wetlands in a box. I said, sure, we can do that. So that's what we did. So we put it in a box. So we've got a wetlands in a box. So we've got different strata medias, we've got full control of inflow, we've got monitoring with all the sensors. As you can see, we've got floating aquatics there in the boxes. Obviously that doesn't get harvested. However, it comes with its own crane, which all packs up, so it all packs up below, so it can be put on a truck, on a ship, and it can be shipped out anywhere in the world. The media, the cassettes you can see in the bottom there are copying. They are chock-a-block full of ANZBIG biochar. So yeah, kudos to ANZBIG for that. They developed a product for us that suited us. We tested it, we sampled it, we trashed it. We put it in a situation that was, it's probably the gnarliest material you could possibly think of dealing with. We got really good results. However, it does have a saturation point with the material we were using. It did such a good job, but the porosity, as you saw on the previous speakers in their slides, the pores became clogged. So it dropped its efficiency during that process. However, with the cassettes, we can actually withdraw those with the crane, put in new cassettes, take that biochar out, flush it, reconstitute it, and then reuse it again. So we're becoming circular with the base product as well. So it means if we send double the biochar with the unit to wherever it's going in the world, that can be reused and reused and reused and reused. Someone said it lasts 1,000 years. It seems like it's a good idea to me. Plants, we've got, so as I said, we can operate this remotely. It's just a drop and play. Oh, hang on, I'll go back. Oh, 3. Oh, you're hard. Oh, what have I done? Help? IT guy, let's go. No, go up one. There you go. All right, okay, so this is the gnarly. So you can see the infighter box over on the left-hand side. This is a pilot plant. This material that we're using here, the plants that you see there are endemic to the area. We've got a massive landfill on top. You can see the lagoon over on the far right-hand side. That to reduce the volume of leachate, they used evaporation. So if you evaporate the top, all the water's gone, that's fine. But the concentrate gets more and more and more and more. So our EC reading of the material coming into our plant was 15,000. And basically it's just salt. These plants that we planted there were introduced to that. We used a decant to get it through there. Came in at 15,000. When it got to the box, it was 8,000. Outside the box, it got 4,000. So even in that small 40-foot container, it reduced the salt content by a factor of 50%. So an extraordinary use. And this, we trialled it here because this is the worst it can actually get. And therefore, that was our pilot. So the plants themselves shocked us. They shouldn't have lived. And they did. And they did a phenomenal job. Extraordinary. But yes, also, being at a trial because we had twin paths, then also we trialled biochar in one of the other cells in a horizontal flow wetland. And that worked really well. But again, we had that same inundation around the porosity of the biochar. So again, next one, cassettes, and we can drop those into there as well and then retract them. And right, so getting back to burning. So as I said, 360,000 litres a day, comes in at the top, trickles all the way down through our surface flow wetlands, through our subsurface flow wetland, which has a product called, well, it's got zeolite and also aerated volcanic basalt, which comes from Tasmania. We found that. I found that. They were using it as decorative rock for gardens. Well, it's very porous. Let's use that. Also, the sand that comes from that is coming from the northeast coast. So local provider gives us the material we want. Down through, so that's all contained in HDP liners. Once we get to the IBs, goes through a series of sensors to make sure that we're okay. Our trigger for the EPA is for ammonia, and that's 1.64. Since we turned this on, and that's the other thing, with Syrinx, whatever we do has to work first time. It cannot fail because we're delivering to the environment. So that's something that we put a lot of work into doing. Once it goes through SBO4, which is our monitoring station, gets then delivered to our IBs, which are infiltration. So we get 360,000 litres in at, say, 8 litres a second, 24 hours a day. Our discharge rate today, I just checked this afternoon, it's 0.4. So all of our plants up the top and down through our IBs, which are pretty much trees, and they're like rice paddies, it's like very shallow, 200 mil. They suck the guts out of it, and the plants love the nutrients, and there's carbon in there, and it's all doing the wonderful stuff. So, and it gets discharged to the environment. So, on the left-hand side, that's the inlet, bright orange. That's the outlet. So that's the difference that makes, but that's 360,000 litres a day. With the Infido box, you'll get a similar process, and it depends. So it's fit for purpose. Also, we've developed a remote water purification unit as well. That comes with 2 boxes, Infido box, and a power supply, pump retrieval from a river system or whatever, and they'll be landed anywhere. Takes 8 hours to set them up, and then you get potable water at the end of it after that period of time. Could be run by solar, or there's a genset backup, and there's also battery backup for it as well. So yeah, a lot of information that I haven't given you, but we've been inundated with a lot of facts and figures, so I thought I might keep it a bit light. But yes, thank you very much for your attention.
I'm not sure what everyone else thinks of that, but I'm a water engineer by training and spent a lot of time working in the waste sector and mining. And Andrew, I spoke to him yesterday, and that absolutely floored me. I think that's absolutely fantastic what Syrinx is doing. So congratulations for leading the industry in that. I'd like to welcome our next speaker, who's actually going to be introduced. So our bronze sponsor for the event is TasWater, and oh, sorry, actually, I apologise for that. It's yeah, they are. That's right, bronze sponsor. So I'd like to introduce Graham Hawke, who's the Chief Scientist for TasWater, who's going to give us an overview of 2 speakers that are jointly presenting for TasWater on their organic waste and circular economy.
Thanks so much. And just look, an opening word from me, if I can. It won't take too long. First of all, thanks, Harold, for your welcome to country this morning and your personal and historical insights, Country Champion, and thank you for that. St. Augustine said that hope has 2 daughters, anger and courage, and anger at the way things are, and courage to see that they do not remain as they are. So we don't want them to remain as they are. We rightly feel anger and sadness at the state of country, land, water and air. However, we can overcome by choosing a posture of courageous optimism, determined to grasp the opportunities with humility and acknowledgement, rediscovering the learning from Indigenous knowledge, quantified with evidence-based science, and enabled and scaled with technologies. Innovation, someone said, is the distillation of good ideas into practice, and it's daunting to weave local solutions through the maze of pathways of technology, feedstocks, markets, soil and plant scientists, logistics, delivery partners, financial realities and regulations, but we're better together, and we're pleased to sponsor ANZBIG's gathering the wealth of experience here today. For Tasmania, a particular challenge is to what I call search and destroy persistent contaminants to transform our biosolids to create sustainable solutions without creating unintended byproducts, so that we earn community and customer trust. And whilst the challenges are complex, I'm optimistic that Taswater's commitment to zero carbon and nutrient discharge by 2050 provides us a North Star to achieve the change that we know is needed. So I've got the pleasure of introducing two colleagues from Taswater who are tasked with finding practical solutions. They deserve to become CEOs of the future when they crack it. First is Phil Woods. Phil joined, Phil starting? You're kicking off, aren't you? Phil started as Sustainability and Climate Change Lead in January 24, and he's got a focus on implementing Taswater's Renewable Energy Roadmap and developing resource recovery opportunities. He spent time with GHD, building a local Tasmanian sustainability team with a range of clients, and prior to that he spent 16 years at Sydney Water as their strategic planning manager and circular economy. He also helped with their carbon zero plan, and he's got a particular interest in unlocking the water sector's capabilities and capability to turn organic waste into value resources. Will I introduce Tim, or will I leave that to you? So Tim as well. So Tim will then follow. He's been with Taswater for 9 years and spent the last year and a half in the sewer systems planning team, working on the future direction for the management of our biosolids. Prior to that, he worked and communicated to businesses big and small that discharge industrial wastewater to sewer systems. He has a diverse background, including trades, tourism, science, research related to both farming and forestry. So thank you, and look forward to your overview.
I'm good. I've got this. Yeah, thanks, Graham. Thank you. Whoops. Thanks, Graham, and good afternoon, everyone. Thanks for the opportunity to come and tell you a bit about what Taswater is doing in the organic waste, or in the circular economy with organics, what we've got plans to do, and some of the challenges that we have. Firstly, just want to acknowledge the traditional custodians of this land. Thanks, Uncle Harold, for your welcome earlier today. It really stood out for me in terms of that. You comment there that things were in balance a couple hundred years ago. We're here trying to get that balance back. There's a lot to do. And just a reminder also that we might be talking about the new biochar and pyrolysis and gasification. Well, there is a history to that. There's a lot we can build on from old knowledge that is still very relevant. So we're starting at the end here with our key messages. So the first is that water utilities play an important role in a circular economy. That land application of biosolids is, and it has been, a high value outcome for agriculture and for forestry. I'm going to talk about those 2 points in particular. Then Tim's going to take over, talk about some of the risks with emerging contaminants with PFAS, that pyrolysis potentially reduces that risk, and other contaminants of emerging concern, as we're hearing today, and that there are challenges in managing biochar from biosolids. And that lastly, and this is work that we're working on, particularly Tim's leading, that the biosolids roadmap that we're looking to develop is really focused on achieving the highest value outcome for resources in a circular economy, that being one of the key circular economy principles. It's not just about keeping resources in the economy, but keeping them in there at the highest value. So Not sure how familiar some of you are with the wastewater treatment process, so I thought I'd start with something really basic. Sorry, Craig, you know this really well, and I'm sure there's others too, but wanted to make sure you knew where we were talking about. So we get sewage come in to a treatment plant. It gets separated into a solid stream, a sludge, as we call it, and a liquid stream. The water goes off to have pathogens and nutrients removed, and then ideally gets reused, or it's discharged into the environment in a safe way. The solids part, which is the part of real interest here, is treated to make safe resources. Little picture there's anaerobic digestion. We have a number of sites with anaerobic digesters where we can produce biosolids and biogas, being two beneficial reuse outcomes. And certainly my role in TasWater is to really try and push the opportunities, particularly in that biogas space, but where you've got biogas, you also get biosolids. So, and Tim's the biosolids man, so we're a partnership working together on that. TasWater has about 38,000 wet tonnes, and we've heard mention of wastewater biosolids a couple of times today. It's a wet product. It's about 20% solids each year. That's 60% of that has been going direct to land, and about 40% going via composting to land. So there's about 1% of highly contaminated going to landfill, but 99% beneficial reuse, and that's been a good outcome to date. However, there are emerging challenges in the future state, the potential for other technologies to come in to help us manage and continue to achieve a high value outcome for our biosolids. So wastewater utilities, or water utilities, but are key players in the circular economy we see. This schematic, which is a little bit messy, but I've got an even messier one if you're really interested in this, but this is a bit simpler. We've got the key components being water on the left there, so water recycling, producing recycled water going back to household use, to industrial use, to agricultural use. We have up the top in the yellow, organic waste management, which mostly has been sewage coming down sewer pipes, but TasWater, we do get a reasonable amount of tankered waste, and there's opportunities for us to be doing more in that space, to not just be a sewage waste manager, but an organics waste manager, using anaerobic digestion and other technology to maximise that resource recovery potential. So on the right there, energy is one of the outcomes of taking that organics in. Biogas that we can produce electricity from to power sites. Heat that helps within the processes, managing heating digesters, and the potential for fuels. It was mentioned, oh no, actually it wasn't mentioned today, but Sydney Water have a biomethane project. So one of their sites I was involved with when I was at Sydney Water, we produced a pure biomethane that's going into the gas network to be used as a fuel by customers. Nutrients down the bottom there. So lots of potential uses or potential avenues there. Organic fertiliser, biosolids has been the main one, but potential for bespoke fertilisers, industrial enzymes, bioplastics are things that have been looked at as well. So, as I say, there's a really broad role that TasWater and water utilities have to play in creating a circular economy and getting that balance. So biosolids to land has been cost effective for farmers. This analysis was reported by ABC Landline a couple of years ago, showing that the relative value, or relative cost I should say, of biosolids from a financial perspective. Biosolids being a much more affordable, much more cost-effective product for farmers. but the financials don't tell the whole story. So, this quote here, I've tried to shorten it a bit. I'll summarise a bit, but from Roger Crisp, who's an agronomist, who's part of an ABC Landline show in 2018, who said it's a complete fertiliser, a soil conditioning agent that goes well beyond the macronutrients that are in the biosolids. Trace elements and a lot of organic matter that are going to the soil to stimulate soil microbes, and so the whole system is working together. And he was coming back to paddocks 10 to 12 years after biosolids were applied, and a very, very visible difference. One of the exciting things I'm hearing today is that biochar has the potential to be doing this. The extent to which it can achieve these outcomes compared to biosolids, I'm not sure about. I know there's some studies I need to read, but one of the big benefits, and what Tim will go into now, is some of those challenges with biosolids, some of the potential contaminants in the biosolids that are creating risks that are proving challenging to manage.
Thanks, Phil. So we have a situation of changing expectations. What's been happening a long time has been okay and was better than landfill at the time. But the contents of biosolids reflects everything in our human life and around us, including the chemicals used. And some of those, this is our older presentation, come to see it, but anyway. Because previously and traditionally we were managing biosolids to reduce odour and pathogens so that it could go to land. And that was an acceptable practice, and that was using anaerobic digestion and some of the processes we currently use. So some of the forever chemicals that we've been talking about is PFAS and fragrances as well, galaxolids, and they're in things like fire suppressants and waterproofings. They're really well known for PFAS, but it's also in makeup, food packaging, even pesticides, with a big scandal at the moment with Prime energy drinks in the US. Whilst the fragrances are in soaps and personal care products again, and they're also a group of chemicals that persist a long time. Something that farmers are probably equally concerned about, because it's really in their wheelhouse, is that antimicrobial resistance. So pharmaceutical residues from antibiotics, which can make superbugs, they're passing through the systems too at the moment. Then we've got micro and nanoplastics. Look, they're everywhere. I think that's enough to say. So all this stuff comes from all around us and ends up in to some extent in the liquid portion, but also in the solid portion. So it's long been kind of speculated biosolids management needed to adapt, and now it's clear in Australia that things are on the shift and expectations are shifting, and to be responsible environmental custodians, Taswater must adapt now and start paving a path forwards where we reduce those contaminants. So biosolids-derived biochar, the things we know at a very high level is it returns nitrogen and phosphorus to the environment without the PFAS and friends, and it increases soil water retention. So all things that farmers currently like about the biosolids, albeit in a lesser volume. We've kind of touched on it, so I won't go deep into it, but the challenge with pyrolysis and the dry thermal is it removes a lot of those organics which are volatilised, and it leaves the metals behind. So it doesn't so much increase as concentrate them. And they do have low plant availability, but our regulations aren't reflecting the science. So things like the biosolids reuse guideline, Tasmanian fertiliser regulations, all those mean that creating biosolids-derived biochar at this point in time, we're not about to sell it as potting mix in Bunnings, because if the metals can be high enough that there's not a clear path forwards. So some of the things that the researchers that Craig mentioned have kind of suggested as easy paths out of this is to mix biosolids with other material to improve the char quality, or alternatively you can mix biosolids-derived biochar with another material. So I've mentioned regulatory alignment there. I've already touched on that because at the moment, I guess the big question is if you create biosolids-derived biochar, how will regulations treat it? Is it biochar? Is it biosolids? Is it fertiliser? And some of those same issues, I think there's people in the room dealing with that same issue, wanting to use organic waste in digesters, because our regulations treat all digesters as though it's a sewage digester. So we've got a few things that are needing to be integrated with science. So our usage considerations, working on the biosolids roadmap, and I had intended to change the wording here because it might portray this poorly, but in some parts of the world, the burn and bury option is one way they manage metals. It can go into concrete, it can go waste to energy and then concrete, but the nutrients are lost from the system then. So of course, we're trying to seek the highest value outcome here. So the intent is to ensure that nutrients are returned wherever we can, and the kind of methods the water industry are currently researching are to strip the metals from the biosolids before pyrolysis when the metals are high. You do end up with another waste stream to manage though. To remove nutrients before pyrolysis, that might make burying the metals an acceptable solution. And then, of course, the adding material to biosolids to reduce the concentration, so wood waste, FO and GO. Of course, food organics also has PFAS contamination issues, so there's some alignment here. And agricultural residues. And down the bottom is that alternate option, which is to more have a simplified production where it's all biosolids into a pyrolysis unit, and then it's mixed into other products as a subcomponent so that the metals are a lesser component and can then comply with current regulations. So I've got a few ways forwards. So we've got a graph on the right from some work that Sydney Water has done in the past, and that's showing that sustainable forestry, so dryland forestry, reforestation, is the most carbon negative option that they had available. Biochar to land was also carbon negative, whilst composting was the highest greenhouse gas emission option they looked at. So at the moment, as we say, 40% of ours goes to composting. Fortunately, Dulverton is about to get an upgrade, so that's going to be good for that portion of the greenhouse gas emissions. So really, and I think we've said it before, pyrolysis for the water industry is a good pollution removal tool. The liquid content is a challenge, and also integrating our 22 plants all over the state with all the options out there for waste heat here, or all the different things that people are looking at for circular economy. So the challenge for us is to match technology with our system, a lot of treatment plants, a lot of change in the long term as far as where we have treatment plants. And the intent is the roadmap we're working on will develop the highest value outcome and manages a contaminant risk whilst also doing it in a cost-effective manner. So as we say, we'll be exploring partnerships with other people with similar challenges, with feedstocks that they're looking at doing biochar with, who need heat and these kind of resources. So thank you.
While I'm finding her, Craig will give you a microphone. So Sustainable Timber Tasmania are a bronze sponsor, thanks to the good work of Karen reaching out, and Marie is going to
and she's in the sustainability program in Sustainable Timber Tasmania, and she's going to introduce herself and then Fabiano and as the next speaker. So thank you, Marie.
Thanks, Rebecca. I won't talk very long. I'll just sort of want to just say that I'm one of the senior conservation planners at Sustainable Timber Tasmania. We're really pleased to be a bronze sponsor for this Tasmanian Biochar Forum. For those that don't know, STT has statutory responsibility for managing Tasmania's permanent timber production zone land, so that's our mouthful way of saying state forest. This land comprises about 800,000 hectares, and that makes up about 12% of Tasmania or 24% of the forested area. Now, not all of PTPZ land is managed for timber production. In fact, actually 42% is managed in reserves and areas excluded for special values or other reasons. But the other 58% is managed for long-term wood production, and that's made up a mix of native forest and plantation forests. We harvest that part of the estate and regenerate that or replant that, in the case of plantations, at a rate of less than 1% of the estate per year. So that's about 7,000 hectares per year. So as part of those operations, there's obviously lots of logging residue or logging slash that's generated as part of that. And we harvest in order to ensure a legislated annual supply of 137 cubic metres of high quality saw log to local sawmillers. So in the coming years, we will be transitioning towards sourcing nearly half of our high quality saw log from plantations as that come of age. So that'll be pretty much from 2027 onwards. So there's real opportunity to be able to use that plantation harvest residue for biochar production. And then, you know, if we've seen today how the benefits can be really used to improve the productivity of soil, we might be able to reapply that back in situ as part of the site prep for the plantation, and also, you know, deal with the likelihood of second rotation decline that comes with rotational harvesting. In addition, as part of our native forest regeneration activities, you know, we're just thinking small at this point, but, you know, we resow harvested areas with locally collected eucalypt seed. So as part of that seed collection and seed processing, quite substantial volumes of eucalypt seed capsules and twigs are generated as part of that process. And that's another opportunity to use that. That's a very clean, nice, beautiful piece size, dry source for biochar production. And who knows, we could even use that biochar to encrust that seed in capsule form and resow that back onto the forest. So there's real huge potential in this space. We're really lucky to have a few people from our organisation here to really learn more, to make connections with you, the experts, to get your advice, how we can work together on future collaborations and potential projects. And so we're really happy to be a bronze sponsor for this important forum. We sort of made a reach out to who I guess I consider a real leading expert in this space with regards to biomass residues, where forestry can play a really important role in this climate change action space. And so we asked Fabiano Jimenez from New South Wales DPI to provide a talk on this from our sector. So I'll just pass on to Fabiano if he's online and ready to go.
Thank you, Marie. Thank you for your kind introduction.
Thanks.
I'm just going to start in live view mode. Okay, can you trust this mode's okay? think silence is consent. Yep. So thank you again, Marie, for the introduction, and also thank you to ANZBIG for the invitation to talk today. I'm sorry I could not be there in person, but I'm joining today from Garigal Land here in Northern Beaches in Sydney. I'd like to pay my respects to their elders, past and present. And today I'll talk a little bit about the opportunities for the forestry sector to provide biomass in terms of feedstock for biochar production. But just to start, I guess it's always good to talk about some of the challenges that have been associated with the use of the biomass across the board, not just for biochar production, but for other bioproducts in the bioenergy industry as a whole. And some of those issues relate to regulation difficulties in getting projects up and running. And those difficulties are obviously they vary from jurisdiction to jurisdiction, but certainly in New South Wales, that's certainly a problem. Cost of transport is an issue across the board. So we consider that that's an issue that impacts all types of projects and really impacts on the profitability of any opportunity associated with using biomass. Also important to consider social perceptions and considerations around that, particularly around sustainability concerns of different types of feedstocks. Also discussions around food versus fiber in terms of potential for instance, plantations to displace prime agricultural land, and also understanding the impact of particularly large projects on communities. Like if the projects involve a large amount of transport of biomass from a region to another, what's the implication in terms of number of trucks on the roads and impacts on communities, etc. So it's really important to understand those different dimensions. And also from a industry development perspective, and again across the board, that's essential, is to have clear policy signals. And I think it's fair to say that Queensland is sort of a leader around that in the country, and with their biofeatures group and their roadmap, and so the policy signals coming from the Queensland government are pretty clear that they are very supportive of bioproduct developments. But now going back to the topic of the talk, so I guess most initially just to talk about the different biomass types in Australia. I guess the different states will have different types of feedstocks, which will be more relevant for certain activities. But broadly speaking, in Australia, we talk about forestry-derived feedstocks that both from harvest operations or sawmill or processing operations, and end-of-life options as well. Cropping straw, that's a massive component of the overall pie in terms of biomass availability. Horticulture, livestock and manure, obviously being wetter types of feedstocks that lend themselves to different types of applications, to more to drier feedstocks, and then organics from landfills. A lot of the work in assessing the potential and the scale of the opportunity for Australia has been done under the umbrella of what was called the Australian Biomass for Bioenergy Assessment project. So that was a national project that started, I think, back in 2016, which ran for about 5 years, and that involved all of the states in Australia, including Tasmania, and my colleague Martin Moroni was leading the charge from a Tasmania perspective. I'm not sure if Martin is in the audience or not. But the aim of the exercise was really to provide prospective project developers with a better handle on the potential availability of a biomass of different types across different areas of the country. So that work resulted in several different layers, spatial layers that have now populated the National Maps framework. And if you go to those two websites on the screen, you'll be able to find the sort of information for each of the states in Australia, including Tasmania. But zoning into forestry as an industry, I guess one of the first things to acknowledge is that from a sustainability perspective, Australia is a signatory to the Montreal Protocol. And that's really a sort of set of different criteria and indicators that govern how forests are managed across the board in Australia. I think about 25 developed countries have signatories to that protocol, and that really has a range of different criteria and indicators that govern how different forests are managed in Australia. And one of the ones of particular relevance from a climate perspective is the need or the driver to maintain the carbon cycles at the very least stable in the forest. So that's criteria number 5, maintenance of forest contribution to global carbon cycles. So the forest has to be managed in a way that carbon stocks do not decline over time. And as I said, Australia is a signatory. All the states in Australia have to comply with that imperative, that driver, and Tasmania is no exception. Now, if we talk about the forestry sector, there are opportunities across the board in terms of use of feedstock. And I think that starts from the harvest of the forest. If you've got a forest, it's just grown, it's been harvested. There's as Maria mentioned before, there's a proportion of the biomass that can't be taken out of the forest as a traditional product. So there are branches and smaller diameter logs, etc. There's an opportunity to use some of that material for biochar production. Similarly, for sawmill processing residues, different types of residues may lend themselves to biochar production, and also end-of-life waste, which in Australia primarily relates to construction and demolition waste, which is basically timber frame and trusses from demolished houses. This particular diagram here depicts, I guess, the concept of carbon neutrality associated with the use of biomass for bioenergy. But obviously, from the perspective of biochar, since that most of that carbon is actually stored in the biochar itself, the carbon will be retained in the product. So therefore, this particular diagram here is not so relevant. But if you think about the different types of residues, I guess where most of the volume and the opportunity is coming from the harvest sector. And when we talk about harvesting biomass, we talk about harvest residue, and primarily we're talking about both stemwood sections and and branches, and pulpwood to some extent. And I guess the reason why we include pulpwood under residue is that there is an opportunity there potentially to switch or to change the use of that log from a pulp production to a different option or a different market that may lead to greater levels of carbon abatement. And when we talk about harvesting residues as well, it's very important to understand that it's really important to leave both the leaves and bark behind, for instance, in the forest, because that's where most of the nutrients are, and that will contribute significantly towards the nutrient cycling in the forest. In terms of harvesting pulpwood residue, that sort of typically talks about logs down to a minimal and small end diameter of 8 centimeters. And if you're talking about processing residue from saw log or pillar logs on a ply mill sort of operation, you've got offcuts, wood chips, and sawdust that may potentially be available. Understanding that a lot of that resource already is used for in the sawmills themselves. If they need heat generation for drying the timber, for instance, quite often that is done using the residues that are produced in-house. So in the work that was done to support the development of the Tasmanian component of the Australian Biomass or Bioenergy Assessment Project, there were calculations of the volumes of biomass present in the different residue types. And Martin Moroni, my colleague from Tasmania, provided me with some of the documents that were used to provide those estimates. So here we've got a couple of tables that show those estimates. There are current, I guess, for the period between 1920 and 26, 27. And you can see here the breakdown of the different types of biomass from, I guess, different operation types. And that's made up of native forest residues, from public and the private state, or from plantation material coming from hardwoods and softwood plantations, and also from the processing sector. So sawmills are producing residues, so some of those residues may also be available. So I guess the sum of that equals about 1.4 million tons of biomass. And if you think about the amount of pulpwood that's produced in Tasmania, so there's a very large amount produced currently, and the figure, it's close to 6 million tons. Obviously, there are variations in that figure. Bear in mind that when those estimates were produced, they were a few years ago, so there have been changes to the management of the forest. So those figures may not be absolutely accurate at the moment, but they give you an indication of the potential. And that's just some of the two main sources of the information that I'm showing here now. So in terms of biochar production, last year we did some work nationally to understand the carbon balance of managing native forests in Australia. And that work involved the public native forest state in 4 different states in Australia. So in New South Wales, Queensland, Victoria, and Tasmania. And the aim of that exercise was really understand the current state of play in terms of the carbon implications of managing those forests, but also understanding the potential for residues that are currently underutilized to be used for a range of different applications, including biochar. So here we've got, for Tasmania, the total area of the public native forest state is around 700,000 hectares. 20% of which is non-harvestable, so it will never be touched. There's opportunities there for residues to be used for a range of different applications. Typically, when we talk about residue usage, we're talking about things like energy generation to displace fossil fuels, and that could be electricity generation, industrial heat, or liquid biofuels, or potentially also use some of those residues for to derive some more novel engineered type wood products, which can be used for mass construction sort of designs for multi-story buildings and things like that. An example of that is cross-laminated timber. The abatement that's generated from those two activities comes from either the displacement of fossil fuels or from the storage of the carbon in the product itself. So the point here is the biochar can achieve both, obviously by the storage of the carbon in the char portion, and then also looking at potential opportunities for using the syngas that's produced to displace fossil fuel. So in the case of Tasmania, we looked at, as I said, the public native forest state, where around 1.5 million tons of log products are produced each year. Obviously, that results in production of residues that are currently mostly left in the forest. So if we, in our assessment, we assume that 30% of the residual stems that are currently left in the forest would be removed, and that 50% of the bigger branches that are produced would also be removed. This equates to approximately a little bit over 500,000 tons of biomass. So that biomass, under the assumptions in our study, would lead to the production of biochar with about 35% char and 40% syngas production. And the syngas in our study was assumed to displace natural gas for industrial heat generation with a substitution factor of 0.142. And that substitution factor was assumed to decrease over time as a result of the decarbonization of our society that, obviously is happening now and is expected to keep going over the long term. And the char itself, we applied a very small half-life value represented by the K value in the screen. And that's to acknowledge the fact that there's a small proportion of that carbon in the biochar that will be lost over time as well. And I should also have acknowledged before that some of the information coming from Sustainable Timber Tasmania was provided by colleague Sean Suter. I don't know if Sean is in the audience, but just acknowledging his contribution and his input. So just as a very simple chart indicating the potential in terms of carbon abatement from the biochar that's produced, you can see here, if we assume that that level of harvest is sustained over the long period and that the same amount of biomass can be used for the production of biochar, you can see that the abatement grows over time, almost in a linear sort of fashion. And that's purely because of that, or primarily because of that impact of most of the carbon in the biochar remaining stable for a long period of time. So if you look at that over 100 years and we calculate what the long-term average abatement is as a result of that activity over 100 years, it's in the vicinity of 2.5 million tons of carbon per year. So it's very significant. Obviously, it's a few assumptions behind it, but it gives you an indication of, I guess, the climate impact of using some of that feedstock for biochar production. Now, when we talk about forestry, just want to touch a little bit about the other opportunity here, which is around growing dedicated biomass crops for the purpose of supplying a biochar market. And really that's under the acknowledgement that as fossil fuel usage becomes more and more limited across the board, biomass a lot of times will be the natural replacement. So the demand for biomass is likely to increase exponentially over time. And it may be that, as a result of that demand or a large increase in demand, there will be a need to look for alternative sources of biomass and looking at marginal, sort of more degraded portions of the land for that purpose may be an interesting opportunity. So we've got a network of trial sites in New South Wales looking at that, the potential for different native woody crops to grow under different soil and climate scenarios. Managed on a very, very short rotational basis, so 3 to 4 year rotation basis, and really sort of targeting those areas which I said are more degraded and more marginal, and providing landholders with an opportunity to increase their income, I guess the income diversification option, whilst at the same time achieving other environmental outcomes for the land. And in terms of the different types of land that we'll be looking at and that we've sort of been working with in New South Wales, mine rehabilitation is one of the key opportunities, but also working with farmers to look at ways of integrating those types of crops in farming systems. And that may be, in the different types of configurations in terms of block planting or belt systems, for instance, which can also work as windbreaks. Also integration with livestock and the grazing sort of scenario in terms of inter-row pasture, growing pasture in the inter-rows that are generated from the trees, and the opportunity to integrate with livestock as well. And things like mixed planting systems, et cetera, et cetera. So there's a range of different opportunities there that you can actually match the type of woody biomass with the type of product, and it may be that certain types of or certain native woody species may be more interesting for biochar production than others, but that work has not been done yet. It's just a picture of one of our trial sites up at Tamworth in the northeast part of the state in New South Wales, and I guess out of interest, when that site was harvested, all of the biomass went to a local biochar facility for processing up at Gleninas, and a facility that Craig Beckenham knows very well. So, and just a final slide, just to give you just a bit of a flavour for what could be done in terms of helping the industry develop. One of the things that we've done in New South Wales is develop a spatial tool called New South Wales BioSmart, which stands for Spatial Modular Assessment of Resources Tool. And what that does is allow you as a user to go into the map and select any area of the state. You can draw a polygon, a circle, whatever it may be, and the tool automatically sort of estimates or tells you how much biomass there is that likely to be from that region. X amount that comes from agricultural cropping, or X amount from forestry, from landfills, livestock, etc. It also allows you to take the biomass from A to B, so it calculates the best transport route for the biomass, the cost of transporting or moving the biomass, carbon dioxide emissions. And currently the tool has electricity generation options as the only end use for the biomass, but we are currently working on increasing that to other potential end uses such as industrial heat, liquid biofuel production, and of course biochar. So that work has been developed with CSIRO. So that tool is available free of charge online. You can have a look there. And there's no reason why it can't be replicated for other states in Australia, including Tasmania. And we'll be very happy to talk to anyone who's interested in doing that. And that's pretty much it for me. Open for questions, and thank you.
Sorry about that, I'm fumbling with the microphone. Thank you, Fabiano, online. We really appreciated your presentation. Because he is online, I'll allow one quick question, and I know that, please put some questions in on chat, Fabiano, if you can maybe continue to answer them online. Is there any questions for Fabiano because he is online before we move on? I thought that was a really great presentation that helped us clarify the residues available and what that means for carbon removal and how that works in with forestry carbon removal as well, so how our industries can align. So thank you very much. So I'd like to introduce now our next speaker, Christina Gladici, who is the founding director of the new Black Biochar and is based here in Tasmania. So if you can make your way up, we'll get you a microphone somewhere. She's an agricultural scientist with over 30 years' experience in agricultural and renewable energy projects in Australia and Southeast Asia. She's worked in permitting, construction and operational environmental management in the water and renewable energy sectors, and has combined this with community engagement and stakeholder management for the major infrastructure projects in parallel with this. She runs a small business called FIMBI, I'm hoping to hear more about that, Feed in My Backyard, which she started in 2008. So thank you, and we're looking forward to hearing about the biochar, the new Black as well. So over to you, Christina.
Thanks, Melissa. Am I on? Yeah. Yes. Thanks. Wanted to acknowledge and thank you, Uncle Harold, for being here with us and for reclaiming and extending and sharing traditional cultural knowledge about fire and landscape. And biochar kind of sideways fits into that. Really appreciate you being here. Thank you. Most of us who spoke today prepared our presentations independently, of course, but I'm stunned at how much overlap and consistency and echoing there is in what we're saying. And as I think about what I've prepared, it's very much a repetition of the themes that we've heard all day today. Themes about scale, viability, context, local context, themes about contamination management, and finding and seeking the highest value for both resources and use. So I'm just going to tell you a bit of a story that reflects on those themes, the story of our little business. So yeah, I hope you enjoy. The new Black was born from a collaboration between myself and Bodie Kavanagh, who's sitting over here, if you want to give him a wave. We met each other through our respective businesses. FIMBI, my business, which stands for Food in My Backyard, which is about helping people grow their own food. I'm an agricultural scientist with an interest in regenerative agriculture and empowering people one pumpkin at a time. And Dovetail Timbers, which is Bodie's boutique sawmill business, which started from an ethos of valuing resources and salvaging high-value resources post-logging operations. And so we met each other through our businesses, and we started on this biochar journey kind of by accident and kind of without much business planning or thought about the context into which we were going. Bodie disclosed one day that he was going to build a sawdust furnace to create heat and steam for reconditioning timber. And I said, oh, maybe you could make some biochar, you know, at the same time. So that's kind of how we fell into it. And over the last 7 or 8 years of our journey, we've kind of found ourselves more and more understanding the biochar world that we've fallen into. We're self-funded and therefore things go slow. And we come from that valuing resources ethos, as many people I think in the biochar sector have come from. And we made a thing. Well, actually, Bodie made a thing. He made a incredible Willy Wonka meets Charles Dickens styled by steampunk kind of piece of kit, our biochar rig, with huge input and support from James Fox, who's an engineer with decades of combustion technology experience. This is a photo of it in its early iteration. It's a creature that keeps changing and evolving and getting more and more complex every month as new things get added on and new things get changed out. Bodie's a master of junk engineering, so salvaging bits of kit that are worth hundreds of thousands of dollars, getting them for almost nothing, and then pulling them out of the weeds at the back of the lot at some point and putting them into the right place. So what we have looks pretty junky, and I've got lots of photos that I'm not going to show you. but it's a continuous flow pyrolysis plant. It has a throughput of about 300 to 400 kilograms an hour. It's a closed loop system. All of the pyrolysis gases are recirculated back through the furnace. It's sawdust powered. It incorporates a pre-dryer to pre-dry the feedstock. Heat can also be transferred through a heat transfer into kiln drying or to create steam for timber reconditioning. And soon it'll be capable of operating 24 hours a day with very little manual input. It has alarms and complex PLC controls and so on. So it looks pretty Dickensian, and it's a highly sophisticated machine, which I'm sure Bodhi is very proud of, and vicariously I am. For feedstock, we currently use clean hardwood sawdust, which accrues in a pile about 20 metres away from the rig, so our life cycle analysis is very good, and it makes a beautiful char, over 80% carbon typically, fairly pH neutral, very high porosity and high surface area. We've been working slowly over the last few years, selling the biochar that we've made as this machine has been commissioned, and working with trial partners in the spaces of horticulture, small-scale market gardens, in architecture, looking at masonry blocks made with biochar and clinker, expanded clay, poultry bedding, more recently goat dairy bedding down at Leap Farm, who are also feeding char to their goats in the pellets. And also doing trials for environmental remediation, much as Syrinx's presentation in similar ways. So we have our feedstock, which we know all about, is very local, but there are other opportunities for feedstocks, some of which has been touched on today a few times. There's a lot of construction and demolition waste and municipal green waste, very local to us, and is problematic for some of the local councils to deal with. And it costs them money to handle and dispose of. For the scale of our equipment, there's enough to hit our current yearly targets of throughput just from within a very close radius. So this pile of scrap here represents an opportunity to diversify our feedstocks. And it comes with some risks. Again, people have already addressed much of this. So there's risks of contamination of the material itself by heavy metals, PVCs, asbestos, glass and ceramics, bioplastics, and so on. There's risks if you stockpile and handle this stuff, you can generate dust. You may have heard about the recent newsworthy stories about the metal recycling business here in Launceston who had big problems with dust. There's a risk to the people that handle this material. There's the risk of putting materials into the pyrolysis rig and generating nasty substances that we don't want in the atmosphere. There's a risk of getting some of those contaminants transport through into the biochar. And there's a business risk of competition for the resource. So how do we address those risks if we want to pursue this opportunity? For us and at our scale, and doing some good economic analysis, we think that it's potentially worthwhile to manually sort some of these material stacks at the source where they're accumulated and find the highest value use for the elements of that, much like the Lego picture that I think Craig showed us, sorting it out into different classes so that we can reuse the stuff that's reusable, pyrolyse the stuff that is suitable for that, and then reduce the intractable pile by quite a degree. So manual selection, making sure that there's dust suppression and leachate collection of any stockpiled contaminated materials, using some technological screening opportunities once the materials have been chipped, so XRF can be handheld, or if we had somebody who gave us heaps of money, we could buy a fancy machine to do that. For us, testing and monitoring both pre and post pyrolysis so that we know what we're dealing with and we can validate what we think we're getting. And the risk of competition for resources for us is addressed by having really flexible plant. So we currently can pyrolyse sawdust. We think we can pyrolyse C&D waste.
We could pivot to municipal green waste, FOGO, other sources as they become available. And finally, this is my last slide, so this is a time catch-up talk. And again, people have touched on this today. We think there's a really important role for all of us to be matchmakers. That is, take the different resource streams that are in our orbit and find the highest value use for them. This photo shows a couple of our collaborators from environmental consultancy in Hobart doing benchtop assessments of our biochar to absorb aqueous ammonia from water in the Derwent River. And David, who's there on the left, who's here with us today, an analytical chemist with a huge and deep knowledge of pyrolysis, is a strong collaborator with us to help us with all questions chemistry and to help to find the highest value for any of the products of pyrolysis. We're all pretty familiar with the story of the feed char into cows through their dung via dung beetles into the soil and therefore assisting with landscape function. That cascading benefit story that's so appealing about biochar. And we believe that there are also similar cascading benefits that can accrue in the industrial space. So biochars may be made from contaminated sources, can still fulfil an important function in remediation or filtration and find their ultimate home in places where they can be safely encapsulated and provide pavement for roads or industrial uses, building materials and so on. So that's the story. I think it's interesting how much the themes of each of us are overlapping and echoing each other. And I just would love to see, because I missed the very beginning of today, in this room, a show of hands, just to understand who's here. This is kind of for personal interest. A show of hands of those of you who have been involved in biochar stuff for at least 5 years or more. Can we get a sense of that? And perhaps a show of hands of those of you who have been investigating or doing something in the biochar space between 2 and 5 years or so. And anyone who's here who's really only pretty new to this space to finding out about it. Are there many of you here? Oh, wow. More than half. That's fantastic. So, yeah, thank you for that. And ask the questions while you're here, I guess. Back over to you.
Thank you, Christina. That was... I think I have to go up here for it to work, do I? I don't know. Hello. I thought I had to. Don't go too far away. You've caught up, so you actually get to see if anyone's got any questions for you. Thank you. That was a good little bit of research on our behalf, Christina. We've got a bit more data now as well. Thank you. We do have this session at the end of the day, but if there's any questions for Christina before we break. But thank you. That's really helped us catch up, and we've got a bit of time. We'll shave off at the end of the day as well. So please. It was a fabulous range of speakers this afternoon. So really wanted to thank the speakers that we had. After afternoon tea, if you can just go and grab a cuppa and maybe try and come back within the next 10, that'd be fabulous. We've got 2 more speakers. Don't worry, we've saved the best for last. Matthew Harrison, I know he's going to wake you all up with his energy and enthusiasm. And then we'll have some discussion from there. And then there's drinks and dinner as well. So is there anyone that hasn't registered for dinner that think they would like to go? If you could just raise your hand. Dinner is across the road. And before we go, I just also wanted to recognise Don Coyne at the back of the room, who's our CEO. Again, he's done a lot of work in this space. I didn't mention he's also been on all the working groups and is a wealth of knowledge and has been a part of the advisory board as well as helping with the board and all the work that he does. So thank you, Don, for everything you do. And I know he's not feeling the best today. Please go and have a cuppa. We'll see you after the break. Hello, okay. Welcome back, everybody, from afternoon tea. We're into the last part of the day, and it's been a journey, I'm sure, for everybody's knowledge and connections, and it's those discussions out there that make all the difference. And, you know, just in that short period of time, I've reflected with Karen on what's happened in the South Australian Forum, and I'd like to bring that up in discussion later on, is where to from here, and we'll have a discussion around that. In South Australia, there's some key state government, CSIRO and others that are meeting to talk about a potential biochar hub in South Australia, and talk about some of the policies that will facilitate scale up of the industry, and it'd be really lovely to see something like that happen in Tasmania. Now, Karen has done an amazing job to get Taiwan's circular economy, pyrolysis, feedstock technology and products. A speaker, Varian Chen here from Industry Technology Research Institute from Taiwan, all the way from Taiwan. It's absolute amazing that he's made it and come here. ITRI is Taiwan's largest and most important industrial technology research and development unit and an international research centre, and Taiwan really do lead the way in climate change mitigation. Because the government is promoting circular economy and net zero carbon emissions, his division has been established to promote the development and internationalisation of these industries. The development of biochar and wood vinegar systems and the use of materials in agriculture, livestock and agriculture are important to them. My brother was there very recently, and he was sending me some pictures of the recycling at the curbside and how everybody had to bring up their rubbish already sorted to the truck, and they'd take the plastics up to the plastic truck and something else up to another truck. They took photos, and it's just amazing how Taiwan really lead the way in this space. So I'd like you to welcome you. Please give him a warm welcome to the stage. Thank you.
Thank you. Good afternoon, Elton, ladies and gentlemen. Yeah, I'm from Taiwan. I very pleasure this presentation. I very nervous, right? But I very glad to show our Taiwan biochar technology to show everyone. Thank you so much. And the E3 is Taiwan #1 big area industrial application research center. And I'm my campus in the Central Region campus in the Taiwan, Central Taiwan. And my division is Agri-Industrial System Technology. I'm Varian Chen. Yeah, this slide, I won't show you. The Taiwan is very focused and very important on the agricultural industrial. And very Tasmania, yeah. And surrounded by sea. So Tasmania have tea and the Taiwan have tea, yeah. So brother, good brother, all right? And per 1 year, the Taiwan over 5 million ton, yeah, in the Taiwan. So our government must be to secure economy evaluated, right? So our division team have innovation, extraction process, such as sequence sequestration, yeah, to evaluate it to make the cosmetic, health care, and drink. And after extraction, have a two-way. One is biochar, or you say carbonation. and the other one is biotransformation. Yeah, today I won't focus on the pyrolysis, digital saving carbonation system. And after biochar and the vinegar, we can application on the agricultural material or field active or pollution remediation materials, right? And this system before 5 years to suitable the Taiwan is very small agricultural industrial, and Taiwan in agricultural industrial is very diffusion. So we can innovation and development this system to very safe and very simple, give the farmer to operation, make a biochar and the vinegar, reuse into the soil improvement and prevention disease and pest. Right. And our system key feature is a module customization depending on the various materials. Is no external heating source. In the Taiwan have a lot of biochar, bamboo, and fruit agricultural waste, and the rice husk and the rice straw, right? So we can based on different material to set the pyrolysis processing pairments, right? And the energy very saving, yeah, less than 3 kilowatt per 1 hour, yeah. And the low pollution, this air pollution already fit our Taiwan EPA regulation, so it's no problem. And the high yield, the biochar and the vinegar, more than 60 is no problem, percentage, right? And one batch, 6 to 8 hours, less than $2 per one batch, right? And very easy operation. So when you already digital pyrolysis pairments, you can one touch after 6 hours to finish your biochar and the vinegar, right? So the species saving less than 35 meters square. Our government to push this system, diffusion the South Taiwan, North Taiwan, East Taiwan, and West Taiwan have more than 9 promotion sites. And these 9 promotion sites to treatment larger bamboo, and rice husk. And today I won't show you the biochar put into the soil have 7 possible mechanisms. Today I won't show 1 and 4 habitat pro structure with microorganisms and improve soil property on the physical, chemical, and biological. So the first one, we can collection our agricultural waste to crossing into our system. And after 6 hours, have a biochar and a vinegar. Because our team won't take macropole size, so we can use the processing is activation and modification to production the macropoles. These macropoles must be more than 1 micrometer, right? So after processing biochar must be verification test, analysis, SEM, BET, pH, FTIR, and we are in Taiwan take tolerate sample to screening the spatial strengths, combine the biochar to make the embedded the biochar engine, right? So this material will be applied the agricultural field in industry and organic waste, biological treatment, or soil pollution remediation and groundwater pollution reaction wall, right? These three trees in the South Taiwan, Pingtung, yeah. This wax apple and Zizipas is very Taiwan famous economic fruit. So after harvest, have a lot of agricultural waste. And this one is Lucina tree in the Pingtung, more than 5,000 hectare, very big area, right? So we use locate the agricultural waste after crushing, 2 to 10 centimeter size, put in to our system. Yeah, and the biochar must be used activator to push to cleaning. We use the oyster shell to activation. This oyster shell in Taiwan, a lot of is waste, right? So after activation, we can use SEM to watch this photo. Yeah, three material have a very beautiful porous. This porous is more 1 micrometer and a high percentage, more than 70 high percentage macroporous. And our team to go to the territory plant soil roots to take sample, and go to our lab to screening the microbes. And from the 200 strains to selection these three bacillus. Because this amyloliquifens bacillus is Taiwan verified Council of Agriculture. So we are first one to promotion this strain to embed it in the Marco Polo size biochar. So these amyloliquifens have a very activating functional amino lattice, sialolattice, prolattice, and phosphorus. Yeah, and the biochar and amyloliquifens at the same time put this system. Our team say this one part essential system. Yeah, so this system is very simple operation. It's digital control and labor saving design. One time is 450 liter, and incubation 1 week. Have finished the biochar with the amyloliquifens in the porous size. So liquid and the slider product can be produced at the same time. We are already applied Taiwan and US patent. So this is the porous size ratio and the biochar characteristic. we have look the Marco Polo size ratio. Yeah, 3 material are more than 70 to 97 higher percentage Marco Polo ratio, right? So we use the biochar and the vinegar to develop 4 product. This 4 product is soil improvement and embedded the complex and the prevention use with the vinegar complex prevention disease and pest, right? And folium fertilizer. So these 4 product is already Taiwan regulation, is organic, right? And 3 years test. This onion feed in the Hengchun, South Taiwan, Hengchun, Pingtung. Pingtung, Hengchun is Taiwan south. 3 years. So have a good results. Disease control rate more than 70%, and the yield increased more than 30%. And last year, September, yeah, our with the vinegar complex sent to New Zealand, Auckland, kiwi fruit, PSI disease prevention, right? And this test already passed 7 months, right? And next week harvest. So these 7 months have a good prevention PSI test, PSI disease prevention. So we are comparing the traditional the carbon agent is traditional prevention PSA disease kiwi fruit, right? So our with the vinegar, yeah, at the same carbon have a good efficiency, but the carbon is not 1 month before flowering is no use. Our with the vinegar is okay. It's okay because it's organic, right? And our with the vinegar complex is no heavy metal pesticide residual, right? And this case study before 5 years in the Taiwan, Kaohsiung, and the Tainan, yeah, put the biochar into the aquaculture, yeah, field active and sediment modifier and water treatment, yeah, and after 2 to 3 months, 2 to 3 months have a good results, increased 125, and water treatment have reduced the ORP, OC, ammonia, nitrogen, and the sulfide contamination materials. And right now, our team is focused this technology. Yeah, the bacillus need 1 micrometer Marco Polo, but the fungus need 10 microliter Marco Polo, And we are very attention the Macropole biochar pH suitable is 5 to 7, and the Macropole size more than 10 micrometer, and low or poor nutrient N less than 250 ppm, and the P phosphorus less than 30 ppm, and the H is low concentration. So we are development this Macropole biochar to embed the fungus, AMF fungus, because this fungus is very big help our soil. You can look here, stress tolerance, and the reduce the disease, and enhance the development and absorption of roots, and help beneficial microorganism survival, and reduce the heavy metal pollution. Right. So this AMF fungus is Taiwan local, good strength. This is my short presentation. Thank you so much.
Stay there for a moment if you can. Thank you. That was, I can't, thank you very much. They mute me when they like. I think a lot of people wish they had that button for me sometimes. Thank you very much, Varian. That was a fabulous presentation, and really, really great work, and just provided some more knowledge, increase the knowledge level of people in this room. Sounds like he's having to leave, so no, he's sitting down later, so hopefully we'll be able to pick his brain a little bit later, and he's got a colleague with him as well. But just the macropores and what they do, and how that changes, you know, agricultural applications, and what you can add with it is great work. And so thank you for contributing to the knowledge base and what you do, and for making the effort to come here as well. We really appreciate it. Okay, so moving on, we have, shall we say, without offending our other speakers, the best for last. I've got to say this to Matt because, you know, he is, I've known Matt for a long time. I actually knew him when he was doing his PhD, and now he's trying to convince me to do mine with him. He's now an associate professor and is an award-winning scientist, and it's been amazing to watch his journey in what he does for climate change. He's at the Tasmanian Institute of Ag in Launceston. He's an internationally renowned for his work improving the sustainability of agriculture and land use systems through the development of innovative solutions to demand-driven problems. He's the director of carbon storage partnerships that is developing inclusive, environmentally contextualised pathways aimed at progressing the entire Australian livestock sector to net zero greenhouse gas emissions by 2030 in a profitable, productive way. And we're really hoping that Matt will see how biochar can be an extraordinarily important part of that process. And we're hoping that Matt will help in Tasmania lead the pathway to this discussions with the other institutes that we need in Tasmania, and do some more research and create a hub. So Matt, please come up, and we're really looking forward to hearing from you. So over to you.
I think I'm on. Can you hear me? Can people hear that? Thanks very much for that introduction, Melissa. I think I'm somewhat of an anticlimax after the last speaker, who came all the way from Taiwan. I come from 5 minutes down the road at Newnham. And Melissa did say that she saved the best to the last. It could be the worst to last, I think, somehow. So no one ever complained over a short presentation, so I'll try to keep it as short as possible.
I do acknowledge the traditional owners of the country throughout Australia and in Tasmania, the Palawa people. We recognise their continuing connection to land, waters and culture, and we pay our respects to their elders past, present and emerging. I wasn't here for the earlier part of today, so apologies if anyone has mentioned this before, but I'll be talking a little bit about our work in feeding biochar to cattle on our farm at Deloraine, and also a little bit about some of my colleagues' work who used it in a program called PIPS, which was using biochar as a soil amendment for apple and pears. There are multiple anecdotal benefits associated with feeding biochar to cattle. It can improve animal health and productivity, improves the surface area of the rumen, and Stephen's done a lot of work on this before. Soil organic carbon, and I think Annette Cowie earlier today probably presented on that. Soil health and functioning goes through the animal, can enrich the manure and improve dung beetles and the ecology of the soil. Mitigation of enteric methane emissions, which is sort of an emerging area and very topical. Mitigation of soil methane when spread on the soil as a soil amendment, and nitrous oxide emissions. So my main interest in biochar is primarily in greenhouse gas emissions and with respect to carbon. And as a systems researcher, I sort of come across it. I thought, oh well, someone mentioned biochar, and I thought, oh, this is quite novel. I might do an investigation on this, and I did an experiment on farm with this farmer, TasAgco in Deloraine. And then with all these things, you sort of do your research onto it, and you come to days like today and you find out that, well, there's a lot of research actually done on it and you're quite behind sort of thing. And really, I think we can do a lot to sort of bring disciplines together and make one discipline benefit from another. And really that's the whole nexus of the work that we do, really bringing different disciplines together and sort of looking at holistic aspects, so productivity, cost to benefit ratios, greenhouse gas emissions, biodiversity and that kind of thing. There is a lot more detail than what I'm going to talk about today, and that is online in that publication. Hopefully that it will be published soon. That's under review, but that should come back from the journal any day. The farm, as I mentioned, is in northern Tasmania. It's Sam Trathui. It's near Deloraine. He is an advocate of regen ag, so he has smaller paddocks, he does a fast rotation, he has multi-pasture species mixtures, he doesn't apply synthetic fertilisers, he applies manure, and so he was very interested in using biochar, and I think his father was good mates with Stephen, and hence the connection there. And so we did the experiment with him on his farm, and thanks very much for his input into this experiment as well. So initially what we did is we just had it ad lib. So we just put it in these little troughs, which were sleds. We added salt at the beginning so that they got the taste of it, and then we eased the salt out of it. Animals like humans like salt and sugar. And then we backed the salt off so that they ate less. We pulled the sleds from paddock to paddock just with a four-wheel motorbike, and that was at the start of the experiment. They were just calves, and they were just coming up and having a nibble on it. They didn't really eat much. Particularly as we got into winter time, so we had sort of rainfall sort of go into the trough sort of thing, and didn't really have good drainage, so the biochar got wet. People don't really like to eat soggy toast, so you can imagine the cattle didn't really like to eat soggy biochar. So we converted to these covered feeders, and they've sort of got the baffles there, and it's just gravity fed, and they put their heads in underneath, and it sort of just filters out. And consumption did actually go up, but they didn't really eat that much over the duration of the experiment. I think it was about 30 grams per head per day, which is about 50 mils, which is not that much. Lower consumption in winter, but that was partially because we had the feeding thing, and we had greater in spring. We did look at pasture biomass, so this was on a commercial farm. So the biophysical side of things and the live weight side of things was only part of what we wanted to look at. We also wanted to bring along farmers to hear from them as well, to hear from Sam, but to also hear from other farmers what they think of the practicality and the cost, and the labour, and the whole holistic point of view, I guess. So we looked at pasture biomass because the animals, we only had 2 treatments. It wasn't a full replicated scientific experiment. So we measured pasture biomass to ensure that the live weight gain wasn't confounded from the pasture composition or biomass. The experiment finished a little bit earlier than what we would have liked. It finished in February 2023. Again, commercial constraints sort of thing. He had to sell the cattle, so we sort of probably finished a bit earlier than what we would have liked to have done. The farmer actually said in his words that the biochar cohort were less scary. That's anecdotal. And he also said that the biochar cohort lost their winter coats earlier. We didn't really do any physical measurements on it though, so he was quite partial to it. We looked at organic carbon content in the manure, which is that graph on the left-hand side there. We didn't really see any differences, but the sampling regime, we probably could have done more of that, I guess, to make that more rigorous in future, but that was just indicative. I think the animal live weight side of things is probably more rigorous. I'm wondering whether I can get that laser pointer to go across. So we started off with 160 animals in each cohort at the start. So the control ones there are the open points, and the black points there are the biochar cohort. And so you can see that both cohorts gain weight over time. Over time, the biochar cohort did gain weight at a slightly faster trajectory than the control cohort, and by the end of the experiment, the mean of the biochar cohort was about 5% greater, and it was unfortunate that we had to finish the experiment at that time. So it did actually look like they're starting to diverge. So it would have been interesting to continue that for longer, but we sort of raised more questions that we answer, so it was a good opportunity to continue that line of research in future, I guess, but I would say it was promising. If you look at the literature, the scientific literature, different sorts of biochar have an effect. So there was a paper on biochar made from rice husk, and what they showed was a 24% live weight gain after about 56 days. Different sort of cattle, different environment, different feeding intake, of course, but their result was significantly different to ours, and that was because the cattle actually ate more rice straw. So it's not that the biochar itself has any energetic value, but it has an interaction with the feed that they do intake, so it causes them to eat more. So all I'm really saying is that yes, it's prospective, not definitive, but would be good to investigate more in future. As I said before, a large part of the experiment was the social side of things, because you can have all these numerical results. You can have cost to benefit ratio, greenhouse gas emissions, soil carbon, but none of that really matters if there's some other, if the knowledge that you require to adopt it is not there, or the skills that you need to adopt it. So we looked at the social side of things as well. We had workshops on farm with farmers who have already fed biochar, who have been feeding biochar, some of them for up to 10 years, and they feed it in a very different way to what we did in the experiment. Some of them mix it through the feed ration in their feed wagon and feed it out to them. And so we brought these groups of people along to hear from the farmer themselves, but also to hear from what the actual people thought. Possibly in a way we were preaching to the converted, because only the interested people come along, but I think they are really valuable. We also did follow-up surveys, so we got the contact details of the people that attended, and we followed up 12 months later, so we called them up on the phone, and we found that about 10 people, after having attended those workshops, had begun feeding biochar as a result of what they'd heard on the day, so that was promising. One person said, and this is quite a salient point, I think, anything you want a farmer to adopt, you have to take a job away. As soon as you start adding jobs, it becomes very difficult and hard to justify, because we're busy enough as is. So unless you make serious weight gain, and what he really means there is opportunity cost, because we're really busy and you're wanting us to add a job, and you're really going to have to take something away. So what you're really talking about is the marginal gain in the change versus the marginal loss, assuming you're going to take something away. So that's the same as any farm intervention, and it's a very important point. We looked at cost to benefit analysis. Now that's a little bit of a horrendogram, so I won't go into the details, but suffice to say that profit was more sensitive to biochar cost in that analysis than it was to carbon price. Carbon price is shown in the rows, and that's probably because the biochar cost was more than the carbon price. Live weight gains dominated profitability, and biochar supplementation would need to elicit a productivity response of between 5 and 10%, or preferably more than 10% to be cost effective. That was just for the scenarios that we looked at, and we have those response surfaces there to look at, well, if you had different enteric methane mitigation or different live weight gain or different biochar cost, how would the profitability sort of vary? And I think, as various people have mentioned today, the economic cost to benefit side of things is very important. The second part that I want to talk about, and this wasn't led by me, this was led by my colleague Sally Bound. She's based in Hobart, and there's a whole team of people involved. It was called the PIPS program, and that was using biochar as a soil amendment. So you mix it into the soil, and they compared that with compost application. So they did 10 tonnes a hectare of compost, sterilised compost, and the program was called PIPS. It was actually for apple and pear productivity, and they did an experiment with Fuji apples at Mountain River in southern Tasmania, and so they compared biochar incorporation into the soil with compost application with a control that was nothing. So they measured a whole bunch of variables. I won't go into the details. What they did show was that daily water use of the biochar supplemented trees looked to be less over the initial lifetime of the tree, but that sort of converged over the duration of the tree as the trees got older, and there wasn't a significant difference by the end of the experiment, but it was significant earlier on. Biochar and compost, or biochar per se, significantly reduced soil compaction and saturated water content, but didn't really have any significant impacts on soil moisture or aggregate stability. It did have a significant impact on fruit size relative to the control. Compost didn't, and when you add biochar and compost together, it had a significant impact on fruit size, probably because of the biochar. It didn't really have an impact on fruit quality, total soluble sugars. So that's really all I wanted to say, and now I'll just sum up. We saw that biochar increased live weight gain, but didn't really have any impact on manure carbon, but we could sample that more rigorously. The benefits of animal health are plausible, but deserve further investigation. Farmer feedback suggests that any intervention you propose adding to their enterprise should minimise management time. Carbon prices and live weight gains would have to be greater to be economical. Cost to benefit analysis is very important. More work on the feeding mechanisms, and this is true for all low emission supplements. How do you actually get it to animals at scale? Is it through a feeder? Is it through a trough? Is it through a lick block? Is it a supplement? Because the animals have to eat it, and paddock size interacts with that result. Impacts on enteric methane, very important, because we've probably heard about soil carbon earlier today, but enteric methane is the biggest farm emission, biggest agricultural emissions, about 70% of Australia's agricultural emissions. So anything you can do to reduce enteric methane, that's methane breathed out, would be beneficial. Biochar as a soil amendment had little impact on soil porosity or aggregate stability, but it did improve drainage and it reduced soil compaction, and they said that it increased earthworm burrowing and so therefore increased filtration. So you get all these interaction effects, and as in all of these things, it raises a lot of questions. Scientists keeping themselves in a job probably. More biochar is not always better, and they sort of said that in the low input fertilisers, and I had this discussion earlier today, biochar might have more benefit. In the high input, high fertiliser enterprises, biochar had less benefit because you're putting on a lot of nutrients anyway. So in all of these farming systems questions, it always depends on what you did before relative to what goes ahead, I guess. So history is always important. So thanks very much for the invitation to present, and thanks also to Meat and Livestock Australia, TIA, and Horticulture Australia for funding the research that I've talked about. Thank you.
Thank you, Matt. What a surprise, they've muted me again. Thank you, Matt. Thank you, Matt, for that presentation. That was really great to hear. And the most important thing is it's raised these questions and it's given you and the colleagues that were involved the experience with biochar. And so we really trust that you'll continue that. And every time I hear you talk, it makes me more and more motivated to go and do that methane research with you. So thank you, that was really great, and a great roundup of speakers today. So once again, wanted to thank you all. It's discussion time now, and what do you know, we've caught up pretty much on time. So we've just got a bit of time for discussion. I'll cut that short. We've got 25 minutes allowed, but we'll cut it short because I can detect everyone's getting a bit worn out. But this is the most important part of the day, really, because as an outcome of the whole aim of this forum is to roll out our roadmap and scale up the industry based on my presentation earlier today, and you know, to remember the importance and the reasons why we're doing that. The reasons why is because Australia-New Zealand Biochar Industry Group says that the biochar industry can mitigate 10% of Australia and New Zealand's greenhouse gas emissions, and globally the figures are the same. So I'm sure in Taiwan the figures are the same. And so we want to do that, but at the same time while we do that, we create $1 billion of GVP for Australia, and we increase the productivity of agriculture, and we decarbonise industries and construction industries. So really now I want to hear from you all, and so I'm going to throw a question out there to our audience, and Craig's got the microphone, and if I don't get answers, I'm going to pick on you. So how do you see us connecting the industry together better? We've thrown out a few ideas there. And like, I'd really like to hear from you, from your organisation's perspective, about how, you know, you think, any discussions you've had today on how you might think that, you know, we can grow the industry together better. So does anyone want to start or kick off with a comment in that space? Thank you. Up the back here. Please, when you do that, just say your name and your organisation as well. No, other side. Thanks, Craig.
Thanks. Jason from Sustainable Timber Tas, work in the forest regeneration and plantation establishment area. This is just a general comment. Over the course of the day, the government, state and federal, aren't mentioned a lot, and I'm just wondering whether the industry is struggling to get interest and funding. It's a no-brainer from my end, from what I've seen today and listened to some very informative talks. I think going forward to generate, you know, that target endpoint, government's really got to be heavily invested in it. They don't seem to be anywhere near that point at this time.
So bring the microphone down to Steve. Thank you, Steve.
Yeah, look, my name's Stephen Sellings. I own a company called Expand. Karen gave a presentation today. I was pretty heavily involved in talking to a lot of the politicians. None of them are actually interested in it. The Labor Party said that burning is not a good thing. They see it as a vote against the general public in the city, so they're not interested in burning. They'd rather not have burning. This is the federal Labor. Down here in Tasmania, I spoke to Jeremy Rockcliffe at the field days. He couldn't make it. Spoke to all the politicians. They all had something else to do. We'd sent them out invites months before. The Agricultural Minister, her advisor had said that she wasn't interested, and when I spoke to Jane, because I know Jane personally through work that I did with Gallagher Group, she said, well, why wasn't I told? And I said, well, your office was, and your advisor obviously didn't pass it on, but he'd answered on her behalf. So there's a lot of issues there, and I think the money has really been going at Asparagopsis, the seaweed group, because that came out of that came out of the CSIRO, and they're pushing the money back through into other groups. And of course you've got the Macquarie Group, Macquarie Bank involved in there. So while you've got millionaire bankers involved, the politicians will follow those guys. So they get all the press. And I left a very large job with a corporate company called Gallagher, a privately owned company by Sir William Gallagher in New Zealand, with about 1,000 people employed. And I was a regional manager, so for 17 years I was teaching people about rotational grazing and grazing management systems. And I left that incredibly well-paid job to pursue biochar, because I see that we need this for our youth to have something to go forward in agriculture and in forestry.
Thank you, Steve. We might just leave that there if you don't have my microphones. Yep. So I don't know why this isn't working, but oh, here we go, I'm back on. So thank you. That was some really good comments about trying to get people here. But I just want to draw on some of the other experiences that we've had. And, you know, it's about it's developing that momentum. So I truly believe that the forums that we've had in each state are developing that momentum. So I ran the South Australian Forum, Craig ran the New South Wales one. As a result of the South Australian one, we had Invest SA, and we had a range of researchers in South Australia that's interested in talking about a biochar hub. Invest SA are looking at bringing different players together to talk about having a biochar research hub, and who knows what else in South Australia. And we have an opportunity to talk to the Premier's Climate Change Council about some policy we think would help scale up our industry. Now, each of the leaders of the state forums are looking to have a debrief on where to from here, and that's probably starting at local and state government, and then collectively at federal government. But we do have different tiers, our working groups that are all working on that as well. So it's step by step. I'd love to talk to you. I could talk more because I had that experience with local government and politics as well, but I also think it starts from the ground up, and we do have some momentum here today and some discussions that we've had separately. We've got Tas Water, we've got Sustainability Tas, and we do have some members that are looking to become politicians in the room. We've got local government here, so there's more here than you think that can create a little help with the next steps. So I want to do less of the talking and hear more from you. So would someone else like to make a comment on? Thank you. Maybe over here first, if we like, this man here in the orange jacket.
Thank you. I'm a physician, and I live in Tasmania. My name's Frank Nicholson. I've been very interested in things that end up in our water, either drinking water or irrigated water. And it seems like remediation of water is something that biochar is very important for. Worldwide, there's a pandemic going on in Parkinson's disease, and it's related to pesticides particularly. An additional concern is neurotoxins produced by blue-green algae, and I was particularly interested in Andrew Shipp's presentation, particularly around what he's done at Rotorua and the agricultural runoff. So it does seem another way that the industry has a role in this area. Maybe there'll be some comments about that.
Well, thank you. And if anyone else wants to add to that, please do. I think also,
say that in terms of the water industry, the biggest shift we've had is when you're not pushing your own wheelbarrow, when someone else is helping you. And the Water Services Association of Australia and all the water utilities have been a huge boon to our industry by working in the same direction. And so, for example, we've had Annette Cowie and myself have both been helped out, and a number of the board with submissions, including a presentation to the federal government. There's been a submission into the Circular Economy Ministerial Advisory Group for Tanya Plibersek. So there is momentum gaining, but the best way is having strong membership and strong MOUs with other organisations. So the more that we can have peak bodies, like we had the Farmers for Climate, Doctors for Climate, I'd love to see come into this fold as well. I think there's a lot of opportunity for that. And then once you've got that momentum that politicians will listen to, because that's politics. You've got what broader support and awareness.
Yeah.
I had a meeting with the former Minister for Environment a couple of years ago at federal level, and their view was it was a cottage industry and it wasn't going to have any significant sort of size or scale. When I told him what China was already doing and the US and Europe, they then went, oh, okay, right, well, can we have a closer look at it? And now the federal government on a number of groups are looking at that, and we're actually got the Climate Change Authority is engaging with ANZBIG at the moment about the potential for the industry to contribute towards CO2. So in the last newsletter, Don called for comments. So if there is anyone out there that still would like to have input, literally in the next day or two, if you could try and get something into us, we're trying to get something in for next week about the potential for the industry for drawdown.
Okay, thank you. Let's hear from some other people in the audience. Got some other comments over here. While Craig takes any other, oh, we've got one here, sorry, apologies. While Craig takes a microphone, just briefly, it's great to have a physician here. The heavy metals as well. Heavy metals is linked to Alzheimer's, isn't it? And so I take regular activated charcoal tablets myself because I've got, just because I know it's good for me. And I don't want to get Alzheimer's. Please, comment.
Thank you. I'd like to thank everybody for the response I got today. I was very surprised that I haven't done a presentation like that one before, and I was quite surprised at how it went. But what I would like to see with fire stick land management and the biochar are very, very closely related, and I hope to think that we can keep it that way. If we can keep the biochar and the fire stick land managed together, I think we might all go somewhere. Thank you.
Thank you. Agreed. Over here, thank you. Matt?
Yeah, I would agree with everything that's been said, but I don't think there's any one singular solution to the problem. I think you need both top down and bottom up. Top down being policy. You think about the soil carbon method, or the way in which landholders are paid for enrolling in the soil carbon method was through scientists chewing on a politician's ear, and become a method, and then everyone sort of become involved. So the economic side of things will be a big push. I know people talk about funding sort of thing. I don't have the answer to funding, but if you do get funding, you get people on board. Bottom up as well, so industry. You think about MLA, a lot of people on board with CN30, carbon neutral 2030 vision, mainly because MLA's got a lot of money, a lot of investment sort of thing, so a lot of research happening into it. So the money side of things, how do you generate income to stimulate research? So top down and bottom up. And probably the last thing I would say is I work for a university, partly, and if you could integrate some of this nascent research or biochar into undergraduate curricula, PhDs, for example, Melissa, you might get more of the next generation on board when you think about, getting biochar into carbon drawdown and negative emissions technologies.
Thank you, Matt. We had some other comments over here in the centre, over this way.
I'd just like
everywhere.
to say that, Matt, in my presentation earlier, I put my hand up as an idea, which you actually triggered, is to include biochar training and testing and education as part of the new TIA hub and the new Australian Forest Wood Innovation investment in New Tasmania. It'll be the first for Australia, and all of our team is geared to help with education for a new agronomic paradigm.
The Farmer's Guide, Matt, it's sitting there. You can use it to start your teaching. It's on our website. Okay, please, other comments.
Yeah, hi, great day today. I've learned a lot, got a lot out of it, and I'm sure we all have. I've got a program that I run, which is a community kiln program where I can lend kilns to communities. I run workshops, teach people how to make biochar. But the entry point for me is not about talking about biochar, it's talking about fire management and fuel reduction. And everyone's shit scared of the fire that's going to come through Tasmania or through Hobart. I'm a Hobart councillor, and it's always on our radar. We're going to burn as a city. And to get people engaged, I talk about fuel management, fire management, and we get a product of biochar. And when I leave your property, after I've helped you reduce your load, I give you $3,000 worth of biochar. And talking about it in a different way has helped me. I didn't understand the first 10 years of being talked about, you know, of biochar being talked to me, and I'm like, what the fuck are you talking about? And then finally, I saw a demonstration, and I got it, and I went, now I get it. And the way we communicate, like today was very data-driven and, you know, science-based, but for different audiences, we have to communicate in different ways. So I'm talking at a community level, and I'm working with the gardening groups, who are all fascinated because they want to grow better roses, and they don't realise that we're actually sequestering. Well, they do. They get it. They totally get that we're sequestering carbon, that we're creating habitat for microbes. They get that. But the inroad is not to just bang on about biochar, but to talk about the benefits of reducing fuel loads on your property.
Thank you. Good
Sell
comment.
sausage,
Thank
not
you.
the sizzle.
That was a.
No, the other way. Sorry.
Got a couple of other comments
Education is the highest initiative of the roadmap. Number one's get funding. First thing to do is education awareness, and totally agree. There's an education and communications working group, and we need as many hands on deck as we can. So if anyone wants to put their hands up, we'd love to have assistance with that.
Just need to be a member of ANZBIG first if you're already a member. That's great. Excellent. That's good to hear. We'll take a couple of more and see where we get to.
Yeah, g'day. I'm James Downey, a sheep and cattle grazier from Central Tassie, and thank you very much for today. Look, I'm just a little bit curious when you spoke about the 500 million tonnes of potential biomass, and then looking at the current capability of actually processing it. You know, we're talking about sort of half a tonne per hour per module. Yeah, so I guess my question is the practicality around, you know, you start putting an economic cost on freight of, say, 20 cents a tonne kilometre. I mean, the sale's $500. I'm just toying a little bit with the economics of it and trying to make sense of how this scale-up works. Actually, you know, getting huge amounts of volume to a plant and making it viable. I'm just toying with that one. I just wondering if you had any comments or strategies around that, particularly forestry and ag broadly.
Okay, thank you. That's a really good question. I mean, I'd like to have a go at that because I have done a lot of thinking in the space and business case development and consulting on this. So, I mean, on the ANZBIG website, which will be much clearer in the next 2 or 3 months when we roll out all our memberships and who does what, so we're going to have different pages for the technology providers and biochar users. Each project is fit for purpose, and each project, as you've seen today, has really completely different applications. We heard from you know, the likes of what Rainbow Beta are doing with a range of char cells and heating glass houses, to you know, what's happening in Taiwan with their batch systems and what they're doing and how they're combining that. And so it's really, I mean, that's the problem. Is part of it is that it needs it's problem solving to link things up. But the other part of this aspect and the reason I think why we need these regional and state-based hubs is because we don't want to be moving biomass too far because of the carbon footprint. So it's essentially recycling carbon, and the more you can do it in your own catchment, the better. And in fact, with soil carbon, if you make and use the biochar in your own catchment, you can put as much biochar as you want on the soil, but otherwise under the Australian Carbon Credit Scheme, you can only put 100 kilos on. So it's about problem solving. So some of the larger dairy producers I'm consulting to as well, they've got some dairies are going under roof because of climate variability. And they need heat to power the under roof barns and energy, and they can feed biochar to their animals to reduce the acidosis, and then they can collect the manure and spray that back out on the pastures. And so, you know, that's an example. The cereal producers, it's another one. You know, that's our second largest amount of biomass. Cereal producers themselves might choose to make their own biochar from their waste biomass and put it back on their properties. So, you know, it ranges from large-scale systems. You know, in some forests, they find that the carbonators are better because you can go into forests and harvest the waste. But in others, you know, they've been solved by having localised systems in throughout the forestry, combined with companies that need the heat energy, that take the heat energy off, and then the biochar is used for various purposes. So they're all fit for purpose, and they require problem solving. And if you've got, you know, you just got to have a look at what's your biomass. I mean, sometimes a project starts, it can start in a different way. You might have a need to decarbonise. You might have a biomass problem. you might have a productivity problem. So it's really trying to solve that question. I guess I often start with the end use of the product and then look at the potential biomass and what system you need to do that. But everything needs a life cycle assessment as well. So they're not easy projects to put together, and there needs to be more consultants that do it. And I've been snapped up by a company to do that for them for their technology. There needs to be more in that space, and to grow that. Hopefully that answers the question. Any other comments?
I might just add to that.
Yes, please do.
So typically the economic radius is about 60 to 100 k's for a commercial plant. You can double that economic radius through torrefaction, where you can keep about 80% of the energy and halve the volume, and increase the transportability. So there's a few things like that where you start looking at biohubs and regional. But when you want to look at, it depends on the masses. Like if you've got a small amount, but there's a lot of you could look at that kind of stuff. And aggregation is a key thing. But the low-hanging fruit is where things are already aggregated. Landfills, like waste systems that are already doing that start there. But in terms of on-farm, it may well be that you can make your own and use it there. And that's when there are potential for credits and things like that a lot easier. And it takes away a lot of these waste and regulatory barriers that are there as well. And you can do that at small scale. There's a great paper by one of the world-renowned biochar people, Hans-Peter Schmidt, 400,000 pyrolyzers to save the world. It's worth having a looking at that one, because he's basically talking about having small scale, the sum of small parts adding up to a very large amount. There's an online question too from Annette, I believe. No, is it?
Well, we got that there, Don? You got a question?
It's a question
it's
from
up
Matt.
here. Okay.
What was the...
Could I ask Matt what the type of biochar and rate were for the PIPS experiment? Sorry, I didn't catch those details. There are a range of reasons why it's hard to get traction for biochar and policy makers. Okay, have we got that? We're just trying to focus on the roadmap discussion at the moment, if you can keep that one short. Otherwise, you might be going to take that up with Annette.
I can you hear me now? No.
No, we can't. Maybe just give him the microphone. Yep.
I think they mixed 5 kilos of biochar with a soil core. So I can give Annette the details of Sally Bound or her email, and she can follow up.
Fabulous, thank you, Matt. All right, we might have time for a couple more comments before we close up. We had another comment over here, Craig. So, Craig, over this way. I've got another comment over this way. Thank you.
Thanks. Tim Schmidt from the Australian Hemp Council. We're focused on a campaign to bring about legislative change for the hemp industry, but one small component of it is relating to carbon. In fact, we segmentised one of the groups into that. I just wanted to mention that we're trying an initiative where we want to establish some research. We've got the Tas Feedlot are very keen to do some biochar and methane emission work. We're working with UTAS to get them involved, looking to draw on Tas Farmers Beef Trust. Going to try and get some funding from the state government, and the key is to have all those components, all those players involved, so as to provide further credibility. And the basic plan is to replicate work that's been done up at Lismore, at Murray Seeds, which has shown some very, very promising results, and to add credibility further to the industry.
Thank you. All right, we might just have that last comment from Duncan, and then we'll move on.
Yeah, Duncan Farquhar here. I'm Executive Officer of the Soil Carbon Industry Group, and I'd just like to congratulate the ANZBIG for developing the roadmap. It's great to be very clear on where Team Australia for biochar is heading, and it'll enable organisations like Hemp and the Soil Carbon Industry Group, the government, a lot of other people to coordinate with where this Team Australia for biochar is headed. We'd love to see it be economic at scalable level at a paddock, and but we've definitely got the forum for the conversation. So yeah, congratulations to everyone involved.
Thank you, Duncan. That's a really great end comment. And before I introduce Craig to talk about the Biochar Pledge, the roadmap is an industry roadmap, but it's not just about the members that we have. We need to grow our membership to do that. We've grown in the time that I've been on the board from something like 60 members to 200 plus members. We hope that we can continue that momentum. If you're not a member of ANZBIG at the moment, now's the time to become a member, because not only will you become part of an industry and a community of practice, if you like, and learn a lot, you'll also be able to advertise your services and your goods and whatever you have. Again, ANZBIG itself isn't going to be able to do this alone. We require, it's other people are doing research in the space, like the MATs and the other universities. It's the people that we just heard from that have got their own backyard kilns that have those other conversations. If every one of you goes away and has conversations, that will also help grow the industry. And that's what networking is about. That's what these forums are about. We hope to continue to roll them out and have. We've got our national forum coming up. Please keep an eye out for that. That's likely to be in late October or November. We do need to be clear about it. That ANZBIG is not going to do all of this, but if you're looking at projects or anything else, ANZBIG looks to partner with you on that too. And if there's an opportunity for us to value add what you're doing, we will do that. We've got such great knowledge of our working group, 60 plus members working groups with people with PhDs. We've got lawyers, we've got accountants, we've got farmers, we've got a whole range of different people with a whole range of skills. And an army wasn't built in a day, but we have an amazing community and an amazing army that's going to keep growing. And so I really thank each and every one of you for coming and listening today. A huge special thanks to Karen for her tireless work. I know she'd be absolutely exhausted, and Steve for what you've done to pull everyone here today. It's no mean feat, and it's incredible what you were able to pull off. So thank you so much, and a big round of applause. Thank you as well for Don for everything that you do in the background. Don's the originally founding member of ANZBIG and really has got ANZBIG to where it is today. And he's just done a huge amount for the industry, so we really thank him. Thank you, Craig. Now I will. Oh yes, well thank you, Sam, for everything you're doing in the background, for our tech guy as well, and anyone else that I haven't mentioned to thank today. I thank you if I've forgotten anyone. So yeah, just want to hand it over to Craig now to close and talk about the Biochar Pledge. But please look at becoming a member. Just go to our website and keep an eye out for our forums coming up, and a whole range of webinars. We've got lots of events coming up as well, so just keep involved. Thank you, Craig. Over to you.
I'll use that segue too in terms of the roadmap and the sponsorship and the pledge, but also with membership, with the research organisations that are here. We have a student membership, and we'd really like to encourage, there's a good point there about trying to get the next generation to take this through. We very much would like to try and see a lot more student memberships. I've had it my way, I'd like to see even school kids become members, because it's actually those kids that are marching the street on climate action that are going to be the next generation to take this forward. And they're the ones inheriting the problem unless we fix it, so very much support that. Okay, under the roadmap, we've developed a pledge, and I guess this was basically just to allow people to formalise an involvement with ANZBIG and the roadmap to where we're trying to build to execute it. I apologise, I'm just going to have a look here because there's actually a part to this beyond the pledge itself, where what people will get out of it. We basically have two levels of the pledge, so this is a general wording of where we want to we see it commonly, but there's a Friends of Biochar community, and under that we have names added to a register as the Friends of Biochar monthly newsletter and a logo associated with it. And then there's a pledge partnership as well, and that's where under that roadmap there'd be recognition on our website as a pledge partner, a logo and certificate to display at your office, and engagement opportunities through the roadmap events such as this. and of course announcements in our online monthly newsletters and social events, so and social media. The other thing, of course, is that the roadmap itself is not a static document, it's dynamic, and one of those things is we're building that support, and all those questions about how do we get the government to support it. When they see a unifying document that is a snowball to turn into an avalanche, hopefully, it's through actually showing that support in it. So you'll see when you open up the roadmap that there's a number of logos in there and different levels of roadmap sponsorship. There's an opportunity for your organisations or all the way through to individuals to be supporting the roadmap and be recognised and add yourself to that voice to call for funding for it, because at the moment ANZBIG is 100% volunteer run with the exception of one full-time equivalent position. If you're trying to fight climate change, you need an army on the ground, and it needs to be paid because volunteer organisations crawl, and at the moment we're basically a charity until we can actually really get funding towards to the roadmap to do seriously accelerated work. So I'd like to basically encourage everybody, that's on our roadmap tab on our website, anzbig.org. Please have a look at that and consider becoming a pledge partner, and consider possibly endorsing the roadmap either through a pledge partnership, or if you're happy to sponsor, let us know. We're literally about to do an update on the roadmap, so it's a great time to get your logo in there if you're interested. And otherwise, yeah, please just join as a member and get involved. If you want to be part of the team working on it, we could do with that army growing. We've got 60 people that are doing a lot of active work, but a lot of those are overlapping through a lot of those working groups, as you might have seen. So we could do with a lot of help, and there's a couple of working groups in particular that could do with some more hands. So if anyone's interested after today and you're inspired, please come and see myself, Karen, Mel or Don, or anyone else that you might know from ANZBIG. Thanks for your time, and big congratulations again to Karen, who I will let do the last word.
Thank you so much, Craig and Melissa, Don, my team members. Yes, as I said, I'm just a young, not so young now, but as a young girl, I never thought I would be here and be able to engage with such exceptional people in the audience. So thank you so much. I'd particularly like to say thank you to Marie Yeh, who stepped forward very, very early on last year to put a hand up to help with this forum as in a working group. And I'd also like to very much thank our sponsors, Tim and Phil and Graham, and haven't actually had a chance to meet you yet, but the Sustainability Timber representatives also in the room. But most importantly, say thank you to Steve and Christina, everybody that presented today, an exceptional lineup. I'm very proud of you and very proud to be a part of this wonderful team. So all the best for the future. And as a way of saying thank you for enduring all of these presentations, we would like to offer you a drink, and finally, big sigh of relief, it's over. So please join us after.
Apologies, I'm bossing everybody around as usual. Thank you, Karen. And so drinks are outside. Just the dinner details was the last thing. Do we have the details of where to go to dinner and what time of those that are coming?
We'd just like to we can go over. So everyone's welcome to join us at the Miwa restaurant. We have a private room. We've never been in the private room of the Miwa before. So that's a very famous Chinese restaurant just across the road. So we have a few drinks here, and then you're welcome to come over for a banquet and continue to network, which I'd love to do. That's the whole aim of the forum, is to bring people together. And just to mention, it is a banquet.
Best Chinese restaurant in Australia. Steve sold this to me last night, so I think say what you told me.
If you haven't been to the Miwa, it's one of the best Chinese restaurants in Australia. And when Sir William Gallagher used to come to Tasmania, he used to say, "We're going to the Miwa." So it's right up there.
Thanks, everybody.